Welcome to Karparo and welcome to my course on Java Programming Masterclass, where you can learn complete end-to-end Java programming from scratch. This course is for you if you're planning to start your career as a software engineer, or you want to clear Oracle Java certification exam, you want to build Android or dynamic web applications, you are a tester and you now want to move to development role, you're a passionate learner like me, or for any other reason. A quick introduction about me. I've been working in IT field since 2007 and I've worked for many reputed multinational corporations as well as on freelance projects. I've also trained and mentored thousands of individuals worldwide, and I've helped them achieve their career objectives like clearing certifications, getting a job, etc. I've also contributed to many open source projects, which also includes Java and Spring ecosystem projects. But more than anything, I'm a vivid learner and a passionate teacher. Few highlights about this course. The course syllabus is inspired from some of the popular books as well as online courses, plus my own experience in dealing with real-time projects. So you don't have to refer to any other books or online courses. You can just stick on to this course and you will learn everything. This course will cover complete end-to-end Java programming with over 200 plus concepts in 20 plus hours, and this also includes all the latest features of Java. Not to blame anyone or something, but I've checked some of the existing Java courses on YouTube. Some of them are even 10 hours long, but still, they're just covering few basics. They're not covering the entire syllabus, and I'm not even happy with the way things are explained or the syllabus that is covered. But this course will cover complete end-to-end Java programming. I've given a lot of emphasis to the topics that are crucial for interviews or to work on real-time projects. This is a must-take course if you're planning to become an Android developer or data engineer or software engineer or any such roles. But above all, I have the unique ability to teach very complex concepts in easy to understand manner by taking real-world examples. You will know what I mean once you go through this course. This course has received loads of positive reviews from my students, and some of them have seen some great results. They really make my day. People who completed this course have seen some great results, like they've gained confidence in writing code. Some of them have successfully cleared Oracle Java certification exam. Many have cleared coding interviews in Java. I've seen people moving to development roles after taking this course, and many more such results. And I'm sure you can see such results as well. This course is originally priced at $89 on my own website, but I'm pleased to tell you that you're getting this for free of cost without any restrictions. I do really hope that you take this opportunity and learn Java programming. Finally, before we proceed with the Java course, I'd like to share a few tips for your own benefit. Avoid distractions, especially if you're watching this on YouTube. YouTube will keep on recommending you some videos. Don't click them. If you click them, then you'll be lost into a different world altogether and you will lose track of this course. Stay focused. This course is like 20 hours long. Just dedicate 1 hour every day for next 20 days and you will learn the technology. Learn from beginning even if you know something about Java. If you know something about Java, you may tend to skip the initial few lectures. Don't do that. Start from scratch and you will benefit from this course. Watch the complete course without skipping any parts. Otherwise, I cannot assure any results. And once again, you don't have to refer any books or other courses. Just stick on with this course and you will learn Java. Finally, I've also kept some useful links in the description. Do check them out while you watch this course. I wish you happy learning, but before you continue watching, do hit the subscribe button and click the bell icon. And also, do share this course with somebody who is willing to learn Java programming. It took me years to create this course, but I'm giving away for free of cost. All I'm asking you is to stay dedicated and watch this course completely for your own benefit. I sincerely hope that this course will help you excel in your career So with that in mind, let's get started learning Java programming. I will see you in my next lecture. Let us try to understand where Java is used. I think it's easier to answer where Java is not used because there are so many things you can do with Java that we simply cannot list everything in here, but I'll try to list a few of them. Java is the most popular option for creating enterprise web applications. If you're wondering what is a web application, assuming that you're a beginner, then a web application is something that runs on a browser and can be accessed by multiple users across the globe over the internet. Some of the examples are like flight booking system or a banking application or maybe an e-commerce website, etc. They all fall under the category of web applications, and Java clearly is the market leader in creating web applications, especially some of the financial management applications where security is the utmost priority, like banking application for example, where you need to perform secure transactions. Java is used for creating Android applications as well. 80% of the smartphone market is Android, and majority of those apps are developed using Java programming. Java is also one of the popular choice for creating standalone applications. Some of the examples are like you have Notepad or Photoshop or some audio editing software like Audacity, etc. Java is one of the popular choices for creating standalone applications like that, although C++ is also one of the popular choices. Java is also used inside embedded devices like remote control, TV set-top boxes, etc. And with the Java 9 module system, things have become much easier, which makes Java even more compatible with embedded devices. Although C++ is primarily used for game development, Java is nonetheless, it comes next to C++. And one of the popular games that I know of and that is developed using Java is Minecraft. And obviously, majority of the games that you play on Android devices were actually developed using Java. Java is used in scientific applications as well. As you might know, for scientific applications, performance and speed are primary concerns, and Java perfectly fits into that groove. Java is also used in automated teller machines. When you withdraw cash from the ATM, the system would make sure that it will deduct that much amount from your account before dispensing the cash, and even send you an SMS regarding the same. Well, that logic is written using Java. Java has a huge market share in big data segment as well. Some of the popular tools that are developed using Java are we have Hadoop, Hive, Spark, etc. Without these tools, there is no question of performing analytics. Although R language is the popular choice for machine learning and performing data analytics, Java is nonetheless is also one of the popular options. Java also has some pretty good libraries to support machine learning and data science, and to perform things like data mining, data analytics, predictive modeling, etc. Java literally left no stone untouched, and it has also gained traction in IoT segment as well. So if you learn C++, then your career options might be limited to game development or creating standalone applications. Or if you learn R language, then your career options could be limited to data mining or data analytics. But if you learn Java, you have all these career options. And for that reason, as per the data from Indeed and Glassdoor, Java has the most number of job openings than any other technology. And this is as per the Medium.com statistics. The demand of Java among all other programming languages is the highest. And the average salary for Java developer in USA is around $102,000, which is 77% higher than the average salaries. Java is secure, robust, reliable, dynamic, and scalable language, which will make it the best choice for developing enterprise web and mobile applications. Some of the popular global investment banks like Goldman Sachs, Citigroup, Barclays, Standard Chartered, and other banks use Java. Android takes about 82% of the smartphone market worldwide, and Java is the official language of choice for developing Android apps. Here are some of the popular websites that are developed using Java. We have LinkedIn.com. We also have aws.amazon.com. I'm not sure if you're aware of AWS, but this is a huge project and the entire AWS application is developed and powered by Java. Similarly, we got other popular websites like aliexpress.com. We got irctc.co.in, eBay, Best Buy, OpenCart, etc.
Before we move ahead and explore the concepts of Java, let us see some of the prerequisites for this course. Let us take a look at skill requirements. Since this course is primarily meant for novice programmer, I'm not expecting much from you, but I would expect the following. I would expect that you know how to install a software. Some of the examples include an antivirus software or any photo editing software like Photoshop. If you have ever installed operating system like Windows or Mac OS X, then you are more than qualified for this tutorial. I would expect that you know how to use a word processor like Microsoft Word, Apache OpenOffice Writer, or Google Docs, etc. If you know how to write emails or send Facebook posts, then you're fit to learn Java. Now this is the toughest of all the required skill set. I would assume that you have some understanding on some of the major components of a computer, like RAM, processor, hard disk. If you don't know any of these, I would encourage you to go explore them a little bit before you plan to learn Java. And finally, although not required, having the skill of typing will be additional advantage. Apart from skill requirements, there are a few software and hardware requirements, termed as system requirements. If you've been using Windows operating system, then these are the minimum configurations required. You have to have processor of at least 266 MHz. You need a disk space of 126 MB. You need to have a minimum RAM of 128 MB for Windows operating system. And the following browser version supports Java: Firefox 3.6 or above, IE 7.0 or above, and all versions of Chrome supports execution of Java. And these are all various Windows operating system versions that support running of Java program. If you've been using Mac, then apart from the above mentioned hardware requirements, you need to make sure you have an Intel based Mac OS X of these versions and a 64-bit browser. You may run into problem if you have old MacBooks with PowerPC. So if you purchase your Mac after 2006, then you don't have to worry, because it was after 2006 Apple started integrating MacBooks with Intel processor, before which it was PowerPC. If Linux is your operating system, you need to have a minimum RAM of 64 MB, disk space of 58 MB, Mozilla browser, and all the following versions of Linux supports execution of Java program. Also note that these are all minimum configurations required to run a Java program. If we want to develop and run high-end Java applications, you would probably need more resources than I had just mentioned. Now you don't have to go check your configuration details to make sure your computer supports Java. If you're able to purchase products online or play games online, or even if you're able to view this video on your computer is already supporting Java. Your process speed must be in gigahertz, your RAM must be in GBs, and your hard disk can even be in TBs or terabytes. This is just for your information. Okay, let us see some of the possible misconceptions in Java, just to prepare your mind for the rest of the course. You need to be good at math to learn programming language. This is so not true, rather funny to state that one would need a math background to understand Java. In fact, in my experience, I have seen people coming from chemical background performing well in Java just as any other person who had scored well in their math. So don't be misled with that statement. You need to learn C language before learning Java. Having knowledge of C language or any other programming language to learn Java would be advantageous. But C is definitely not a prerequisite for Java, which means you can learn Java without knowing anything about C language. Rather, I would say it depends on who is teaching you. At least for my course, I'm not expecting any prior programming language skill. Course complexity increases chapter by chapter. No, course complexity never increases as we progress. As a simple example, let's say you're planning to learn swimming. Now swimming for even 25 meters or so is a great deal for you. But once you know how to swim, you can even go for 50 meters effortlessly. Like I said, this course is structured in such a way you will never feel like you're actually dealing with complexity. Java has a very vast syllabus. True, Java is a very vast syllabus, and so is any other programming language. But why do you want to learn everything? You just need to know just enough Java to be able to stand on your own legs. Nobody in this world knows everything in Java, including James Gosling, the inventor of Java. I bet even an experienced Java professional will struggle a lot if we disable Google from his life. So don't worry. Now let's take a look at some of the tips. Tip number 1, practice. Tip number 2, practice. And finally, tip number 3, practice. No kidding, it's important that you practice everything you learn. By the end of each chapter, do experiment with your skills. Success or failure is a different matter, but please don't fail to try. Believe me, it's worth spending time on practicing. I will guide you though. So the million-dollar question, what is Java? The simple answer would be, Java is a programming language and a computing platform. So what exactly does that mean? Let us first understand what platform is. Let's say you bought a new computer, and as a friend of yours, I give you a few softwares and games. I give you one Photoshop, Chrome browser, and Need for Speed racing game. Would you be able to install these softwares or play games? No, because your softwares does not know your computer and your computer does not know your softwares. They both are strangers to each other. Now we need to somehow introduce both these strangers to each other and develop friendship between them so that we can play games. So we need to hire a guy who does that job. Any guesses? He is none other than the operating system, like Windows or Linux. So if you see, operating system is acting as a platform on which we can run applications or play games. Now I hope that you got some idea on what platform is. So just as operating system is there to run applications like Photoshop, NFS and Chrome, Java platform is there to run Java programs or Java applications. Except Java platform is installed on operating system just as any other software. And this is the very reason why Java is said to be portable. We'll talk about portability later. Remember, I said Java is also a programming language. These Java applications must have been developed using Java programming language. So depending on the context, you need to determine what Java is. Java is a platform on which you can run Java programs or applications developed using Java programming language. Now let us take a look at some of the categories of programming language. We have high-level programming language. These are somewhat closer to human readable language and are hence easy to learn and easy to code. Most of the high-level languages are portable or platform independent, which means You can write your program once and run it anywhere without having to worry about the operating system on which you're running your code. One setback though is that high-level languages are relatively slower compared to low-level languages. One major reason is due to the conversion process, which converts the code that you write to the code that machine can understand. This process abstracts a lot of low-level details for the convenience of the programmer. This would be minimal in case of low-level language. So more the language is closer to human natural language, the slower it becomes. C++, Java, PHP are some of the examples of high-level language. Coming to low-level language, these are somewhat closer to machine language, I mean zeros and ones, and hence humans find it difficult to understand and to code. These languages are often dependent on platform, so the developer have to keep in mind on which operating system he is really willing to run his program. So if he writes a piece of code for Windows, there is no guarantee that it runs on Linux. Developers have to amend the code to get it working for all operating systems. And since these languages are close to machine-readable language and mile away from humans, they run faster compared to high-level languages. Assembly language is one good example. And middle-level language lies in between high-level language and low-level language and are neither close to human nor computer. They stay in between the two. A good example would be C language. Although you can write code which is somewhat closer to human readable language, you can also access memory using pointers, or you can even write assembly level code using C. You must be glad that Java is considered as high-level language though. Let us spend a couple of minutes knowing the history of Java. I'm not going to spend a lot of time in this as it does not really help us in any way except for interviews. So here is a quick history of Java. It all started in 1991 by a small team called the Green Team from Sun Microsystems. James Gosling, along with his team members, had a vision to create a language which is architecture neutral or platform independent language that can be embedded into electronic devices like microwave, remote control, etc. This would certainly help some set of programmers who write code for electronic devices. But in the meanwhile, there was a huge demand for the platform independence even for internet applications, because internet was booming by that time. So now obviously all that Green Team had to do is to say goodbye to a small set of programmers for electronic devices and say hello to web developers. Since then, Java started advertising itself as Vora, which means write once, run anywhere. And obviously this has attracted a lot of frustrated programmers and contributors. In 1995, Java was first made available to public. The main intention was to get a direct feedback from programmers and general public. Later, in 1996, Sun released the first official version of Java. JDK 1.0 stands for Java Development Kit, which has all the tools and libraries essential for programmers to start developing Java applications. And they made it available for all major operating systems. Since then, Java continuously evolved release by release along with industry demands and requirements. In each release, they fixed the bugs in its early release as well as they introduced some new features. The following is the release history. So if you notice, from release 1.2 to release 5.0, the name changed from JDK to Java to Standard Edition, or J2SE in short. And from release 6 to 8, it's simply Java SE. Now although we can spend some time in knowing the features introduced in each one of these releases, I feel it's not worth the time as we have a lot of good concepts to cover. Let's preserve our brain for some interesting concepts which will come shortly. Let us take a look at one equation in math. A equals 10, B equals 20, C equals A plus B. What's the value of C? Did you say 30? Okay, well done, you really deserve a standing ovation. Now one more question for you in computer language. Did you get anything? You probably wouldn't. I just asked you, if A equals 5 and B equals 5 and C equals A plus B, what is the value of C? The answer is 10. You may find it impossible to read and understand, but it's very easy for a computer to understand. And it's mere impossible for a human to remember and code hundreds of combinations of zeros and ones just to write a small tiny piece of program. So we need to solve this problem and eliminate the trouble to write a program in pure computer language. Now how about introducing a translator between you and the computer so that you write your code like this and the translator will translate it for computer to this. And the translator in programming world, we call it compiler. So the compiler takes the input of a source file which has your source code in high-level language, and it will generate an object file which has numericals and characters in some weird sequence. For us, object file may look weird, but it makes perfect sense for a computer. And as we know, computer processors understand only zeros and ones. You need to have a C compiler to compile a C program. You need to have a C++ compiler to compile a C++ program. Similarly, we need Java compiler to compile a Java program or Java source file. Let's take an example. Let's say you wrote the following program in a file and you saved it. Let's call it a source file as it has the source code in it. In this program, we want to display the result of x plus y on your computer screen. Now this code has few bugs in it. The compiler will start the scanning and translate the source code to machine code from first instruction, which is x equals 10. And then it goes to line number 2, which is y equals 20. And then it reads display z. The letter z comes as a surprise for the compiler, because until this point it read variable x and variable y and know nothing about z, as the compiler did not read the line number 4 yet, where value of z is calculated. So compiler takes a note of this line number 3 and then it continues from line number 4. At line number 5 we have another bug. We are trying to display something that is not previously defined. Compiler takes a note of this bug as well and moves on and continues with line number 6. Now if you compile this program, you don't get the output you're expecting. Instead, you will see a message saying there are 2 bugs in your code, please fix them before you compile once again. So the programmer will fix the bug by removing line number 3 and 5 as they are not of any use anyways, and he compiles the program once again. Now your computer will run it and show the output you're expecting. It will be 30 and will be displayed on your screen. So the compiler translates your source code in one go and notifies all the errors it finds in the end. Once the compiler certifies your code that it does not have any bugs in it, your computer will go ahead and run the program and display the output as 30. Okay, good. Now let's see how the same thing is done in case of interpreter. Let us take the same code. Unlike compiler, where the program is compiled in one go and run in one go, interpreter translates the code line by line. Let me explain you what I mean. The first line says the value of x equals 10. Now the interpreter translates it to machine language, and then machine will run it the very moment the interpreter translates it. The machine will not wait for the entire program to be translated. Each line will be run by machine the moment it is translated. So now line 1 is translated and is run by machine. Line 2 is translated and is run by machine. When it comes to line number 3, just as compiler got surprised of letter Z, interpreter too gets surprised and reports the error immediately, and it won't further process the lines. So this time it asks the programmer to fix the bug, only then will it ever go to line number 4. Since this course is about Java, let's talk a little bit about Java compiler. In case of C language or any platform dependent language, the compiler would convert the source code directly to machine code that the computer processors can understand. But in case of Java, the compiler will convert the source code to an intermediate code that the Java virtual machine can understand. And JVM further uses some tools and utilities to convert the intermediate code to machine code that the native computer processor can understand and run. So you write your source code, it will then be compiled using Java compiler. This will generate an intermediate code that neither computer nor you can understand, but only a Java virtual machine can understand. You may wonder why we need to have intermediate code. I will answer it later. So until now, interpreter did not come to picture. Now let's say compiler did not find any bugs in your code. A utility called loader will load the intermediate code which is compiled to the Java virtual machine. Now the file is ready for interpreter to take. The interpreter will then read the first line, translate it to machine code, and then your computer will run it. Now it reads the second line, translate it to machine code, and then your computer will run it. It keeps on running till the end of the file or first occurrence of error. We'll understand more about interpreter when we cover the concepts of runtime errors or exceptions. In some languages, the source code in high-level language will be interpreted, not compiled. In case of Java, interpreter will not handle the source file, but it will handle the compiled code or intermediate code. Just-in-time compiler. Now you will better understand what just-in-time compiler is. Let's have a small program. Here, as you can see, that we are having 5 statements or 5 lines of code, out of which 3 of them are redundant. The statement display Z is written 3 times. The compiler will compile the code and generate intermediate code. Let's assume this is the intermediate code. Now when we run the program, the interpreter translates line by line and your computer runs them as and when it gets translated. But one interesting thing about this is that the computer will have to wait every time the interpreter translates each line. Whereas in case of compiler, there is no wait time, as the computer will get the fully translated file in one go. In this scenario, although we cannot nullify the wait time, at least we can reduce some impact using a technique called just-in-time compilation. The compiled code or intermediate code will go through the just-in-time compiler so that it will further optimize it. In this case, line 4, 5, 6 are redundant, and just-in-time compiler will mark this code as redundant. So when the file gets interpreted, the interpreter will now know that the code in line number 4 is going to come again. So it stores the machine code of line number 4 somewhere in the computer memory. And whenever it comes across with the same piece of code again, it will simply tell the computer to run machine code directly without translating. So there is no retranslation of same code again. This phenomenon is called just-in-time compilation, and this will significantly improve the performance. In reality, just-in-time compiler and interpreter will go hand in hand in Java and use even more optimizing techniques to increase the performance. So just remember, both just-in-time compiler and interpreter will come into picture only when you run the program. Now I hope I made myself clear in explaining what compiler is, what interpreter is, what just-in-time compiler is. If you're still unclear about any of this, don't panic, it's very normal for beginners. Just try to view the video once again. If you still don't get it in second time, no need to worry again. Just move on to my next videos and revisit this video later. Okay, we've been hearing terms like JDK, JVM, JRE, and there are a dictionary of such words which kept annoying us. Now let's try to uncover a few of them. We've already talked about JVM and just-in-time compiler in our previous video, so I'm not going to talk about it again and waste your precious time. But one thing which I wish I should have mentioned you in my earlier video is JVM have multiple vendors. Sun Microsystems has their own version of JVM. Similarly, there are some other vendors who claim that their JVM is better than their competitors. So each JVM is different. Some may use interpreter, some may use compiler, and some may use both. So if you got people saying JVM uses only just-in-time compiler or only interpreter, they are all correct, because each vendor is having their own implementation of JVM. Okay, let's move on. JRE stands for Java Runtime Environment. The word itself says it's a runtime environment, which means JRE helps run the Java program or .class file to be specific. JRE is actually a collection of few tools, utilities, runtime libraries, and JVM, which together help run the Java program. If you just want to play games or use Java applications, you just have to install JRE. But JRE does not let you develop any Java programs. For that, you need JDK, stands for Java Development Kit. It has all the tools and utilities to help you write, debug, compile, and run the Java program. You're already aware of one of the tools that JDK has, the Java compiler. It also has debugger, which helps in detecting the bugs in your code, and a few other useful utilities. It also has JRE for you to run the compiled program. So yes, if you install JDK, it comes with JRE, so you don't have to install JRE separately. Okay, that's it. Let's keep things simple for now, as we are definitely going to uncover some of the interesting and annoying terminologies as and when we come across with them.
It's time to install JDK on our computer so that we can start writing Java programs. Installing JDK is same as installing any other software. What are you waiting for? Go ahead and install JDK. Okay, relax. Let me help you out. Visit their official website, that's www.oracle.com. Click on this menu, locate the downloads link, click on it. There are quite a lot of softwares offered by Oracle, but the one that we're interested in is Java. From this list, we want to download Java JDK for developers. We don't want to download JRE, which is a runtime environment. And as we had discussed before, if you install JDK, it comes with JRE. So let's click on this. And then download JDK. I've already done that. I don't have to do it again. Once you have this executable, just double click it. You may get a prompt that looks something like this. Here is the installation directory. If you'd like to change it, you can change it. But I would recommend you to just leave it to the default and click Next. It's going to take a while, so let me pause the video and then get back. Okay, we have successfully installed JDK on our computer. You can just close now. And if you go to the installation directory, you should be able to see all these files. In our next lecture, we're going to write our first Java program.
It's time for our first Java program. In this video, we'll write a Java program and run it. Let's take a look at the steps that we need to follow. Let me open up the notepad. Step 1. Write the source code on a text editor. Step 2. Save the source code as Java file. Step 3. Compile the source code and generate object code or intermediate code. Step 4. Run the program and display a message. Step 5. Get a sense of accomplishment. Okay, let's go step by step. Now, what I suggest you is don't just sit and watch me do this. Follow along and do exactly what I'm doing. This will help you even if you're an experienced Java programmer. So step number 1, write the source code on a text editor. I'm using Windows operating system, so I'm going to be using Notepad for this purpose. If you're using any other operating system, you can use something similar to Notepad. So let's open up Notepad and write our source code. Class, first app, opening and closing brackets, public static void main, and within the brackets string args. Make sure that you take care of uppercase and lowercase letters. For example, if you type string with lowercase s, your program will not work. Just type exact same code. You don't have to try to understand this code, but just write it. System.out.println, and then you give your message here. I'm going to be giving AP. It's working. Now all we are doing from this program is we're trying to show a text. So when we execute this program, we should see this string. AP, it's working. But before that, let's go to step number 2. Save the source code as Java file. Let's do that. So what we have here is a source code. Now to save this file as Java file, we need to append .java at the end of the file name. So we go to File, Save As, and type in first app.java. Make sure the name of the file is same as the name of the class. If you want to know why it has to be same, maybe the answer would be too advanced at this moment. But as a rule of thumb, always give your class name as file name. Let's save it in desktop. So we got our file created here. This is a Java file now. Let's move on. Step number 3. Compile the source code and generate object code or intermediate code. For this purpose, we're going to be using a tool called JavaC, which is a Java compiler. This comes with JDK. So let's open Windows command processor by hitting Windows key and then letter R, and then type in CMD. Hit enter or press OK. Now let's navigate to the location where JavaC tool is residing. So we go to cd is a command used to change the directory. CD stands for change directory. And then we go to C, program files, Java, JDK, and then we go to bin directory. Hit enter. Let me show you the tool that I've just talked about. Let's run dir, which shows list of directories and files in the current directory. So we should see JavaC here. So here it is, javac.exe. Now we're going to be using that tool to compile our source code, which is in desktop. We type in JavaC and then the absolute path of the Java file, which would be C, users, admin, desktop, first app.java. Let's hit enter. This should compile our source code and generate intermediate code. Let's verify if it has done that. We see a new file generated. This is nothing but the intermediate code that JVM can understand. Now let's move on to step number 4. Run the program and display a message. For this purpose, we're going to be using another tool called Java. So Java is the name of the programming language, Java is the name of the technology, Java is the name of the platform, Java is also the name of the tool used in JDK. So don't get over confused. Let's go to command processor. Luckily, Java tool is residing in the same folder, so we don't have to navigate to some other directory. So I type in Java, and then we need to specify the location of the class file by specifying class path. So that CP stands for class path, and the location of the class file is desktop. So let's specify that. C users admin desktop. Now we specify the name of the file, which would be first app. You don't have to specify .class here because the tool Java is going to consider only class files. Now if we run this, we should see our message. It worked. We see the message EP, it's working. Let's go to step number 5. Get a sense of accomplishment. I hope you're feeling so. Now I'm pretty sure that you might be having questions like, what is this public? Why do we need to write so much of code just to display a simple message? Isn't there a single command that helps us compile and run together? For all such questions, ladies and gentlemen, welcome to Java World. Now every time you want to compile and run the program, you need to navigate to this bin directory in order to access these tools, Javac and Java. To ease our job a little bit, Windows operating system lets us configure path variable. Let me show you what I mean. You right click on computer, click on properties, and then you go to advanced system settings, click on environment variables, and then we're going to be specifying a new user variable which would be path in capital letters, and then the value of it is the directory where the Javac and Java tools are residing. So that would be C program files Java JDK 1.8.0_51/bin, end with the semicolon, and then click OK, click OK, click OK, and then you can close this window. Now let's try to run this program. This works. Obviously we're in bin directory. Now let's try to run the same program outside the bin directory. So let's open up new command processor window. Now I type Java -cp for class path, C users admin desktop, then first app. Cool, we are seeing this message. This would not have worked without setting the path variable. So when we specify the word Java or Javac, operating system tries to search this tool in the current directory, which in this case would be admin. If it is not there, then it will refer to the path variable that we have just set. And whatever the path that we give in path variable, it will go and look into that particular directory. And hence, we got this tool working even though we are away from the bin directory. In this chapter, we'll talk about variables and data types. Take a look at these equations in math. Now, a question for you. What can I do to these equations so that I can improve the readability and decrease the amount of physical effort required? It's simple. I would just represent these numericals with letters. So maybe I would just call this numerical as A, and I would call this numerical as B, and this as C. Now let's see how the equations look after replacing numericals with letters. So this is how they look. Now the equations look a lot cleaner, more readable. Also down the line, if you want to write hundreds of other equations, you don't have to remember the numericals. You can just use the letters instead. So that will save a lot of physical effort as well. So what's a variable here? A is a variable here, B is a variable here, C is a variable here. So from this, let's try to form a definition of a variable. A variable is something that holds a certain data. In this case, the variable A and B are holding numericals, the decimal numbers. Now let's understand variables in Java. We have our first step program. Let's use the same program and make some amendments to it. So now what I'm going to do here is I'm going to find the sum of two numericals. So let's say we have A equals 10 and B equals 4.3. To do the sum of these two numericals, instead of displaying this message, you would just say A plus B. Now if I try to compile this program, the compiler will throw some errors. Let's see what those are. Let's open the command processor and go to the directory where your program is residing. It's in desktop. Let's do CLS to clear the screen. Now let's try to compile the program. javac, which is a Java compiler. firstapp.java. So the compiler has thrown some errors, which says it cannot find symbol and it is pointing to letter A. Same is the case with letter B. Alright, what's going on? Java is not a human being. It's a computer. It's artificial intelligence. And we humans, we programmers need to be more specific about the information that we're providing to a machine. By that I mean, it's just not enough if you say A equals 10 or B equals 4.3. We also need to tell Java what type of data this A is holding. In this case, it's integer in case of A. In case of B, it's a decimal point numerical. So the keyword that we need to use for integer in Java is int. This tells Java that the variable A is holding a data of type integer. Now for decimal point number, the keyword that we need to use is double. One thing to note is like I've already mentioned, Java is a case sensitive language. So instead of double, if you say capital D double, then this would yield a different result. Or if you say DO, if you make O as capital, then this would yield compilation errors. So let's not do that. Let's keep it as double. And let's save the file. I just hit Ctrl S. Let's go to command processor again and try to compile the program. The program got compiled successfully. Now we also have a class file here to run the program. Let's do CLS to clear the screen and then now let's just try to run the program. So Java space first step. Let's hit enter. Great. It has shown the output 14.3, which is expected. Now to make this output look a little bit more meaningful, let's try to prepend a string before the result. So instead of just saying A plus B, what we do is we'll write a string which says the sum of A and B is the result. Now there is one more thing to note here. The character plus, in case of a plus b, it is used to find the sum of these two numericals. But the plus in here is acting as a concatenation operator, which means it is concatenating what's there in the left and what that comes in the right. Now if you try to run this program, you'll see a strange output. Let's see what it is. Let's compile the program and run it. The sum of a and b is 104.3. What has happened? It's supposed to be 14.3. As I said, the plus character serves two purposes. One, it acts as a concatenation operator. Also, it can be used to find the sum of two numericals. In this case, Java got confused to determine whether this is a concatenating operator or to find the sum of two numericals. So what we want is, we want this plus operator to be a concatenating operator and this plus as a plus operator in math. So we need to put them in parentheses. Now let's just try to run the program. Compile the program and then run it. Cool, now it's displaying the correct result. The sum of a and b is 14.3, which makes sense. So a variable has the following syntax. The data type, which defines the type of data, like integer, and the name that you want to give to the variable, something like this, and the value, actual value, that this variable holds. Now let's try to understand what happens behind the scenes when we say int a equals 10. So when we run the program and when the interpreter comes across with this instruction, it will create a memory location to store the value 10. And how would this memory location be identified? With an identifier, which is a in this case. So variable in essence is nothing but this memory location. So down the line, if you do a plus b, the interpreter tries to look at the memory location with an identifier a and get the value inside it and replace this letter a with 10. So behind the scenes it does 10 plus, let's say, 20. Now we have different types of variables in Java, but at this point of time it is way too advanced. After we cover the concepts of classes and methods and a few other topics, we'll definitely be getting back on these variables and we'll explore even more concepts. Now I said a certain memory is allocated, but how much is dependent on the type of data. In case of integer, it's going to allocate 4 bytes of memory. In case of double, it's going to take 8 bytes of memory. Our next lesson is dedicated to understand how much memory does each data type take and their ranges. For example, you can't just give 10 zillion number here. There's a certain range within which the number has to be. In our previous video, we've talked about variables and data types. Now in this video, we'll understand how much memory does each of these data type take. We've already talked about integer data type. It takes 4 bytes of memory. Just for your information, each byte would constitute 8 bits, and a bit is the smallest unit of memory in computing world. And the value can fall in within this range. For example, int a equals 100 is valid. Int a equals 100,000 millions is not valid. The number has to fall within this range. Short is a shorter form of integer and it takes half the memory what integer would take. It just takes 2 bytes of memory and its value can fall within this range. Byte takes the shortest memory of all numerical data types and you can have a number within this range. This range actually makes sense given the fact that it just takes 1 byte of memory. As I said, 1 byte would constitute 8 bits. So with 1 byte you can have 255 combinations of zeros and ones. So hence the range is 128 to 127. Same is the case with all the other data types. Now long takes 8 bytes of memory, and you can have a number within this range. In most of the cases you would either use integer or short, and only in rare cases you would ever use long. So why do we have 4 different integer types? The problem is the performance. It's because if you have to use a variable that holds a value within this range, maybe let's say the value 120, then if you use long for that, it occupies 8 bytes of memory, whereas if you use byte, it would just consume 1 byte of memory. In case of high-end applications, memory is very precious. If you keep using long even though it is not necessary, then it would degrade the performance of your application. We've already talked about double data type. It consumes 8 bytes of memory, and it can have a decimal number within this range. Essentially what this means is, in simple terms, you can have up to 15 decimal digits, which means the numbers that come after the decimal point. Float is a shorter version of double, and it just consumes 4 bytes of memory, and you can have a decimal number within this range. Essentially, you can have up to 7 decimal digits. We have a couple of other data types. Boolean is a data type that holds only 2 values. There are only 2 possible values that a Boolean can hold. One is true and the other is false, and it just consumes 1 bit of memory. Actually, it's not reasonable to say it takes 1 bit of memory. It's actually dependent on few other factors, one of which is the JVM that you're using. But typically, let's assume it just takes 1 bit of memory. Char data type is a single 16-bit Unicode character. It consumes 2 bytes of memory, and number has to fall in within this range. This might confuse a little bit for you because we're talking about character. Character can be letter A, an uppercase A, or lowercase x. But how come we have numbers, numericals here? In order to demonstrate the data type char, I already have a program written. Let's go through it. If you take a look at the character variable C3, then it's just holding a single character. In this case, it's A. But character data type can also hold a numerical. If we try to print C1, it won't print 76. Instead, it would print a character which is corresponding to this Unicode. For example, for 76, the character that is corresponding to this is letter L. And for 40, it is the opening parenthesis. Let's run this program so that we'll understand more. Let's open the command processor, go to desktop. That's where my program is residing. Let's do CLS to clear the screen, and do java c char.java. Let's run it. So let's see what has happened. The char for Unicode 76 is L. So this is the instruction which prints that. The char for Unicode 76 is C1. So it just retrieved the letter corresponding to Unicode 76. Same is the case with C2. Char for Unicode 40 is open parenthesis. Now for C3, we're just simply displaying what is there here, the letter A. Now here is the interesting part. The plus plus is an increment operator. Soon we're going to discuss what this is. In this case, what it is doing is, for C3 character A, if you do C3++, it will just increment the Unicode of A by 1. By that I mean the Unicode of A is 65, and it will increment it by 1, so it will be 66. And when we print C3 now, it would print the character corresponding to the number 66, letter B. In our future examples, we would definitely be using this operator again and again. I'm sure that you would feel much comfortable with this. Now one more thing to note is the Unicode character set has, like I mentioned, it has 65,000 numericals, so that means there are 65,000 plus characters as well, which means it supports all the characters in most of the popular languages. Now if you give a number something like 30,000, 60,000, something like that, now the character corresponding to it may not get displayed in the command processor. It's because the command processor does not support all the characters. If you have much advanced GUI interface to run this program, maybe something like Eclipse or something, then you can probably display the output in most of the popular languages like German, French, Latin, etc. Alright. Data types is a pretty vast concept in Java, and whatever we have discussed in this video are just primitive data types. And when it comes to non-primitive data types or object data types, it's pretty vast. That being said, don't get terrified. We're going to cover everything in detail, and I'm sure that I'm going to make you feel comfortable. But for now, these are called primitive data types, and I believe now you have a fair idea on what these are. Sometimes it's the problems faced by developers or programmers which will introduce new features. Same is the case with arrays. Let me explain you what I mean. Take a look at this program. What we're having is the salary details of 10 different employees of a company. For example, Ron earns $10 million and Krish earns $12 million. Obviously, no paying job would pay you so much whatsoever, but for example's sake, let's assume so. Now, let's say I wanted to find out the average salary of all these employees. The formula that we need to use is sum of all the salaries of all the employees divided by the number of employees. So I would do Ron plus Ben plus Liber plus Krish plus blah 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 divided by, and then the count 10. Let me just make sure it is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, it's 11. So here is the problem. It is pretty tiresome for me to write, and it's even more tiresome for you to listen. Also, let's say we have some hundreds of employees here, and we need to give a proper count here, which is painstaking process. If I give an incorrect count, then that would yield a very bad result. So how do we solve this problem with arrays? Let me pull pen and paper and let's see a real-time example of arrays. Alright, let's say you own a transportation business and you specialize in transporting cars. So now you got a requirement where you need to transport 10 cars. Now we have a source and destination, which is where you need to transport the cars to. Now you'll start by sending all the cars on the road, car C1, C2, C3. Now the problem is it's pretty difficult to keep track on each and every car, make sure it is safe, take care of all the fuel expenses and potential physical damage to the car, etc. There are a lot of things to be considered, and it's pretty hard to manage. What if one of the driver just goes away with the car, not taking to its destination? Pretty tough. So how do we solve this problem? Instead of hiring 10 different drivers and managing 10 different cars, you would just hire one truck. Let's call this truck as truck T. And this truck has a certain capacity. Let's say it has a capacity to hold 12 cars. And each segment or each section will be identified with an index starting from 0. So the first section can be accessed with 0 index, and the second with 1, the third with 2, the fourth with 3. Now once you load all the cars into this truck, and once it reaches to the destination, you can pull a certain car using the index. For example, if you say T0, that would pull the car inside this segment. If you say T3, that would pull the car in the fourth segment. So that's exactly what arrays in Java. Let me go a little bit more technical into this. When you say int a equals 10, as I've already mentioned, this would create a memory size of 4 bytes and store the value of 10 in this, and this memory location can be accessed with an identifier called a in this case. And if you have 10 another integer variables, you would create 10 another memory locations, each of 4 bytes. But whereas if you create an array, it would just create one memory location, one big chunk of memory location, something like this. And whatever the size that you specify while creating the array is the number of segments it contains. And each of these segments can be accessed with an index starting from 0. Now if you want to pull the value inside one of the index, you would access it using the index. If you want to pull the fourth element, you would use index 3. Now let's apply this on our code and let's see how we can solve the problem. Let's get rid of all the code in here and start writing a fresh code. Now the way we declare and initialize a variable is, by the way, we didn't talk about declaration and initialization. We will in a while. But to declare and initialize a variable, we say int ron equals 10. Now to declare and initialize an array, all you would do is to add a square bracket here. Now we can't give the value 10 here. We need to use a keyword called new, and then the data type, which in this case it's int, and then remember I talked about segments? That's what you need to give here. You need to tell Java how many segments of memory would you be requiring. Let's say 10. Now we have an array created. We have 10 memory locations created. All we need to do is insert values in each one of the segments of an array. So to insert a value in the first index, what we need to do is you just say ron at 0 index. Let's change the name ron to something meaningful. Let's call it array. Let me change the name here as well. Array of 0 index equals 10. Array of 1 equals 20. In order to save your time, let me just finish all the typing and then I'll get back. Okay, here we are. Now all you would do to find the average salary is this. Now please note that you may not be able to understand some of these instructions. When we cover the concepts of control statements, classes and methods, you would better understand these equations. We'll definitely be getting back on this example and we'll make you understand. But just for the explanation's sake, what we're doing here is we're just looping through each and every individual item in this array, and then we are adding each other. By the end, we're having the sum of all the elements. And in here, what we're doing is we're getting the sum divided by the length of an array. Going back on the problem statement we had to count each and every individual variable and type the exact count here. But in here, you can just say array.length. So this would just take the length of the array itself. So in here, we're just printing the average. Let's try to run the program. Cool, it displayed the average salary. Now the key thing to note here is we gave the size as 10. If you just fill only 5 of them, we would still be having 10 memory locations. So when we do array.length, it actually gets the size of an array, which is 10, regardless of number of segments that were filled. So that's one of the primary disadvantage of using arrays. You have to know upfront the size of the array that you're going to use. Otherwise, most of the memory will be wasted. The point that I want you to take away from this is, let's say we have thousands of employees. You don't have to type in each and every variable. Instead, you can just have the similar lines of code which would do the magic. This is just one simple example of array, but this does not actually explain the real advantage of arrays. To know more on arrays, we need to cover the concepts of classes, objects, methods. Also, we need to go through the control statements to understand better. But for now, this should suffice. Now let's quickly talk about declaration and initialization. By the way, we can further shrink this code and reduce the number of lines by using curly braces. So instead of giving a fixed number of 10 and entering each and every value in this manner, we can just simply get rid of this and get rid of this as well, and simply use curly braces and give the numbers or the values separated by comma. Something like this: 10, 20, 30, 40, 50. Now the size of array dependent on number of values that you give here. Now this statement makes more sense, and this would never go wrong. Now let's try to run the program again. Cool, we got the average. So it's working. Okay, now let's see declaration and initialization. As I have already mentioned, we have two different types of data types. One is primitive, other one is non-primitive or object type. In case of primitive data type, like int equals 10, this is the declaration part, and if we assign some value to it, that's called initialization. So when we say int a, we will create a memory location with a as identifier, and we would have a default value of 0 regardless of initialization. So even if you don't say a equals 10 or something, we would still have a memory location created. But that's not the case with non-primitive data types. For example, in case of array, if you say int square brackets array, this is just a declaration of array of integers. This would just tell compiler that we're creating an array of integers. Unless you use a keyword called new, no actual memory will be allocated. So you need to say array equals new int of certain size. Then this would just create 10 memory locations, and each memory location would be of size 4 bytes. So this part is called declaration, and this is called initialization. Now let's go back to our workbench and see a few other examples. Now in this example, what we're doing is we're just sorting all the values of an array in ascending order. So the function, the method, by the way, method is synonymous to functions in C language. And once again, we'll talk about methods and classes, and more specifically on this operator over here, the dot. But for now, just think of this as a function in C language, and it takes some value and do some processing. In this case, it just takes array and it sorts all the values in it. Looks like our list is already sorted. Let's shuffle them a little bit. Maybe let's say 40, 10 420, and would give 99 here, and maybe 300. Let's save the file and run the program. Compile the program and then run it. We have the output in sorted order. Great. Let's take a look at one more example. Now in this example, we're using binary search to find the index of a certain value. Let's say we wanted to find the index of the value 40. The expected result is 2, since this is the third element. That's 0, 1, 2. Let's try to run the program. We got the output that we were expecting. Now, like I said, you may not be able to understand some of these instructions. We'll definitely be covering all these concepts, and I'm sure that I'm going to make you feel comfortable with this. The methods like this are all predefined in Java. They come with the standard edition. In order to know more on what sort of manipulations you can do with arrays, you can take a look at this link. And it's pretty hard and especially time consuming for you to go through each and every functions provided by arrays. I gave you 2 examples. Use those examples to experiment with methods offered by arrays. In this video, we'll talk about literals in Java. A literal is nothing but a fixed value or a fixed data. Take a look at this instruction. The data that you see on the right hand side is an integer literal, since it's an integer value. This value can also be represented in multiple forms. This can be in hexadecimal format. This can also be in binary format. Let's take a look at the example of integer literals. Let's go to our workbench. Take a look at the following program. Here, the byte, short, and int holds an integer value, and these values or literals can also be represented in hexadecimal format with 0x prefix. The hexadecimal number 70 is representation of numerical 2000. In the similar fashion, you can also represent a number in binary form with 0b prefix. This binary number is representation of the number 2000. Coming to long, you need to append the letter L in the end. So why do we need to do so? It's because no matter what integer value that you give here, by default Java assumes its data type to be of type int. In case of int, the data type is already int, so there is no problem. But when it comes to byte, since this is an integer value, Java assumes the data type to be of type int. But since we gave here byte, and the value that we gave here falls within the range that byte supports, Java implicitly convert this int type to type byte. And we know that byte takes lesser memory compared to integer. Same is the case with short. But when it comes to long, if you give a value which is in the range that int supports, then Java does not complain. Even though you tell Java that this is of type long, it will just allocate 4 bytes of memory. But in case if the value exceeds the int data type range, then you need to explicitly tell Java that the literal that I'm having here for data type long by giving the letter L. If you don't give the letter L, this would yield a compilation error. Alternatively, you can give a value which falls in the range of int, and now you don't have to give the letter L. That's perfectly fine. So now I hope you understand why we have L here. But why does Java default any integer type value or integer type literal to be of type int? It's because to save memory. For example, you're using a long variable which has a value that falls in the range of int. Why do we need to allocate 8 bytes of memory which long takes? We can just allocate 4 bytes of memory which int uses. So the basic answer is to save the memory. Now let's try to run the program. So we have byte as 120, short as 1000, integer value as 2000, and then we just represented 2000 in hexadecimal format, but when we print it, it actually printed the numerical. Same is the case with binary format. Let's experiment a little bit with this long variable. Let's try to get rid of this L. Let's save the program. And then let's compile it once. See, we have an error which says integer number too long. So by default, Java assumes this number to be of type int, and it is complaining that the range exceeded what int data type would support. So hence we need to give the letter L here, which says, no, I don't want you to assume this to be of type int. I want it to be of type long. Now Java does not give any compilation error. But if you give a value which falls in within the range of int, let's save the program, and then let's try to run again. This time, even though you don't give the letter L, it's fine. See? Now Java has just allocated 4 bytes of memory, which int takes. So this saved some memory. Now let's go ahead and take a look at floating point literals. A floating point literal can be represented either in decimal number with a decimal point or in exponential format. Going back a little bit, if you take a look at this table, we have specified the range of both float and double in exponential format. This is representation of numerical in a scientific notation. And the strange thing here is, even though float takes only 4 bytes of memory, since it's representing numbers in exponential format, it can even accommodate the maximum value that long supports. So even the float just takes 4 bytes of memory versus long, which takes 8 bytes of memory, it can easily accommodate any long value. Talking about exponential notation and how to convert a decimal number to exponential notation is beyond the scope of this tutorial. You may want to explore it from other sources, but I feel it's really not worth knowing. You would seldom use it. Note that we need to have the letter F in case of float. Guess why? No matter what decimal value that you give here, Java assumes this literal to be of type double. The reason is to improve the precision. When you're dealing with decimal values, you need more precision. For example, if you calculate the value of pi, which is 22 divided by 7, the output that you get might be requiring double. The maximum value that float supports may not hold it. So you need more precision, and hence we need to have the letter F here. Otherwise Java assumes this to be of type double. Let's run this program. Cool, we got the float value 12.1, double value 3.144433, and exponential value 2.1474839. Now let's take a look at character literals. As we've already seen in our previous examples, a character can also be represented in Unicode format. So 65 is a Unicode for letter A, and so a character literal can have a numerical in Unicode format or a letter within a single quotation, or we can also display some escape sequences. /t is a tab button. So if you run this command, or if you execute this character, it's as good as you pressed tab key on your keyboard. Let's run this program and see how it goes. Cool, the output is as expected. So the escape sequence that we used here printed a tab. That's the space that you see here. It's a tab space. Let's take a look at Boolean literals. A Boolean literal can be either true or false. Let's run this program. So in our first line, we're just printing the value true. In second line, we're printing the value false. Coming to third and fourth lines, we're having an expression here. Is 10 greater than 100? Is it true or a false? It is false. So the output of this expression is either true or false. It's a Boolean value. So that's what we have here. It's a false. And is 100 greater than 10? 100 greater than 10? Is this expression true? It is true. So we got the result true. Great. Now let's quickly take a look at some of the escape sequences that Java supports in case of character literal. Java supports following character escape sequences: /b for backspace, t for tab. You can quickly go through each one of these and experiment with each one of these. In this lesson, we'll talk about typecasting in Java. Typecasting is nothing but converting a value of one data type to another data type. Now take a look at this table. It's easier for us to convert a value of byte to a value of short because the range of byte is lesser than to that of the range of short. In the similar fashion, we can convert int to long. We can also convert char to int. Remember, I said character can also be represented in numericals, and the range of char surely is lesser than to that of the range of int. When it comes to converting a value of lower range data type to a higher range data type, Java does that automatically because there is no loss of information. For example, it's easier to put a 1 liter container in a 10 liter container, but not the other way. If you try to put a 10 liter container in 1 liter container, there may be loss of something. Same is the case with Java. If you try to put int value in, let's say, byte, Java won't do it by itself because there is a risk of losing data. There can be loss of magnitude in the resulting value. So Java won't do it by itself, but will ask the programmer to do so at his own risk. Let's go to our whiteboard and take a look at some theory behind it. So Java does automatically convert byte to short, short to int to long, long to float, and float to double. Here you need to note that long takes 8 bytes of memory, whereas float takes only 4 bytes of memory. All the float values can be represented in exponential notation, it can easily accommodate the maximum value that long supports. We also have char, which can be converted or typecasted to int. So if you go from left to right, we are converting the value of lower range data type to a data type of higher range. This is called widening. For example, you could convert byte to short, you could convert byte to long, you can convert char to float. And the name widening makes sense because byte takes 8 bits of memory, whereas int takes 32 bits of memory. And like I've already mentioned, you can easily insert a 1 liter container in a 10 liter container. And in the similar fashion, the 8-bit memory is actually widened to a 32-bit memory. So essentially we have widened the space. But whereas when you try to convert int to byte, you're trying to convert a value which is in a 32-bit container to 8 bits. This mechanism is called narrowing, and the arrow goes from right to left. So if you try to convert double to int, it's narrowing, long to short, it's narrowing, etc. In case of narrowing, Java does not do it on its own. It's up to developer because there can be loss of data. When Java tries to convert a 32-bit value to an 8-bit value, obviously it cannot accommodate the entire numerical. Now let's take a look at the syntax of typecasting. A quick question: what are we doing here? Are we doing widening or narrowing? We're doing widening. We're trying to convert a value of type byte to integer. This is called widening, and doing so does not yield any loss of information. Hence Java does it on its own. So it does implicit casting. It will convert this byte to data type int, as there is no loss of magnitude or there is no loss of data. But when we try to do the other way, for example, int I equals 1000, byte b equals I, compiler will complain the programmer, because Java cannot convert an int value to byte without the loss of data. So the way we tell compiler that it's at my own risk, I don't care if there is loss of data or loss of information, I still want this to be done. I still want this to be a valid statement. So to tell compiler, you just have to say byte here, your destination data type, within the brackets. Now compiler will successfully compile this program and even run this program, but the result would be something unexpected. Let's go to our workbench and take a look at a quick example. So here we have a value as 2000, which is of type int, and we're trying to convert into byte, and we explicitly typecasted it to byte. Now let's try to run the program. And then let's run it. So the value is pretty unexpected and is completely useless. So let's see what has happened behind the scenes. The binary representation of the numerical 2000 is this. And since we said int a equals 2000, this entire thing is stored in 32 bits of memory. And when we say byte b equals 8, it's going to create 8 bits of memory, and somehow Java needs to manage to put this number 2000 in 8 bits. It will try its best. So Java does some sort of calculation. It will straight away ignore all the 24 bits and would consider only 8 bits, which is, and then it checks if the most significant bit is 1 or 0. If it is 0, it will straight away print the decimal number of this binary representation, and since it is 1, it will go ahead and try to do the ones complement of this binary number. So ones complement is nothing but the negation of this number. So it's just replacing ones with zeros and zeros with ones. And now the decimal value that you get is 47. It will add plus 1 to it, and we get the value 48. And in Java, all the integer types are signed. So since we have 1 here, which means negative sign, minus, it will treat this number as a negative number, and hence we got the output as 48. Throughout my career of decade and a half years of experience in using Java, I have never ever used narrowing for primitive data types. I don't even think of a scenario where you would need a narrowing for primitive data types. You'll have to check with the designers of the Java. But I did use widening a lot of times. Well, now going back a little bit, you might be wondering why char cannot be converted into short, even though they take same bytes of memory. That's because char is unsigned, but whereas short is signed. So out of 2 bytes, 1 bit will be allocated to decide the sign here, whether it's minus or plus. But whereas for char, it starts with 0 to 65,536, all are positive integers. Okay, now let's take a look at widening and narrowing examples. We have a pretty simple program here. We're converting byte to int. So byte b equals 10, int I equals b. Java implicitly convert this b to type of int because we're doing widening here and there is no loss of information, and Java gladly does the conversion by itself. Same is the case with long to float. We have a long value here, we're trying to convert into float, and this is the maximum long value that long can hold. We're also converting char to double. So the Unicode number of letter capital A is 65. So what we're going to store in double D is 65.0. Let's try to run this program. Cool, we got the expected output. Now let's take a look at example of narrowing. So we're trying to convert integer data type value to a byte. Int I equals 2000, byte b equals I. And we're printing the value of b. So would this yield a compilation error or not? It does. Because there is loss of information, we need to explicitly say that I want to convert this to byte. Now this will, we've actually already taken a look at this example, so I'm not going to waste your time running it again. Not to confuse you, but Java does do narrowing implicitly in case there is no loss of data. For example, take a look at these statements. So byte b1 equals 10. By default, Java treats any integer value as of type int. So Java converted this int data type to byte b1 gladly because the value 10 comes in the range of byte and it's not resulting in any loss of information. Let's save the program. Let's get rid of this code in here. Let's save the program and try to run it. Not to confuse you further, but let's take a look at a few more statements. Now what we're doing here is essentially the same thing. The only difference is we have explicitly initialized the variable a with value 10. Now if you run this program, do you see errors? Yes or no? The answer is yes, we do, because we explicitly stated that the value a is int. So it's our responsibility as a programmer to explicitly cast this a to type byte. First, let's try to run without typecasting it and see what happens. Compile the program. Oops, we have already seen the error. So incompatible types, possible lossy conversation. If you convert int to byte, there can be loss of data. That's what it's complaining. So I would say it's at my own risk. I want to take care of this, so I'd say it's byte. Save the file. Compile the program. Run the program. Good. The result is expected.
If all you want to do in your life is to develop simple Hello World applications, then you should be happy with the Notepad. You can use Notepad to write your Java programs. But in all likelihood, you want to go beyond a Hello World application and actually write some meaningful Java programs or create applications. Well, in that case, you have to get rid of a Notepad and actually install IDE, or Integrated Development Environment. The name might sound a bit too technical, especially if you're a newbie to using IDE, but you can think of it as an enhanced version of Notepad with a lot of features. IDE will give you a lot of convenience while you're writing code. For example, it will give you auto suggestions so that it will save some development time, or it will show the compile time errors right when you're typing the code, and you don't have to manually compile the code yourself. So stuff like this will definitely give you a lot of convenience while writing your Java programs. So the next thing we want to do is to install an IDE. Now there are a lot of IDEs available in the market. Some of them are paid, some of them are open source. For example, we have Eclipse, we have NetBeans, we have IntelliJ, which is one of the popular IDEs, etc. But the one that I'm going to install right now is going to be NetBeans. Well, one of the popular IDEs used in the industry is Eclipse, but I'm not going to install it right now because the user interface of Eclipse is not so user-friendly for beginners. So we're going to stick on with something that sort of sits between a Notepad and Eclipse, and that IDE is NetBeans, which is also an open source. You don't have to pay a single dollar. You can download it and use it. So let's take a look at how we can install NetBeans IDE. Let me go to the browser and type in netbeans.org. So here is the home page of NetBeans, and here it says you can quickly and easily develop desktop, mobile, and web applications with Java, JavaScript, HTML5, etc. What we're interested in right now is just Java. Click on download. Once you're in this page, go ahead and click download. If you're interested in older releases, then you can check this out. Otherwise, just download this. That would take you to this page. Here you can either download the source or the binaries. Since NetBeans is an open source software, you can actually get access to its source code. But let's just download the binaries. We're not going to do anything with the source code. So click this link. That would take us to yet another page. Click this link here. That would actually download the NetBeans. I've already done that, and so I have it in here. Use a software like WinZip. In my case, I'm using 7-zip software in order to extract all the files. And once I extracted this zip file, I got this folder. Just open it, go to bin folder, and double click netbeans64.exe if your operating system is a 64-bit operating system. Otherwise, you want to open up the other one. In my case, I have Windows 64, and I'm going to double click it. Once you run this application, you may actually get this prompt. I guess this will come only for the first time. Just agree with it. And then you'll see an IDE that looks something like this. If you get any additional prompts while installing, just accept all those prompts and finally install NetBeans. One of the prerequisites of using NetBeans is that you have installed JDK. In one of our previous lectures, we have seen how to install JDK, and I hope you've done that. So without any further delay, let's run our first Java program. For this, we're going to create a new project. You'll be used to all these terminologies. You can think of project as kind of like a folder that holds multiple files. Not exactly, but close enough. While we progress through this course, you'll understand what is a project. It would basically comprise of all the files that your application might comprise of. For example, you could have Java files, you could have image files, you could have XML files, etc. Once you click on the new project, you would get this prompt. You can either go with Maven, Gradle, or Ant. Maven and Gradle are a little bit advanced. Just go with Java with Ant. This is the simplest form of Java application. Choose Java application under projects and click next. Give your project a name. I'm going to call it as sample project and hit finish. It's going to take a while. So this has created the project along with a Java file where we can start writing the source code. I'm just simply going to say hello world or whatever as part of the sysout statement. And as soon as I press the dot, you would see some suggestions coming. That's the beauty of IDE. Out dot println, and you can say whatever you want in here. Let me also increase the font size just a bit. I'm not quite sure how to do that, so before I waste your time, let me pause the video, increase the font size, and then get back. Okay, it's quite easy. You go to Tools, Options, and select Fonts and Colors, and you can change the size in here. I hope you're able to see the text now. Let's run our program. It's going to take a while. So this has displayed our message, which is great. In case if you're not able to see this message, then your NetBeans IDE haven't recognized the JDK installation directory, in which case just open up the NetBeans folder and go to etc, open up the NetBeans conf file. I'm going to use the Notepad++ software to open this file. So here it is. Go to the extreme bottom of the file and you would see this field NetBeans JDK home. Just uncomment this by removing this, and here you would specify the path to the JDK installation directory, and you should be good to go. If you face any issues, do let me know and I'll be happy to assist. Let's talk about type inference, which is a feature introduced in Java version 10. This feature is actually inspired from some of the other popular languages, like for instance JavaScript. If you're used to JavaScript, then you probably know that while declaring and initializing a variable, we don't have to explicitly mention the type of that variable. That, however, doesn't hold true in case of Java only until version 10. With type inference, we don't have to explicitly mention the type of the variable. We can just say var, and no matter what value that you assign, you don't get any compile time errors. For example, I can change this to 10.1, no errors. I can make this a string, still no errors. We can even assign our own types or collections like list and set, and you still don't get any errors. Basically, although we're not explicitly mentioning the type of the variable, compiler is actually doing that job by looking at the type of the value that we're assigning. It looks at the value, and based on that it can figure out the type, and same would be assigned as the type. However, in case of Java, we have certain restrictions. For example, you can't have this as part of the class member variable, or as method argument, or even as a method return type. You can't have var as a return type. That's not allowed. And similarly, you can't have var x or something of that sort. That's not allowed. The obvious reason is the user of this method does not know what type of value that he needs to send to this method. If this is accepted, for instance, then the user of this method can actually send something whose type is not supported by the internal logic of this method, and so we're going to see an error. So you're only limited to use type inference as the local variable of a method, or as part of index variable in a for loop, or you can also use it as part of try with resources. You shouldn't have any problems there.
In this chapter, we'll talk about operators. An operator is a special character that does some operation on operands. For example, if we have a plus b, then plus is an operator that does some operation on operands. In Java, we have different types of operators. Let's take a look at them. In this lesson, we'll talk about arithmetic operators, modulus operator, and assignment operator. But before that, we need to import the project. I have already bundled the project files as part of this chapter. You can just download it and import the project. And this is how you need to do so. Go to File, go to Import Project, click on From Zip. Click on Browse and select the zip file that I have bundled, named Operators. Click on Open. Click on Import. Alright, now the project got imported. Let's expand the project. No need to worry about these packages and all. We'll definitely be exploring all these concepts in our future videos. So expand the source packages. This will contain the Java source files. Expand it, expand operators, and then double click on arithmetic operators. This will open up the file. Now to talk about all these buttons and all these panels, we need to wait for our code to grow a little bit. So Again, I'm saying it too often, but believe me, we're going to cover each and every topic in detail. Just trust me and follow me. Double-click the tab to expand it. Arithmetic operators are operators that does some arithmetic operations. Take a look at this. We have additive operator that will find the sum of two operands. We have I equals 20 and D equals 10.1. This statement will find the sum of it and it would print the output. And we have subtraction operator. This will find the difference between the two operands. And we have multiplication operator. And the symbol that you need to use to multiply two operands is this, something that looks like a star. And we use / to perform the division operation. These are all arithmetic operators. Now we also have assignment operator. We use this operator to assign a value to a variable. And we have already seen this used in our previous examples. It's simple equal sign that we use to assign a value to a variable. And this is how exactly we did in our math classes as well. And then we have modulus operator. We use percentile symbol for this. And what this does is it will find the remainder of two operands or two variables. Let's run this program. Let's double click the tab to shrink it. And then you should not run the program using the run project, because doing so will run the entire project. And in entire project, it is expected that will have only one void main method. By the way, we'll talk about methods and all, but just remember that for every project we should have only one main method. But since in all these files, for example, let's open Bitwise Operators, we have main method here too. So we need to run each of these files individually. So to do so, we need to right click on the file and then click on Run File. Or we can also use a shortcut, which is Shift key plus F6. Let's click it to run the program. Alright, we got the output. Ignore all the junk here and let's just focus on the result. So I plus D is 30.1, I minus D is 9.9, etc. Great. Now you try to modify the code, give a different value, and try to play with the program. In this lesson, we will talk about unary operators. Let's double-click the file. Let's double-click the tab to expand it. We have unary plus operator, which tells Java that the integer is a positive integer. And we have unary minus operator, which tells Java that this number is a negative integer. If you don't give any operator here, by default, Java will assume this to be a positive integer. We have unary increment operator, and the operator looks something like this, two consecutive plus signs. And when we say a++, what this does is it will increment the value by 1. So it essentially does a equals a plus 1. Within increment operator, we have post increment and pre-increment. So in this instruction, we're doing post increment, which means we're printing the current value of a and then we're incrementing the variable a. So if you execute this statement, we would get 20. But the next time you use the value a, we get the increment value. For example, this instruction prints the incremented value. But when it comes to pre-increment, we're incrementing the value of a by 1 before we print it. So this statement will actually print the incremented value. And we have decrement operator. It has two consecutive minus signs. And what this essentially does is this. It does a equals a minus 1. It will decrement the value of a variable by 1. Even in here we have post decrement and pre-decrement. In post decrement we'll print the value of a and then we'll increment. So in this instruction the value of a is currently 20, so in this instruction it would just straight away print the value 20. But after it prints, it will decrement the value of a by 1. And the next time we use the variable a, we get the decremented value, which is 19. When it comes to pre-decrement, we are decrementing the value of a and then printing it. Finally, we have logical complement operator. This would just reverse the result of a Boolean value. For example, is a greater than b? We have a and b, and a is indeed greater than b. The result of this statement would be true, and the result of this statement would be false, because we're essentially having the same equation here, but we're kind of negating it. So the value of this instruction would be false. Let's try to run the program. Alright, here is output. The initial value of a is 20. When we are showing the result of this instruction, a++, the value of a is printed first, which is 20. And then the value of a post increment is 21. In here we're doing pre-increment. So the value of a is incremented and is printed at the same time. Because it's after the increment operator, we have the value a. So the current value of a is 21, it's now incremented to 22. In here we're just resetting the value of a back to 20. Now we did post decrement, the value of a is printed, and then in the next instruction we have the decremented value, and hence the result is 19. In here we're doing pre-decrement, the value of a is decremented and printed at the same time, and we have logical complement operator. Is a greater than b? True. And the logical complement of a greater than b is false. We'll understand and we'll definitely be using all these operators in our future programs. In this chapter we will talk about relational operators and equality operator. A relational operator compares two operands and would give a Boolean result. We have greater than operator that will check if operand on the left is greater than the operand on the right. Similarly, we have greater than or equals to operator. It will check if a variable or an operand on the left is greater than or equal to an operand on the right. Similarly, we have less than operator and less than or equals to operator. And finally, in relational operators, we have not equals to operator to check to see if operand on the left is not equal to operand on the right. And we have equality operator that will check if operand on the left is equals to operand on the right. Note that this operator has two consecutive equal sign, because if we just give single equal sign like this, then according to Java this is a signing operator, just as we did here. If you want to compare two operands and check the equality, then you need to give two consecutive equal sign. And one thing to note here is all the relational operators We'll consider only numerical data types like integer, float, character. Let's run the program. Alright, is A greater than B? False. A is greater than or equals to B? False. A less than B? True. A less than or equals to B? True. A not equals to B? True. Is A equals B? False. Alright, now you can go and experiment with this program by yourself. In this lesson, we will talk about conditional operators. We have conditional and conditional or operators. Conditional operator defines under what conditions should an equation result in a Boolean value true. Let me explain you what I mean. Unlike other operators, conditional operators will take Boolean expressions on both the sides. For example, this expression would result in a Boolean value. It could either be true or false. Same is the case with this equation. Now for conditional AND, the only case where the result of this entire equation would be true is when these two equations result in Boolean value true. Otherwise, this equation would result in false. So in this case, A equals 20, it's true. Is B greater than A? It's true. So it's true and true, which would result in value true. In this case, we have true and false, and ultimately we'll get false as the result of this entire equation. And false true is also false. False false is also false. So only under one condition this equation will be true in case of conditional AND. That is when both the equations result in Boolean value true. When it comes to conditional OR operator, if either of these two Boolean equations result in value true, then the entire equation would be true. So true true would be true, true false would be true, false true would be true, false false will be false. We'll see the output in a moment. And then we have ternary operator. Unlike any other operator, ternary operator takes in 3 operands. For example, this is actually a shorthand of using if-else clause. We'll talk about if-else statement when we talk about control flow. Okay, basically what this equation is doing is we have an equation which would result in either true or false. If it is true, then this statement would be executed. In this case, we're just simply assigning the value A. Or if it is false, then this would not enter this section of this statement. Instead, it would print this, the value B. So essentially what we're doing here is we're trying to find the minimum value between these two operands or these two variables. If A is less than B, we would say A is smaller, and we're going to print the value A, because that's what we're assigning here. If A is less than B, then we're going to assign the value of A to this variable, min-val. If A is not less than B, then obviously B would be the minimum value, and we're assigning the value B to min value. That's what we're printing here. Let's run the program and see the output. Alright, what do we have here? Conditional AND. True, 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 and in any other case it would be false. And for conditional OR, the only time we would see false is when both the conditions or both the Boolean expressions result in false. And ternary value, so the minimum value between A and B using the ternary operator is 20, which is the value of A. Alright.
In this video, we're going to talk about bitwise operators. Personally, throughout my career, I have never used bitwise operators. And I would also recommend you not to give full focus on this topic, as it's not worth it. But if you're a student, maybe this will be helpful for your academics or for cracking interviews. So basically, all the other operators we have seen so far deal with variable. But in here, we deal with the binary representation of numerical. For example, bitwise operators does not perform operation on 65, but rather it performs operations on its binary representation. The binary representation of value 65 in 32-bit format is this. And for -30, it's this. To better explain each and every bitwise operator, I might need to use annotations. Let's go there. Alright. We have unary bitwise complement, and the operator looks something like this. All this does is it will invert the bits. For example, 0 will become 1 and 1s will become 0. When we're trying to find unary bitwise complement of A, this is what the result would be. And when we convert this to a decimal value, we would get -66. Zeros have become 1 and 1s have become 0s. That's it, as simple as that. We have bitwise AND operator. For this, we need to follow a table. Here it is. We have only 4 possible combinations of 0 and 1. When it comes to bitwise AND, 0 0 will become 0, 0 1 will become 0, 1 0 will become 0, and 1 1 will become 1. So the only case we would see the result as 1 is when both are 1. So what we're trying to do here is we're trying to find bitwise AND of A and B. So 1 0 will become 0, 0 1 will become 0, 0 0 will become 0, again 0, it's 0, 0, and we have 1 and 1 here, and that will make 1. Similarly, if you fill out all the bits in here, this is the output that we get, and when we convert that to a decimal value, we would get 64. We have bitwise OR operator, and the operator looks something like this. We're trying to find the bitwise OR of A and B. When it comes to bitwise OR, there are 3 cases where we would get the value 1. If at least one of these 2 is 1, then the result will be 1. So 0 0 will become 0, 0 1 1, 1 0 would become 1, 1 1 will become 1. And if you calculate the bitwise OR of these 2 binary representations, this is what we get. And when we convert that to a decimal value, we would get -29. Cool. And then we have bitwise exclusive OR. In here, there are only 2 cases where we would get the value 1. 0 0 will become 0, 0 1 will become 1, 1 0 will become 1, and 1 1 will become 0. And if you perform exclusive OR on these 2, you would get this result, and that when converted to decimal would get -93. And we have sign to left shift operator. So what this essentially does is it's going to push, since we're doing a left shift by 4, it's going to push these digits towards left side 4 times. So what that would result in is all these 4 bits will fall, and we get 4 empty places here, and those will be filled with zeros. That's exactly what we have here. And when you convert that to decimal, we would get -480. We have signed right shift operator.
This is similar to signed left shift operator, except it's going to push the digits towards right. In here, we're trying to push two places on the variable b. So what this is doing is it's going to push these bits towards right a couple of times. So these two would spill over and will disappear, and we get two empty locations here. And those empty locations will be filled with whatever is there in the most significant bit. So in this case it's 1. And that's exactly what we have here. And we have unsigned right shift. This will do exactly what signed right shift would do, except instead of filling the empty bits with the most significant bit, it will simply fill with zeros. So that would result in this value. If you run this program, these are the outputs that you're going to see. Go ahead and run it. In this video, we're going to talk about operator precedence. This can be better explained with annotations. So let's go there. Alright, let's say in our Java program, we have the following equation. 10 multiplied by 6 minus 3. Now if we run the program, would the output be 10 multiplied by 6, 60, and minus 3 would be 57? Or would it be 10 multiplied by 6 minus 3, which would be 3, which gives us the result of 30? Which one is correct? This is ambiguous. We don't know how to evaluate this. So to solve this problem, Java developers introduced this precedence table. The precedence table tells which operator will have the higher precedence and which operator will have the least precedence. The operator that is listed on top will have the highest precedence, and the operator that is listed at the bottom of the table will have the least precedence. So the precedence increases as we go up and vice versa. So now coming back to this equation, let's see how we can solve this ambiguity. If you take a look at this table, the multiplication operator has the higher precedence compared to subtraction operator. So this part of equation will be evaluated first, and the result will be computed with this. So the result would be 57. However, if you want this piece of equation to be calculated first, then you need to enclose it within a parenthesis. Now the result would be 30. Let's take a look at another example. 6 divided by 2 minus 1. So what is the result of this equation? Pause the video and find out. Okay, now let's solve the ambiguity. We have division operator and subtraction. Division has the higher precedence compared to subtraction operator. So this part of equation will be evaluated first, and then the result will be computed with this. So the result would be 2. Sometimes in an equation we may have operators with equal precedence. Let's take a look at this equation. Now both plus and minus operators here have equal precedence. That's where this rule of associativity come into picture. Plus and minus, the rule of associativity says we need to go from left to right. So we'll first solve the left hand side equation, and then the result will be computed with this. 7 plus 5 would be 12. Now let's take a look at another equation. So we need to go from left to right. So this will be evaluated first. Result will be evaluated with this, and the result of this entire equation will be evaluated with this. So we're going from left to right based on the rule of associativity. Similarly, we have associativity rules for other operators as well. Take a look at this equation. So the result of this would be -1. We're going from left to right. Both the operators are same, meaning that they both have the equal precedence, and as per the rule of associativity, we need to go from left to right. Now let's try to put things together. Take a look at this equation. Find out the result of this equation where x equals 5. 10 minus 4 divided by predecrement of x minus 5. Pause the video and solve the equation. Okay, so in this equation we have 4 operators, of which the predecrement operator has the highest precedence. So this will be evaluated first. So 10 minus 4 divided by the predecrement of 5 would become 4 minus 5. And now out of these 3 operators which are left, the division operator has the highest precedence. So this piece of equation would be solved. 10 minus 1 minus 5. Now since both these operators has the equal precedence, we need to go with associativity rule, which says we need to go from left to right, and when we solve it, the result would be 4. We solve this first and then computed the result with this. Now go back to our IDE and run the program. You would see the same results. In this video, we are going to talk about statements and blocks. Let's first talk about statements in Java. The statements in Java is similar to statements in our English language. Let's take a look at the procedure to make tea. Go to kitchen, turn on the stove, put on the pan, pour some water, insert tea bag, serve hot, enjoy your tea. These are all the steps involved. Now if you see, each of this statement is ending with a period, and moreover, if I remove one of the word from here, this would result in not accomplishing our task of preparing tea, because I go to kitchen, turn on the what? I don't know what to do here. In Java programming, this would result in compilation error. Let's put it back. Now each of these statements collectively performing a certain task. Keeping this in mind, let's go to our Java program. So in the similar manner, we have statements in Java that ends with semicolon, whereas in English they end with period. That's it. Now we have multiple types of statements which I feel is not worth knowing. We have already taken a look at some of those statements, like we have declaration and initialization statements, we have method invocation statements, we'll talk about methods later on, etc. Now let's talk about blocks. Each of the block would constitute n number of statements. It could be 0 or any number of statements. We can just have an empty block. A block will start with a curly brace and end with a curly brace. In this program itself, we have multiple blocks. This is one block, and within this block we have another block, which is this, and we have one more block. We have one more block as well. We're calling this block 1, block 2, and block 3. One important thing to note is the scope of variables. We have block 1 here, and it has a variable char a. Now inside this block we have sub-blocks, which is block 2 and block 3. The char a can be accessible from inside this block, and when I say inside this block, it also means inside the blocks inside this block. So the variable a is accessible within these blocks as well, block 2 and block 3, but not the other way. For example, in block 2 we have char b. If you try to access this variable outside this block, which is block 2, then we would get a compilation error, because the scope of a variable is restricted within the block where it was declared. In this simple example, we're just explaining A is accessible within block 1, block 2, and block 3. B is accessible within block 2, block 3, but not block 1. And C is accessible within only block 3, but not block 2 and block 1. Let's run the program. Alright, you see the output. In this video, we're going to talk about control statements, or sometimes referred to as conditional statements. Control statements help in controlling the flow of execution of a program. Now let's take a look at a real-time example. Let's say you have source and destination, and we have a robot. Our goal is to send this robot from source to destination. And let us also assume that we have a car, a bike, and a truck. Now we need to program this robot, and we need to instruct it to go to destination as fast as it can. Obviously, what we're going to write in our program is to tell the robot to walk. However, it will take a lot of time to reach destination if it walks. So we need to find a way to go much faster. So for that, we can make use of these vehicles which are available. So instead of saying walk, what we're going to say is if car is available, then use car. So the robot will check to see if car is available. If yes, then it's going to use the car to reach the destination. But we have a problem here. Let's say car is not available for some reason. Maybe it was taken by some other robot, or maybe due to technical difficulties the car is not starting. Then that would result in robot not reaching the destination. So what we need to do is we need to tell the robot that if car is not available, then start walking. We say else walk. Now we have two more vehicles here, a bike and a truck. If car is not available, then why can't robot use bike or a truck? And if neither of them are available, then it can walk. So instead of saying else walk, we're going to say else if bike is available, then use bike. Again, else if truck is available, use truck. Else walk. So what this piece of program does is it will let the robot check to see if car is available. If it's not available, then it will check if bus is available. If bus is not available, then it will check if truck is available, and if truck is not available, it will simply start walking. Good. Now let's say car is available, which means we're going to enter this piece of code. And note that once we enter this block, we're going to ignore rest of the code because we have our car available. Now inside this car we said use car. Let's program it more specifically. So if car is available, what we want to do is to start the car. And as we know, pressing the start button in a car may or may not start the car. It may be due to any number of reasons, but it may or may not start. So car may not start in the very first go. We need to keep trying until it starts. So in here, within this block, we're going to write this program. We say while car not started, then we're going to do something. Press start button. So robot will enter inside the car and it will see if the state of car is not started. If this condition is true, then we're going to enter inside this block. And we instructed robot to press start button. So robot will press the start button. Again, it will go back to this line of code and it will check to see if car started. If not, again it's going to enter inside this and robot will press the start button, and it keeps trying until the car starts. But we have a problem here. Let's say due to some technical reasons the car will never start. According to our program, the robot will keep trying forever, and that would result in robot not reaching the destination. So we need to solve this problem. At the same time, we don't want to give up trying. So what we're going to do is we're going to have maximum attempt of 10. So the robot is going to try 10 times, pressing the start button, expecting the car to start. If the car doesn't start, then it will just simply give up. So how are we going to do that? We're going to have a variable that says number of tries, say 10, and then we're going to have a counter that starts with 0. Now every time we enter inside this loop, inside this block, after meeting this condition, we're going to increment the count by using post increment operator. So the count will keep on increasing every time we enter this block. Now we need to have an if condition here, just as if condition in here, and that says if count equals tries, which means we have reached the maximum number of tries. If we reached the maximum number of tries, then we're going to enter inside this block and we're going to tell the robot to break, which means give up. By using this word break, we're going to get out of this while loop, and we're going to go ahead with further lines of instructions. So this way the robot will try for 10 times to start the car. If it doesn't, it will go ahead with these instructions, and in here we're going to mention the robot to simply walk. Now I believe you got a sense of how control statements are used to control the flow of execution of a program. So we've talked about if condition, we've talked about if else if condition, we've also talked about while loop, and we've also talked about one keyword called break. Alright, in our next video we're going to see all of these written in our program. Alright, now let's take a look at some of the examples of control statements. Now you need to open this file, if else if example, under the project control statements. Now you probably must be seeing the whole program written. What I would suggest is to select the entire content and delete it and write from scratch and follow along with me. That way you will have better learning. Okay, what we're going to do in this example is we're going to demonstrate the if-else if example. So what our program does is, as a user, I'm going to enter a certain number, and if the number falls in within a certain range, there is a title, a chess title associated with it. For example, if the number falls in between 2200 and 2300, the title that we're going to display is Candidate Master. If the number is between 2500 and 3500, then we're going to display the title as Grandmaster. So let's see how it goes. First of all, we need to write a program to take the input from the user.
And for that, we're going to use these 3 lines of code. Obviously, at this point of time, you probably don't understand these lines of code, and I suggest not to try to understand, because we're going to talk about them when we talk about classes, constructors, methods, which we're going to cover in our future chapters. But for now, what these 3 lines of code does is, when I run this program, you're going to see this text being displayed on the console, and then it will wait for the user to enter a certain integer value. So let's see how it goes. But before we run this, there's an error to be fixed. Let's see what it is. Let's click on this light bulb, and it has shown some suggestions on how to fix it. What we're going to do is we're going to import this particular class. Obviously you don't know what import means, but we'll talk about it when we talk about packages. So let's save the program by pressing Ctrl S and run the program. Of course, we can't run it from here. We're going to run from here. Run file. We were prompted with the message, enter your chess rating. Now we'll enter something, and we hit return or enter. That's it. So it is basically taking the input from the user and sort of storing that value in the integer variable rating. Now we're going to do something with this. Now, coming to the syntax of if-else statement, this is how it is. If a Boolean expression, this expression must and should result in a Boolean value, that means either true or false. And if this condition is true, then it's going to enter inside this block. In case if this condition is false, it's going to enter, the control is going to enter and look after this else if statement. And it will check this condition. If it is true, execute this statement. If it is false, go ahead with other statements. The control keeps going till the condition is met, or if none of the condition is met, then there is only one case with the word else. The statements inside this block will get executed. Now let's get rid of, or wait, let's keep this and try to write our program. If rating is greater than 2200 and rating is less than 2300, then we're going to display system.out.println candidate master. In order to save your time, I'm going to copy paste the code which I've already written. Let's expand it. So what we're doing here is, if the value that the user enters, in this case it's me, falls in between this range 2200 and 2300, we're going to display the message candidate master, because this is the title given to a chess master with the rating that falls in between these two numbers. And similarly, if the rating falls in between 2300 and 2400, he's going to be given with the title FIDE master. And we have international master for this range. We have grandmaster for this range. And if the rating is lesser than 2300, then we're gonna give him the title of future grandmaster. Actually, there is no such title called future grandmaster. Just that this is the minimum expected rating for any kind of title in the chess world. So if the rating is less than that, then we're gonna assume that he will be a grandmaster pretty soon. And else, if none of these conditions are met,
then that probably means the rating is way greater than or greater than the 3500, which is the max rating which we have here. In that case, we're going to call him a human computer. So let's see how it goes. Let's run the program. Okay, I'm going to enter the value 2444. He is an international master because the number which I have just entered falls within this range, and the control entered this block and executed. Now let's try to give something like 2600. Let's rerun the program. Here's a grandmaster. Great. Let's expand the file. Now I have intentionally left a bug in this logic. Could you find it in, say, a couple of minutes? Pause the video and try to find the bug. Okay, let's see what the issue is. Let's run the program. I give the rating of 2500. He's certainly not a human computer. He's supposed to be grandmaster. What is the issue? We said if the number falls in between 2500 and 3500, but what we didn't say is if it is equals, if the rating is exactly equals to these numbers, what should be the rating? So what we need to do is, if number is greater than or equal to 2200, then it's supposed to be candidate master. If the rating is greater than or equal to 2300, FIDE master, etc. I believe this is supposed to be 2200 because that's the minimum rating we have. That's a quick fix. Sorry about that. We're good to go. I think we're in good shape. Let's run the program again and try to see if that works. If by entering 2300 would give us FIDE master, we're good. Alright, in this video we're going to talk about while loop. First of all, open this file named whileloopexample.java, and in that you will see this syntax. You must probably be seeing the code written already. What I would suggest is you get rid of the code and try to write from scratch along with me. Now this is the syntax we use for while loop. We had already talked about while loop in the beginning of this chapter when I explained it on the whiteboard. Now this is the syntax. We use the word while and then the expression. This expression should result in a Boolean value. If this expression results in false, then we're going to come out of this loop. If this expression is true, then we're going to get inside this block and execute this set of statements. We keep on entering this block and execute whatever the statements are inside this till the condition is not met or till the condition becomes false. Now let's take a look at one good example of while loop. I'm going to consider the same example we've talked about in the beginning of the chapter, the robot example. What we're going to do here is the robot will try to attempt to start the car with max attempts of 10. If it succeeds before 10 attempts, then we're going to get out of this loop. Let's see how it goes. Again, we're going to be needing the user to give some input. Let me paste that code here. Let me fix the error. In addition to these 3 lines of code, we also have a couple of variables defined. The max attempts is the maximum number of attempts that the robot will try to start the car, after which it will simply give up. And count is something that we're going to use in our logic. This is basically to keep track on the number of attempts happened. The attempts is something that the user will give, which actually tells the logic in how many attempts will the car start.
In order to save your time, let me copy paste the code. Let's do Alt Shift F so that the code will have proper indentation. So first of all, let's talk about these two blocks in here. We have an if condition and it will check to see if count is equals to attempts. If this condition is met, that means the car is going to start. So we're going to send a message saying robot successfully started the car and count attempts, number of attempts. We use the keyword break to break out of this while loop. We had already talked about the keyword break earlier in this chapter. Now we have another condition. It will check to see if count is equals max attempts. That means robot tried maximum allowable number of times and then it needed to give up. So we're going to print the message robot has failed to start the car, and automatically we're going to come out of this loop. We don't have to use the word break here because this condition will become false and we're going to get out of this loop. Now this is the post increment operator. Every time we enter inside this block while loop, we're gonna keep incrementing this count just to keep track on number of attempts happening. And that's it. Let's try to run the program. In how many attempts will the car start? Let's say 13. Note that 13 is greater than the maximum attempts. So ideally, the robot should give up trying in 10 attempts. Let's see the output. Let's press return or hit enter. And if you see, let's expand this by double clicking it. Robot indeed tried 10 times. Robot is attempting to start the car, and we see that message 10 times. Finally, we displayed the message that says robot has failed to start the car. That's because we gave 13 here, because the car is going to start in 13 attempts, which is greater than the max attempts. Now let's give another try. This time I'm going to give 3. I'm going to tell the logic that the car will start in 3 attempts. Let's hit enter. So the robot tried 3 times, and after the 3rd attempt it has succeeded. Robot successfully started the car in 3 attempts. Of course, this program doesn't make a lot of sense, but in real world programming, it's not human who's going to give this value. It will be dependent on the machine logics, which is pretty complicated, way out of the scope of this chapter. So the intention here is to explain the while loop, and I hope you understood what it is and what we're doing here. We have another construct called do while loop. Let's see what it is. The do while loop has the following syntax. The only difference between while loop and do while loop is we execute the statements at least once before checking the condition. Now in this chapter, maybe in next video, we're going to talk about how it makes sense to use do while loop instead of the while loop. But for now, let us try to understand what do while loop is. I'm going to use the exact same piece of code in here and make little amendments. Let's copy this code and paste it over here. The only difference here is we need to take out this while condition, Control X, and paste it over here and use the keyword called do. And this statement, this is a statement, and we end this with a semicolon. Alright, we're good. Now this will do more or less the same thing what we have seen in the while loop example, but the difference is without checking the condition, we're going to execute this block of statements at least once. If you run the program, you would pretty much can expect the same results as to that of this program. Again, we'll talk about the differences between the while loop and the do while loop. We'll understand when to use do while loop and when to use while loop etc. Now we have another looping construct. Let's see what it is. It's called the for loop. The for loop does more or less the same job what while loop does, except it will look more compact and improve the readability. And not just that, there are some additional advantages with for loop, and definitely sometimes it makes sense to use while loop instead of for loop, and vice versa. We're going to talk about it in our next video. But for loop has the following syntax. It has initialization. In here we'll initialize a variable, the termination or the expression that would result in either true or false, and then increment and decrement statement. Let me show you with an example. I'm going to use the same code which I had used in the while loop. Sorry. I'm going to copy this and paste it over here. I press Alt Shift F to give proper indentation. First thing is to change this keyboard while to for, and we're going to get rid of the count variable from here and put it in here. Let's get rid of this. And we'll also get rid of this post increment of count, Control X, and paste it over here, separating with a semicolon. So this is it. This is exactly how for loop looks like. Now this will do exact same job what while loop did. If you run the program, you would see the same results. Let's run the program. I would say 3, the same results. So for loop looks more compact and more readable. So now that we have learned 3 different looping constructs, in our next video we're gonna see when to use which looping construct. In this video we're going to take a look at the differences between for loop, while loop, and do while loop, and we're going to understand when to use which looping construct and depending on what circumstances. Obviously you can always use while loop instead of for loop, and you can even use for loop instead of while loop, but it's always advisable that you follow best practices. As a rule of thumb, always try to use for loop instead of while loop whenever applicable. One reason for that is it looks a lot cleaner and more readable. For example, you write your program today and you come back on this code a year after, and you will thank yourself that you had used for loop because it looks a lot cleaner, and you'll get a glimpse of what this loop is doing just by looking at this line of code. Because this line of code has all the major statements that will define this loop. Now, just by looking at this statement, we're going to say that we're going to loop through this block of statements again and again for n number of times. In this case, it's array.length, the length of an array. So we're going to loop through this for loop 5 times. If you would have used while loop, then all these 3 statements must have been scattered around. And let's say you forget to define this, or you forget to increment the counter, then we will lose the track on number of iterations, and hence the logic will result in infinite loop. So there is a chance that you're gonna miss one of these statements and break the code. We can minimize that using for loop. So now that's one major big difference. So it's always advisable that you use for loop instead of while loop whenever possible. So what else could be the reason where you need to use for loop instead of while loop? Is when you know ahead of time how many times you're going to loop through this statements. By that I mean, if we run this program during the compile time itself, the compiler will be able to figure out how many times it needs to enter this block of code. And since the compiler knows ahead of time, it's going to make copy of this set of statements inside this block. In this case is just one statement. That way it will make the job easier for the JVM to run the program. So that will improve the performance aspect as well. Not much though. And another good reason why you need to use for loop is because of the lines of code. The lines of code will decrease if you use for loop instead of while loop. Obviously, because all the statements will be scattered around multiple lines, and in this case it's just in one line. Just for your information, lines of code is one of the metrics used to evaluate the quality of the code. Now we have while loop. So when to use while loop? You can use while loop when you don't know ahead of time how many times you're going to loop through the statements. For example, take a look at this example. If you wanted to maintain a backup files from your local PC to a remote server, then you need to have a logic that looks somewhat like this. You're going to say while true, okay, and then you come inside that block, and if new file is present in your local directory, then copy that file to the backup server, and we'll wait for 1 hour. So what this piece of code is essentially doing is this code is running forever. When we say while true, that means the condition will always be true, and we're going to enter this block again and again every 1 hour, because we have a timer set to 1 hour here. And every 1 hour we're going to check to see if there are any new files added in your directory, and if so, if there's a new file present, then we're going to take a backup by copying the file to the remote server. So this is one place where you want to use the while loop instead of for loop. During compile time, we don't know how many times we're going to loop through because in this case it's just infinite. User have to terminate it manually, or you will have to have a condition here that says stop this operation after say 1 or 2 years, and we need to break out of this loop. Another reason why you want to use while loop is when you are say copying a text from a file to another file. Then we're going to loop through and copy each and every line till the end of file is reached, or till there are no lines left. So if it is not end of file, that means there are still lines to be copied. Copy that particular line. Again, we're going to come back here and check if we reached end of file. If not, go to the next line and copy that line to our destination file. Obviously, we don't know ahead of time how many times we're going to loop through. We don't know how many lines of text is present in the source file. In this case, it just makes sense to use while loop. Let's take a look at another good example. The while true statement will be used very often in animation field. For example, whenever you play any game, if you're seeing a moving character, chances are that they would have used the while loop construct in this manner. We will have a while loop true, that means this is going to be an infinite loop, and we're gonna say keep walking. You got a cartoon character walking or whatever, and when the user presses exit or maybe escape key or control C or whatever is the key to get out of the game, or maybe to quit the game, will break out of the loop as well. So this is another logic where you want to use while loop instead of for loop. And obviously, as I've mentioned, you can use for loop instead of while loop even here, but it makes more sense to use while loop here. So always use for loop when you know ahead of time how many times we're going to loop through. If you don't know, then use while loop. And I gave you some examples on when to use while loop. Now we have a do while loop. As we had discussed, it's going to perform the action first, or execute the block of statements, and then we'll check the condition. One good reason why you want to use do while loop is demonstrated here. What we're doing here is we're going to take the input from the user, and we're going to check to see if the user entered number is in the multiples of 10. If so, we'll quit out of this program, or we'll get out of this loop. If not, we're going to ask him again
to enter a number which is in the multiples of 10. Try to accomplish the same thing with while loop. First of all, let's see how this runs. I'm going to enter some value, say 8. Now 8 is not a numerical in the multiples of 10, so let's hit enter. We're going to get prompted with this message once again to enter a number which is multiples of 10. Let's enter 88, or let's say 85, and let's enter 90. Now this should get us out of the loop. It did. Now try to accomplish the same thing with while loop. Chances are that it will get either complicated or not possible. In this video we're going to talk about the continue statement. We had already taken a look at the break statement. The break statement will break out of the loop or exit out of the loop, but the continue statement will continue with the next iteration, skipping the current iteration. That means it will not let Java execute the instructions that come afterwards. Let me show you what I mean. Take a look at this program. We have an array defined here. We're just looping through all these array elements one by one, and we're just checking if the number is not divisible by 10. If it is not divisible by 10, then we would just want to simply continue. That means skip the current iteration. And that would result in not executing the instruction that come afterwards. In this case is just 1. So by running this program, the output would constitute only the numbers that are divisible by 10. Let's see how it works. There it is. Now take a look at this program and try to understand what I've just explained. Now let's take a look at another example of continue statement, but before that you need to understand what's a prime number. As per definition of a prime number is either divisible by 1 or by itself. Now we have a logic here that will determine if the given value n is a prime or not. To explain this better, let me pull the whiteboard. Let's say we have a value n, 7. Now the numbers that come in between 1 to 7 are 2, 3, 4, 5 and 6. If we divide this number n with all these values such that if that results in the remainder of 0, that means the number n is not a prime number. Is 2 divisible by 7 so that it would result in the remainder of 0? No. Same is the case with all the other numbers. So that means 7 is a prime number. Let's say we want to take 9. In that case, 9 is divisible by 3. So 9 is not a prime number. Now how do we write this logic programmatically so that we provide a value or a number n and the program will determine if it's a prime or not? We're simply going to use a for loop. For int I equals 2, I is less than n, I plus plus. Now let's say I have the value as 8. So we're going to loop through how many times? We're going to loop through 2, 3, 4, 5, 6, 7. We're going to loop through this for loop 6 times with each one of these values. And in each iteration, we're going to check to see if n percentage the value I results in 0. And we have a block of statements to be executed here. If we enter inside this block at least once, that means the number n is not a prime number. Well, if we didn't, then that means the n is a prime number. Now let's go back to our workbench. We have more or less the same logic here. just take a minute and go through this logic. Now let's find out if the value n, which is 3343, is a prime or not. Let's run this program. It is indeed a prime number. Now let's comment out this part. And uncomment our actual code that explains the use of continue statement. Now in this program, what I'm doing is we have an array, and I just wanted to loop through all these array elements and find out which one of them are the prime numbers. So we're going to use two for loops for this. The first for loop is for looping through all these elements, and second for loop is to determine if the current number that is in the current iteration is a prime number or not. So this is essentially the same logic what we have here. Now in case this condition is met, that means the number is not prime. So what we want to do is, instead of printing it, we're just saying continue outer. This is very important because we named this block as outer. When we say continue outer, it's just going to skip the current iteration of this for loop, and it's going to go ahead with further iterations. So by doing this, we're not executing the instructions that come afterwards. In this case, it's just one instruction, that is to print the number. So if we run this program, we're going to see the prime numbers out of this list. Run the program. There it is. And just for your information, 2 is also a prime number. It's the only even prime number. Alright, in our next video, we're going to talk about the switch statement that will summarize our chapter on the control statements. In this video, we're going to talk about the switch case or the switch statement. It has the following syntax. We're going to have a variable, and based on the variable, we're going to execute a particular block of statements. If the variable says it's C1, then we're going to execute the case C1, and we'll execute all the statements that come within this block. We have a break statement that acts like a delimiter for each case. Similarly, we can have any number of case statements. And finally, we'll have default. If none of the case matches, then we're going to execute this set of statements that are part of this default block. You will better understand this when we look at the code. So here's the code. What we're doing here is we're going to prompt the user to enter a value. In this case, it's an integer value. And depending on what he enters, we're going to choose the operation to be performed. We have a couple of variables declared here and initialized. Now if the user enters 1, then we're going to find the sum of these two integers. If he enters option 2, then we're going to do this operation. If he enters 3, then we're going to multiply both these variables. If the user enters anything other than the given options, which are in this case 1, 2, 3, then we're going to go ahead and display a message that says invalid entry. So let's see how this program works. I'm going to give the option of 2. Enter 2 to find out a minus b. So I'm expecting the result as 5. We're good. Let's run it once more and give an option that is not listed here. Let's say I want to enter 7. Invalid entry. Great. Do take a note that we're only supposed to enter integer value here in this case. Let's run the program once again and see what will happen if I enter something other than integer. Let's enter a. So that would result in an exception. We'll understand about these errors, exceptions at later chapters, but for now you're not supposed to enter anything other than integer. because that's what we have here. And it doesn't necessarily have to be an integer. It can also be byte, short, char. These are all the supported primitive data types for switch case. And this doesn't have to be 1, 2, and 3. This can also be like 11, 22, or maybe 34. The program still works as expected. And one key thing to note here is, let's undo it. And one key thing to note here is we have a break statement, and it's mandatory that you delimit each and every one of these cases with a break statement. It's very vital. In case if you remove this break statement, then the control just keeps flowing down the lines. Let me show you what I mean. Let's get rid of these break statements. Let's save the program and run the program. Now once again I give the option 2. The expected result is 5, but see what will happen. I'm sorry, I'm supposed to give option 2. Let's enter 2. We got the result as 5, but in addition to that, even these two statements got executed. So we got 50 as well as the invalid entry, which we're not expecting. Let's undo and save the program. You can also use if-else clause instead of switch case, but you have to decide which one is best, which one looks more readable, and which one performs better. Coming to performance, let me explain you something. Let me pull the whiteboard. Let's say we need to write a program where the program takes in an input from the user, and the user has to enter a value between 1 to 12. Depending on what he enters, we're going to print the corresponding month. Let's say if the user enters 1, then we're going to display January. If the user enters 11, then we're going to display November. Now let's see how we can accomplish this using if-else. We're going to say if entered value equals 1, then print January. If value equals 2, then print February. And we keep writing this for all the conditions. And in our else block, we're going to say invalid entry. That means user has entered something that is beyond the number 12. Now coming to switch, we're going to say switch month, and we're going to have a case 1 to print January, break, and case 2 to print February, break, so on and so forth. And we're going to have one last case which is default, that says invalid entry. Now during the runtime, that means when we run the program, let's say user entered the value 12. In case of if-else, it has to go from the line 1. It has to check to see if the user entered value is equals to 1. No. Is it equals to 2? No. It keeps going until the condition is met. So the control has to go through all the if conditions and check to see if any of those conditions is met. Now coming to switch, it's just going to directly jump onto the exact case which needs to be executed. So we're saving quite a lot of time here. So there is a performance benefit when using switch instead of if-else. Now let's go back to our workbench. Even in our previous example, let's go back to the continue statement example. So instead of writing the code in this manner, we could just say we want to print the value in case if the number is divisible by 10. So this would essentially give us the same results. Let's run it. There you go. But it's you who have to take the call on which one looks much better and which one makes more sense. So that summarizes the switch statement and the control statements chapter. See you in my next video.
In this video, we're going to talk about switch expressions, which you can think of it as an enhanced version of the traditional switch statement. What I have here is a traditional switch statement with bunch of cases, and what I'm trying to do here is we're going to activate one of these cases based on the integer value. If I say 1, that's going to correspond to Sunday. If I enter 2, that's going to correspond to Monday, and if I enter the value 7, that's going to correspond to Saturday. But there are certain problems in here. Number one, the code is taking too many lines of code, and number two, there is a risk of so-called switch fall through. For example, let me just run this program. Since I've entered the value 2, this should print Monday. And it did. But let's say that I've forgotten to put the break statement and save the file. What happens is the control won't break and it would just continue executing the other cases. So this is going to yield some bad results. So 2 shouldn't correspond to Tuesday, but it was printed. Another problem is, let's say if I enter some value like 12, there is no default switch statement to take care of that, and it's going to return null. So let's write a switch expression and see how it's going to solve all these problems. I'm going to directly assign the switch statement to this, and I'm now actually going to use an arrow, which is a specially introduced operator, just like so. I'm going to do the same for rest of the cases as well, and of course we can actually get rid of the break statement as well. It would be taken care automatically. So with this, not only are we going to get rid of the switch fall through problem, but if you hover your mouse over this error, it says add default case. It's mandatory. So in an instance where none of these cases match, then the default case would be executed. Let's end the statement. And everything would work as usual. So this has returned NA, whatever we had entered. If I enter the value 2, then this worked as well.
In this chapter, we're going to talk about classes and objects. And in this particular video, we're going to get a glimpse of what classes are and what objects are. Now, I have a confusion between classes and objects as to where to start from. Should I start explaining about classes or should I start explaining about objects? But I thought it would be better to start with neither. Instead, I would start with methods. Now, if you go take a look at other tutorials, they may start by giving the definitions of classes and objects, which I feel at this point of time you may not be able to understand. My way of teaching is different. I'm going to give you a real-time example,
and from that you can easily make out definitions. That makes more sense. Anyway, let's get started. Let's talk about methods. Let's say we have an e-commerce website, something like eBay or Amazon, that was written using Java, and let's say our code, our source code, constitute of 2000 lines of code. It would probably be exceeding 1 million lines of code, but just for the sake of explanation, let's assume so. And the entire code is under one block. Now within this code we might have a set of instructions spanning across 10 to 20 lines that does a particular task. For example, add product to the cart. And there could be another set of instructions that does delete product from the cart. And there could be instructions on applying the coupon, or something like make payment, etc. Now we have a problem here. We are lacking code readability. Let's say you wanted to perform the same operation, add, at later point of time. Then you're going to write this set of instructions, 10-20 lines, again somewhere over here. That's going to increase the complexity and reduce the readability. The new programmer who will take a look at your program will definitely curse you. So what is the solution? We're going to create methods. If you are aware of functions in other programming languages, that's nothing but methods in Java. So what we essentially do is we're going to take out this set of instructions that does a particular task, separate it out, put it inside another block, and we're going to name this block something like addition or something like that. And whenever we need to execute this set of instructions, instead of writing all those 10 lines, we're just going to simply call this block of statements using this name, addition. Similarly, next time you'll have to do the same set of operations, then you're going to simply call this block using this name again. That will reduce 2000 lines of code into 50 lines. This will increase the readability. Also, the code is more organized. And this block of statements that I'm talking about is nothing but methods in Java. Now let's try to form a definition of a method. A method is nothing but a set of instructions in a block that does a particular task. And that block of statements will have a name tag to it so that we can use it to execute those block of statements. Let's go to our workbench and see how this works. Open the file named classes and objects under the project classes and objects. Now I'm going to simply copy paste the code from switch statement example that we talked about earlier. I'm just going to copy the code inside this block, the main block. I do Control C and paste it over here inside this main block. I'm going to save it. Now let's say we want to separate this statement out and put this inside another block. The first thing is to take this statement. This could be one or more statements, but in our example it's just one statement. We're just going to do Control X and we're going to take that statement out of this block like this. Now what we're going to do is we're going to call this statement or statements from here. How do you do that? We need to give the statement or the set of statements a name. So for that we need to create another block using curly braces, and we're going to give it a name, something like addition. Now this block of statements is not aware of these two variables a and b, because a and b are initialized over here in a different block. So the scope of this variable are within this block. So what we're going to do is we're going to give parenthesis, something like that. And we're going to send these two variables from here. So first of all, let's put this over here and send a comma b. And since this is a statement by itself, we're going to end with a semicolon. We have sent a and b here, but we're not receiving it here. How do we do that? We're going to give the type of the variable int that we're expecting, int a and int b. Now this block of statements will be aware of these two variables a and b. We have another problem here. What's that? Whenever we execute a certain block of instructions, we're going to expect something out of it. Sometimes we don't. Here we're just doing system.out.println a plus b, and we're printing it. In this case, there is nothing that we want to give back to the block where we're calling this method from. So what we do is we say void, which means I'm not sending anything from this block of statements or from this method addition. In case if you want to send something, then you might want to use the keyword called return. We'll talk about it in detail at a later point of time. So for now, this is it. We have a proper method declared or defined, whatever you call it. There's one little twist here. Since this is a static block, we didn't talk about static block, but we will in a while. This has to be static. We'll talk about static keyword later point of time. But this is it. Now this will essentially does the same thing what we're doing here. But in this example, we just have one instruction. Let's say these are 10 or 20 lines of code, then that would make perfect sense to use methods instead of writing the code over here. If you run this program, it's going to yield the same result. Let me save your time by not running it. Great. Now we understood what method is. It's essentially a block of statements that does a particular task, and we're going to give that block of statements a particular name so that using that name we can execute that block of statements anywhere in the program. So next time we want to execute this set of statements, we're just going to do copy paste of this, Control C, and maybe we're going to put it over here. By the way, that's illegal to put it over here. Let's save the file. Great. Let's go back to our whiteboard. Now obviously we don't want the entire code to be under one file. Think about Amazon or eBay, where the source code would be in millions of lines of code. How could it be possible to manage the code if it is under one single file? Probably the entire code is split across multiple files, class files. So what we're going to do is we're going to create multiple files, essentially class files in Java. Say we're going to have a class file called product that has the methods that are related to product. For example, add product, remove product. And we're going to have another class that's going to do checkout. And this may constitute methods like apply coupon or maybe make payment. Now let's understand this in our example. So what we'll do now is we're going to take this method out of here to a different file. So for that we need to create another class file. So let's do Control C and Control V. That will create a clone of this class. We're going to name this class as maths class. I'm going to click refactor, and we're going to get rid of this entire code in here. In fact, we're going to get rid of this entire block altogether. We don't need main method here. For the entire application, we'll be needing only one single main method. We'll talk about it later. But now let's move it over here first. I'm going to do Control X, cut it from there and paste it over here. We definitely will have an error here because the method is no longer existing here. So how do we call this method residing in another class? This is how we're going to do. I'm going to say somewhere over here, math obj stands for object, and we're going to create a new object using the keyword called new, and then again maths, typo error there. So what did we just do? We created an object. Ladies and gentlemen, welcome to object-oriented programming language. This is what is object. Of course, we're going to talk about it in detail in a while. Now, using that object, we can call that method by doing object.addition. Let's continue in our next video. Let's continue. Not sure if you have observed or not, but we've been using classes, methods, and objects already. What does this out.println mean? Out is nothing but an instance of a class, and we're just trying to call a method inside that class. What this method does is just going to have some instructions that will print the statement on the console. And the main that we've been talking about is nothing but a method with some arguments. We're going to talk about this statement pretty soon. And in here, classes and objects is nothing but a class. So knowingly or unknowingly, we've been using all these throughout our examples. Now these variables in here doesn't necessarily have to be inside this method. It can also be inside a class within this block. Let's try to do the same thing in our maths class. So we can have int x equals 10. We can have int y equals 20. And you can have a method. By the way, we don't need to have static in here. Should have fixed it in our previous example. See, we don't have any error here. That means we're good. I'm going to do Ctrl S, save. We're going to create another method. Void, let's do product of x and y. We're just going to simply copy paste this line and do it's x multiplied by y. Let's do Alt Shift and F. Alt Shift and F, that will indent the code. That looks better. Now using this object, you can also invoke this method. Now note that we don't have any arguments in here. We'll talk about syntax of methods pretty soon in our next video maybe. But yes, this is it. Let's try to understand a little bit more about classes and objects. Why is this called an object? This is somewhat similar to real-world objects. If you're talking about real-world objects, it has two things. One is the state and the behavior. Let's think about a dog. A dog will have a state of height. It can have a state of breed, or it can have a state of color. Coming to its behavior, a dog can walk, or maybe running, or maybe sleeping, etc. Let's take another example. Let's talk about a car. A car will have a state of brand name. A car will have a state of number of seats available. Coming to its behavior, start the car, stop the car, or change the gears, etc. An object in programming world does have a state and a behavior. When I'm talking about a state, those are nothing but the fields that we initialize or declare here.
Coming to the object's behavior, the methods that we write here are nothing but an object's behavior. We can have multiple objects from a single class. Let me explain you in detailed fashion. Let's go to whiteboard. Let's say you have a land of 10 acres. Now what you want to do is you want to construct 100 houses. All these 100 houses are constructed based on one single design. This design is nothing but a class, and all these objects that use this design are nothing but instances of this class or objects. So now let's try to form definition of a class and an object. A class is nothing but a blueprint of an object, or a template using which you will manufacture multiple objects. Whereas an object is an instance of a class. It will have the state of number of bedrooms available, or the color of the house. It can have a behavior of add tenants, remove tenants, check mailbox, etc. Let's go back to our workbench. Just as in our example, we created multiple objects, we can also create multiple objects of math class. For example, we can say object 1. So essentially what we did here is we have two objects but are identical. Objects doesn't necessarily have to be identical. Let me explain you what I mean. Again, let's go back to our whiteboard. Although all these houses are based out of one single design, that doesn't mean all these houses should stay identical. They can vary in terms of color, number of bedrooms available, etc. So when we're trying to create an object, we'll also set its state. And we'll give the values like number of bedrooms available or the color of the house, etc. Going back to our workbench. Sorry about the frequent switching. Now let's get rid of this. So how do we set the state of an object? We used constructors. Let's talk about it a little bit. A constructor will have the similar syntax as to that of methods. We haven't talked about the syntax of methods and constructors. We will in our next video. But constructor will have the same name as to that of the class name in which it is residing. So we'll simply say maths, and then that's it. We have a constructor here. And instead of setting these values in here, we're just going to get rid of all these initializations, and instead we're going to send parameters to this constructor. We're going to say int, say d, comma int b. All right, let's say k. X equals d, y equals. Now this should bring us an error here. So what's going on? Whenever we create an object, it will definitely call the constructor first. If you don't create any constructor, by default a default constructor will be considered. What's a default constructor? A constructor without any parameters and without any content inside it is nothing but a default constructor. So what is the purpose of it? Let's say you have a class called dog. Then let's say you have a field called height. If you don't set anything, constructor will do that for you. It will give the initial state of the dog. It will set the default value. It will set the value to be 0 if it is an integer type. Now since you gave your own constructor with parameters, the default constructor will no longer be considered. You'll have to write another constructor which does not have any parameter. If you don't write one, then at least send some parameters in here with object. So we'll send 10 and 40. So the moment this statement gets executed, we'll set the state of this object as x equals 10 and y equals 40. So now think about it in this way. Let's say this is a house class. We can set the number of bedrooms and the color of the house using a constructor. And throughout our program, we'll use those particular fields. So what do I mean by that? Had this been a class called house, then you can have an object, a house object with say number of bedrooms 3, and you can have color as red. We can have another object 2 of house with number of bedrooms as 2 and color as green, something of that sort. You can have as many objects, you can create or manufacture as many objects as you can. So that's what is the job of a constructor. Now I hope it makes sense. You can run the program, you can play with this program in whatever way you want. You can also say object dot product to print the statement. Alright, see you in my next video. Let's talk about methods and constructors a little bit. For the sake of explanation, I have created another class, and that has the code exactly what we need. I have two variables and an object of class maths, and using that object we'll be able to execute this method addition, which is residing in the maths class. This essentially means we're triggering the behavior of that object. Now in here we're sending two parameters to this method. This is not mandatory. You can also get rid of this. You can also get rid of it. Let's save the file. By the way, I guess we have errors here because these two parameters are no longer available. Instead, what I'm going to do, instead of finding the addition of a and b, I'm going to find the addition of x and y. I'm going to save the file. Oh, this is going to bring an error here because in this method we're not receiving anything, so we should not send anything. We'll get rid of this. I'll save the file and let's try to run the program. What is the result expected? While creating the object, we're also calling the constructor in here, and we're setting these values just as I explained in my previous video. So the result that I'm expecting is 50. Let's try to run this program. By the way, I guess we have an error here. Let's get rid of this. I don't know what it is. Okay, we've changed the method here so it would impact here as well. Now take a note of this. Changing anything in here will actually impact everywhere else. Now we're going to talk about that problem and its solution pretty soon when we talk about access specifiers. But for now, let's make the change. Now we run this program. Run file. This will give us 50. Well, hopefully. No, it will. 50. Great. Let's expand this. So we can also have methods without arguments at all. Methods can also have a return type. What do I mean by that? I don't want to print this here. Instead, what I want to do, I would like to return the result. And when we return something from this method, we're also going to say what we're returning, which type of data we're sending back to the calling method. In this case, it's integer. So I'm going to say int. And if we're sending something, we also receive it over here. So we're going to have another variable, maybe int c. Actually, we're going to get rid of this a and b because we're not using them. So I'm going to say int a equals 0, and I'm going to assign a value to that a. What's that value would be? Whatever I'm returning from this method. So we're calling this method object.addition here, and whatever is being returned from here, we're going to receive it, and I'd like to print it. System.out.println. Let's print it. Let's run the program and you would get the same result. There you go. Now let's take a look at the syntax of methods and constructors. A method will have the following syntax. It will have an access modifier, which we'll talk about
at later point of time, so ignore for now. We're going to have a return type, which I have just looked at. A return type can be of any type. It could be a primitive data type or a user-defined data type. We'll talk about user-defined data type pretty soon. We're going to give a name to that method, and we can have no or any number of parameters. And within this block we'll have some code with optional return statement. If the return type is of void, then probably we don't need to return anything. If this is of type int, then probably we should return the integer from this method. Now coming to constructors, the syntax of a constructor is no different from method, except for a constructor there won't be any return type at all. It will have access modifier, it will have a name, and the name supposed to be and should be exactly the same name as to that of the class in which it is residing, including the case. There won't be any return statement because we won't have any return type here. So essentially this is the syntax of a constructor. Okay, now let's go back to code and talk about one important thing. You can think of math as a user-defined data type, just as int. Int is a primitive data type, maths is a user-defined data type. Now when we have this statement defined, we can literally use this object just as any other data type, like int. So that also means we can also return an object from this method. This could be of any data type, including user-defined data type. The maths in here is just a user-defined data type, and you can use the same way you use a primitive data type like int. Alright, this might sound a little confusing. I'm going to clarify it in next 2-3 videos. See you in my next video. I'm not sure if you're aware of this, but we do have a psychology tracking system. Each and every one of our video will go through this system to make sure that the viewer is able to understand the concepts clearly. If the rating is below 9 out of 10, then that means the explanation needs to be improved. The rating that I got for my previous 2 videos is 7.5. That means some of you must be having some kind of confusion around these objects and classes. So this particular video I'll try my best to bring clarity on it, and even in my next video we're going to get into the technicalities of it, and you will definitely better understand the concept. Okay, now take a minute or maybe pause the video and try to figure out the output of this program. Okay, let's move on. We have created an object 1 and we're calling its constructor with the values 10 and 40. This is a parameterized constructor, and these 2 parameters we're just simply assigning to these variables x and y. And when we execute the statement, it's object 1, which is this, dot addition will invoke this, and it will find the addition of x and y. So what's the expected output here? It's 50. Now coming to second object, we're creating a new object altogether with different value, 20 and 20. So the values of x and y would be 20 and 20 for this particular instance. So this is one story, this is a different story. I'll bring you clarity on this in my next video, where we get into some technicalities and see how memory allocation is done. Remember our example on houses? Using one single template we create multiple houses. In the similar fashion, we're using single class to create multiple objects. We have 2 objects in here, and each with a different state, just as I have explained in that example of houses. You may want to revisit that video if you wanted to check that out. But in here for object 2 we have 2 different values, 20, 20, and the result of addition would be 40.
for this statement. We have object 3, for which we're assigning object 1. So object 3 will constitute the same values 10 and 40. This is somewhat more or less similar to int x equals 10, int y equals x. This is somewhat similar. Remember I said this is like a user-defined data type and this is primitive data type, and you can use this user-defined data type just as primitive type, and hence even assigning is possible because object 1 and object 3 are of same type, maths. So what's the value, what is the result of this instruction? It would again be 50. Object 4, we're assigning object 3, which in turn is being assigned to object 1. So the result of object 4 should be same as well. Coming to object 5, we have, instead of assigning the values, I'm just trying to take the values from the object 1. When we created this object, we have actually assigned the value 10 to the variable x. So this would be 10 and this would be 40. The result of this statement would be 50 as well. Let's try to run the program. See, just as we expected. See you in my next video. In this video, I'm going to talk about stack memory and heap memory. Remember this toy from your childhood? How do you take out the yellow ring from this? You'll first take out the blue ring and then you'll take out the green ring. Only then will you be able to pull the yellow ring out. This is sort of like a last in, first out, which means the last one that comes in is the first one to go out. So this is called stack approach, and it follow last in first out approach, LIFO. Java follows the similar methodology to allocate memory while we run the program. So we'll have a stack and it will have sections in it. Each of this section will be dedicated to one particular thread. You can think of thread as a single process, very small process. Or you can think of it in this manner. Let's say I created an object and I say object.m1. I call method m1. Now a section will be dedicated for that method in this stack. So let's see how it's done. Let's get into the internals. Now take a look at this. The execution starts from the main method, and main being a method, a section in the stack will be dedicated for it, for main. Java Virtual Machine uses this section to store all the variables that are local to the main method. In this case, x and y are the local variables that are local to the main method, and these variables will have the scope within that method. Whatever are the variables that have the scope within this method will be residing here. In this case, it's x, just 10, and y, 20. And the interpreter goes line by line. We'll talk about this line pretty soon. When the interpreter comes across with this line, object.m1, we're calling another method. So another section will be dedicated in the stack for method m1. And whatever are the variables that have the scope of m1 will be residing here. In this case, we're sending one parameter x. So we're taking it as parameter p, and the value of that would be 10, because that's what we're sending here. Interpreter enters inside this method and it starts executing lines in it. This is supposed to be m3. When the interpreter comes across with m3, we're calling the method m3. And since this is another method, A section will be dedicated for it to store its local variables, and local variables will be residing here. And once interpreter comes to the last line of method M3, it goes back to method M2 and it will continue with execution of further instructions in the method M1. Now at this point, since we're done with M3 method, even the memory will be freed and is available for future processing. Once the interpreter comes to the last line of method M1, it will go back to the main method and it will execute the remaining instructions. Once it returns back to main method, even M1 method will get freed, and whatever are the variables that are inside this will be lost as well, because we're done with operations that needs to be performed on those variables. Now once we reach the end of main method, even this memory will get freed. When we have nothing in the stack, that means we're done with the execution of the program. Now let's talk about this particular instruction. We have a heap memory as well, in that we'll store objects, and each and every object will have a location, an address associated with it. This address in here is used to locate that particular object. Let's get into the details. Let me go to a fresh page. Now take a look at this. We have a new keyword used. This particular section in this instruction will create an object in the heap memory. And take a note that we're passing some parameters to the constructor of the maths class 10 and 20, and we're setting the instance variables. And these two variables are instance variables, and they're not local to any method. They are specific to an instance. Hence, this will be stored in here. Maybe A is equal to 10, B equals 20. And in order to identify this object, there will be an address associated with it. Let's assume it's 0101. Now do take a note that the obj in here doesn't hold the object itself. It will hold the reference of that object. Let me explain you what I mean. Let's assume that this is inside a main method. So we'll have a stack created and a section will be dedicated for main method. Now we'll have this obj created in here. And what's the value in it? The value of it would be 0101, which is the address where this particular object is residing. So this is also called as a reference type, because it will have information on where the object is residing. But this obj doesn't hold the object by itself. It will just have some information about where the object is residing. And the scope of this obj is also within this main method. Once this particular section pops out of the stack, then the reference of this object is no longer available. In our stack memory, we store the primitive data types as well as the reference type. You can hear terms like reference type, non-primitive data type, or user-defined data type. They all essentially mean the same. We're talking about a reference variables in which its value would constitute the address where the object is residing. So whatever is residing in the heap will have a global access. That means even though there is nothing left in the stack, we could still have some objects hanging around inside this heap memory, at least for some time, until the garbage collector comes in and cleans them up. We'll talk about garbage collection in a moment. But this is how it works. Let's take a look at another example to bring you more clarity on this. Take a look at this. Okay, let's go line by line. We have created a new object with the keyword new, so that will create an object inside the heap memory with the values 10 and 20, because these are instance variables, and we'll have an address associated with it. In our stack memory for our main method, by the way, let's assume these instructions are residing inside a main method. there's a section dedicated for main method, and we'll have reference type defined, and it will have the information on the address where this object is residing, which is 0101. And the interpreter comes to line number 2. We have created a new reference type and we assigned this reference type to it. So we're not actually assigning the object, we're just assigning the address in which the object is residing. So here is how it gets allocated: obj2, and it will have whatever is the value inside this object1, which is 0101. So essentially obj1 and obj2 are pointing to the same object. We're not creating a duplicate object here. Similarly, on the similar lines, we have object3, which is holding the value which object2 is holding, which in turn is holding the value of object. So even we'll have object3, and that will hold the same value. So all these reference variables are holding information on the location where the object is residing. Hope that makes sense. So now the $1,000,000 question: why do we need to store objects in heap memory? The reason is simple. Things will get very messy, as well as it will impact the performance dramatically. What do I mean by that? Whatever are the variables residing in the stack memory are predefined types. I mean, we know exactly how much memory they're going to take upfront, right in the beginning when we compile the program. But whereas the object is JVM specific, the size of object is not certain. It can vary from JVM to JVM depending on the vendor. So it's hard to make a guess on how much memory each object would take. There are a lot of factors that come into picture when deciding the memory allocation done for an object. The type of variables, the number of variables, and we also need to consider the space it takes just to maintain the state of this object or to maintain this object itself. So it gets really tricky in here, and let's not get into it. So now that's number one reason. And number two, let's assume that there is no heap memory at all, and that also means there are no reference type. We're directly storing the object in here. Now take a look at this same example. By doing this, we're not actually pointing to single object. We have to create 3 different objects inside this stack, which is pretty consuming. That's a lot of memory, and each object won't consume 4 bytes or 8 bytes. It's a huge chunk of memory, and we're trying to duplicate the same data multiple times. Instead, why not just have reference type and point them to the actual object like we do? So that's reason number 2. Let's take a look at one last reason why you want to store objects in heap memory. Take a look at this example. For the sake of example, let's assume there is no heap memory. So we'll have a stack and a section dedicated for main method. Again, let's assume this is residing inside the main method. We'll have an object created that will have a huge chunk of information about this object, including these variables, say 10 and 30. Now we're sending this object to this method m1. There will be a new section created for method m1, and its local variable would be the object that we sent. And let's say inside this m1 method, I updated the state of this object. Let's say object.x, I changed this value 10 to 20. Let's assume so. So now inside we'll have an object with the value 20 for x. Once we come out of this method m1, this detail will get popped out of the stack. So that means there is no information related to this method m1. that also means we don't have the details on the updated state. So when we send this object to method m2, a new section will be created, and again the value of x would be 10, not the updated value. This is clearly a problem. We're not getting the updated value, updated state of that object. Hope that makes sense. Now whereas if the object is residing in the heap, as you can guess, everywhere in all these methods m1, m2, m3, we're actually talking about the same object, and we're all pointing to the same object. If the state is updated by method m1, the rest of the methods will get the updated state. Now let's talk a little bit about garbage collection. We'll get into the details of garbage collection in our future videos, but for now, just a quick explanation on it. When it comes to primitive type or reference type, we're cleaning them up the moment we get out of that particular method. In case of objects, there has to be some way to clean them up. Otherwise, the memory of the heap will get full and we start getting some exceptions or errors like Java heap space out of memory exception. So how does JVM solve this problem? It uses a tool called garbage collection. What that does? It's pretty complicated, but in simple terms, if there are no references available in the stack, that means that particular object is eligible to be cleaned. The garbage collection process happens periodically. There is no specific time for it. It just happens periodically and takes a look at all the objects and see if it has any references left in the stack or elsewhere in the memory. If not, then it will just clean that particular object. And that way the heap memory is maintained and it will help in not getting the memory to be full. We also have a way to configure the sizes of heap memory and the stack memory. By the way, if the stack is full, we get the stack overflow error, which I'll talk about it later. Now let's go back to our program, and I bet now you'll be able to understand the concept by yourself. Open the file, methods and constructors. So we have, how many new keywords do you see here in this program? There are 3. That means you can straight away say that we have 3 objects created in the heap memory. In the instruction number 3, we have object 3, which is a reference type and is actually having the same information that object 1 reference type is holding. That means the address of this particular object. Same with the object 4, it is holding whatever object obj3 reference type is holding. So essentially object 1, object 3 and object 4 are holding the same information about the same object. The reference type object 2 points to a new object altogether. Object 5 is a reference type that holds information about a new object and whose state is set based on the object 1. So that this should be 10 and 40. Hope that makes sense. See you in my next video. In this video, I'm going to talk about this keyword. Take a look at this program. We just simply created an object, an instance of a class, maths, and I have sent a couple of values here, 10 and 20, and we're trying to find the addition of those 2 values. Now I'm going to make a small change here. I'm going to change D to X and K to Y. So what does this mean? The name of both local variables and instance variables are both same. Now if I run this program, what is the result that you're expecting? Would get 0. I'll tell you why. Let's run the program. The reason is the compiler could not figure out if this X is a local variable that was sent as a parameter here, or is it an instance variable. Hence it just didn't do anything. By default, the value of int would be 0. So the sum of 0 and 0 would be 0. Now how do we fix this? We use the keyword called this. But before that, there's one key thing to understand. Whenever we call a constructor or a method, we're also sending one parameter, which we don't see it here. That parameter is nothing but the current object. We're just sending the reference variable to that method. And we know that reference variable holds the address where the actual object is residing. And when we do so, we can play anything with that. We can do anything with that object. The keyword that we need to use is this, which means the current object. Essentially, this is same as obj and obj. Certainly we don't use the word obj. That's because we can have more than one object. For example, like Control C and Control V, I could name this as object 1, and we cannot change the name here to object 1 because it might cause problem with this statement. So we're just simply going to use a generic word called this. This will just implicitly assume the current object. With this statement, this will be replaced with obj during compile time, and with this statement, this will be replaced with object obj1. Now this will solve our problem. Compiler is certain that this is an instance variable and the x in here is a local variable that is sent as parameter. Let's try to run the program. Great, 30. Now as I mentioned, even when we're calling a method, the current object will be sent. Let me add another method here. I say void set values int x and int y, and I'm just going to simply copy paste this code in here. I do Alt Shift F to give proper indentation. Now from here, using one of these objects, I'm going to call set values. I'm going to give 50 and 50. Now what is the result that you're expecting? It would be 100. That's because we have set the values to 10 and 20 initially, but those values are actually overridden when we call this method set values. So we got an updated value here for both x and y. Now let me just get rid of this statement, the keyword this, and try to run the program. What is the result that you're expecting? You think it's 0, or would it be 50, or would it be 100? You'll be surprised. It would be 30. That's because of the same reason. Compiler is confused and is not able to figure out if this x in here is a local variable or an instance variable. Hence, it just didn't do any changes at all. The last updated values were 10 and 20, and hence the result is 30. Hope that makes sense. See you in my next video. I have said this a million times by now, that objects can literally be used just as any other data type, any other primitive data type like int, float, etc. This is one such example which explains the same. I'm going to demonstrate you how to send an object as a parameter to a method, and also how to return an object from a method. The same thing is applicable even for constructors. Now what I'm going to do is, I have two objects created. One is derived from the maths class and the other one is from the car class. Inside this car class, I'm going to write a new method which will take the input, which will have the parameter of an object, and the object that I'm going to send is of the maths class. So let's see how it goes. I'm going to get inside this void. I'm going to give this method a name, object param example maths object, and I can do anything with that object in here. Maths object dot x equals 100. I'm going to leave the y value. Now take a note of this. What is the data type here? It's maths. It's a user defined data type, or you can call it as a non-primitive data type, or even you can call it as a reference type. And obviously we need to call that method from here using the car object. Let's save the file. Now we have already set some values while creating the object itself. The 7 is for x and 10 is for y. But with this statement, we have reset the value of x to 100. If I run this program, okay, before that, let's write down another line. It's math addition. Now this will give us the result of the sum of x and y. Let's run the program. Great, the result is as expected. Now let's see how we can return an object from a method. Again, let's introduce one more method. This time the return type is of maths object instead of void. Example. And in here I'm just simply going to return a new object altogether. It's 70 and 848, let's say, or for simplicity let's make it 30, so that the sum of these two numbers would be 100. This will create a new object, alright, and the values of x and y will be set to 70 and 30. We need to collect whatever is being returned from this method. Let's do that. Let's comment out these two lines. Again, car object dot object return example. Now we could either write maths new object equals this and new object dot addition blah 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 system dot out dot print ln. You could either write it this way or simply cut off all this stuff and simply you can just do system dot out dot print ln. You can simply just use the dot operator right here. Let's save the file and run the program. The result should be 100. It is. Great. By the way, we haven't talked about this dot operator, but by now I'm sure you must have understood what it is doing. It will let us access the instance members, be it instance variables or instance methods. Also, we can assign some values. For example, in here, using the dot operator, we got control of that particular field and we assigned a value. Alright, see you in my next video. We're going to talk about pass by value and pass by reference. This is one of the most confusing terms you often hear, especially if you have a background of C language. Then you're the one to get confused on that. Let me help you get clarity on it. See you in my next video. I have said this a million times by now that objects can literally be used just as any other data type, any other primitive data type like int, float, etc. This is one such example which explains the same. I'm going to demonstrate you how to send an object as a parameter to a method, and also how to return an object from a method. The same thing is applicable even for constructors. Now what I'm going to do is I have two objects created. One is derived from the maths class and the other one is from the car class. Inside this car class I'm going to write a new method which will take the input, which will have the parameter of an object, and the object that I'm going to send is of the maths class. So let's see how it goes. I'm going to get inside this void. I'm going to give this method a name, object param example maths object, and I can do anything with that object in here. Maths object dot x equals 100. I'm going to leave the y value. Now take a note of this. What is the data type here? It's maths. It's a user-defined data type, or you can call it as a non-primitive data type, or even you can call it as a reference type. And obviously we need to call that method from here using the car object. Let's save the file. Now we have already set some values while creating the object itself. The 7 is for x and 10 is for y. But with this statement we have reset the value of x to 100. If I run this program, okay, before that let's write down another line. It's math addition. Now this will give us the result of the sum of x and y. Let's run the program. Great, the result is as expected. Now let's see how we can return an object from a method. Again, let's introduce one more method. This time the return type is of maths object instead of void. Example. And in here I'm just simply going to return a new object altogether. That's 70 and 848, let's say, or for simplicity let's make it 30, so that the sum of these two numbers would be 100. This will create a new object, alright, and the values of x and y will be set to 70 and 30. We need to collect whatever is being returned from this method. Let's do that. Let's comment out these two lines. Again, car object dot object return example. Now we could either write maths new object equals this and new object dot addition blah blah blah, system.out.println. You could either write it this way or simply cut off all this stuff, and simply you can just do system.out.println. You can simply just use the dot operator right here. Let's save the file and run the program. The result should be 100. It is. Great. By the way, we haven't talked about this dot operator, but by now I'm sure you must have understood what it is doing. It will let us access the instance members, be it instance variables or instance methods. Also, we can assign some values. For example, in here, using the dot operator, we got control of that particular field and we assigned a value. Alright, see you in my next video. We're going to talk about pass by value and pass by reference. This is one of the most confusing terms you often hear. Especially if you have a background of C language, then you're the one to get confused on that. Let me help you get clarity on it. See you in my next video. In this video, I'm going to talk about pass by value and pass by reference. Take a look at this program. We have a main method, and inside the main method we have initialized a variable x, and we are sending that as a parameter to a method which is in another class. Here is how it works. We'll have a stack memory in that a block will be allocated to main. In that we'll have the value x, which is 10. When we call a method from inside the main, we're going to stack up another block for that method, and note that we're sending this parameter x. If we are talking about pass by reference, then we're actually sending this value to this block. In Java, it is not supported. In Java, there is nothing called pass by reference. We only have pass by value, wherein we'll send a copy of that variable. So when we do this, we're actually making a clone or a copy of this field, and we're sending it to this method. So we'll have another variable. The scope of this variable is within this method, and once this method exits, then this block will get freed. If we are using pass by reference, then the value of x would be 20. That's because we are updating the value here. But since Java is pass by value, the value of x would still remain as 10, not 20. Now we understood what is pass by value and pass by reference. Let's take a look at our code. I have jotted down 3 different scenarios. In our scenario 1, we have a variable x, and we're sending that as a parameter. The initial value of x is 10, and after we send that value or the variable to this method example 1, we're updating the value of x to 100. The line next to it is we're just printing the value of x. Since Java is pass by value, we're not actually sending this x. We're actually making a clone or a copy, and then we're sending the copy to this method. So in essence, nothing will get updated, at least in main method. The value 100 is applicable all the operations that you do in this example 1 method, and once we come out of it, the value would still retain to 10. So the output of this statement would be 10. The confusion arises, however, when we send an object. Objects are references, and this might sound a little confusing because when you're sending a reference, that might sound as pass by reference, which is wrong. We're still sending the reference type as a value, we're not actually sending this math object, we're actually sending a copy of the reference object. A copy of the reference. I mean, this math object will only constitute the address wherever this object is residing in the heap memory. And in example 2 method, we're essentially a copy of that address. And when we do so, this new variable in here will have that address assigned. And the scope of this variable is actually within the block of this. I think this can be better explained in the whiteboard. Let me take you there. Again, let's assume we have a stack memory and heap memory. Since we have created 2 new objects, we'll have an object of examples, we'll have another object for maths with some addresses. In our main method stack block, we'll have these reference variables obj and maths obj. We're good so far. Now in here we're calling a method, and whenever we call a method, we'll have a new block created in the stack for that method. For example 2. And when we're sending this object, we're not actually sending this reference type, we're actually sending a copy of it. So a copy of this is made and is made available here as well. Maths object. But take a note of this. Both these 2 reference variables are actually pointing to the same object. Hence, this statement in here, object.x, if we make it to 100, the change will reflect in here as well. When we do system.out.println maths object.addition, then it's going to find the sum of 100 and 5, because the value x, which was 5, is now updated to 100. Now let's go back to our code. We have a third scenario here. I'm essentially doing the same thing what we're doing here, but if you go inside that method, example 3, I'm creating a new maths object and assigning that object to this new reference variable, and then I'm trying to update the value of x in here. I have jotted the same code in our whiteboard as well, and let me explain you over there. Once again, we'll have a stack memory and heap memory with 2 objects. One is of examples, one is of maths. When the interpreter comes across with this statement, we'll have another block for that method, example 3. And by the way, main block will have object and maths object. Since we send this object as a parameter to this method, we're going to have another copy of this reference variable. Great. So we've reached till this point. Now when this statement is interpreted, we'll create a new object altogether. This is a third object, and the reference name that we used is new object here, and we assigned this reference to obj. So obj was actually pointing to this object earlier, but with this line, now it's pointing to whatever this reference variable is pointing to. Now this is pointing to this object, hence even this would start pointing to this object. This is no longer pointed to actual object. So whatever updates I do with object.x equals to 20 or object.y equals 30, it will be updated in this particular object, but not the original one. Based on your understanding, okay, let's go back to our code. Now try to look at the code and try to guess the output of this program. The output of this would be 10. The output of this would be 105. And the output of this would still be 105. There won't be any difference. Let's run the program. There you go.
In this video, I'm going to talk about comments in Java. Comments are there for the convenience of the programmer. They just describe your code. It's the responsibility of the individual programmer to comment on his or her code. That being said, it's not mandatory. It's just a good practice. In fact, compilers will simply ignore all the comments while compiling the code. All the gray text in here will be ignored by the compiler. These are all comments that are meant for developers. So you shouldn't be the only person who understands your code. You also need to think about the other programmers who will come and take a look at your code at later point of time. Even they should be able to understand. And one way to convey what your code is doing is through comments. Now there are two types of comments. One is for the programmers who is going to take a look at your code and possibly make modifications. And the other is for the programmers who will not be able to take a look at your code but can use your code. Let me explain you what I mean. I'm initializing a couple of variables in here, and I've mentioned the same thing as a comment in here. X and Y are variables and are initialized here. To make a single line comment, you need to use double slash like this. However, if your comment is spanned across multiple lines like this, then you need to enclose them within /* and */. Now these two comments that I've shown you are for the programmers who is going to take a look at your source code and make modifications. By the way, I have just commented on this initializing the variables. In real world, we usually don't comment on such simple lines. We would usually comment on methods, constructors, and objects that usually a programmer is not aware of. Okay, moving on. Now the second type of comment is documentation comment. This is a little tricky. Let's say I wanted everybody to use my class, use the functionality I'm providing. For example, I wanted somebody else to make use of the method I write. But at the same time, I don't want anybody to make changes to my code or copy my code. How do I handle this? I'll simply compile this code. I get a .class file. I'll share the .class file to everybody, and they will be able to create an object of this class and then call this method, whatever. But since they cannot take a look at my source code, how would they see the comments inside it? They cannot. Compiled version of the Java file will not have comments anyways. How to solve the problem? How do we tell the programmer what we're doing in the source code? Is through documentation comments. For documentation comment, they start with /" and ends with a / with a star in each line. And there is a specific format that you need to follow when it comes to documentation comment. We can also use the tags like this. All the tags will start with @ You will see in a minute why we have tags. In order to generate documentation for this class file, we need to use a tool called JavaDoc. It comes with the JDK. You don't have to install it separately. Just as JavaC is a compiler, JavaDoc is a tool that will generate the documentation of your program based on the documentation comments you provide. That tool will generate a HTML document which you can share it to anybody that you wish. So let's try to use that tool. You need to open a command processor and navigate to any directory that you wish. This would be the directory where our documentation files will be generated by the tool. And all you have to do is use this tool JavaDoc and then give the complete path of the Java file. To get the complete path, you can simply go to properties of that file and you find the complete path in here. You can copy that and paste that over the command processor. Let's go back. Let's get inside this folder and make sure nothing is there in that directory or the folder. By the way, I use mix of terms like directory or the folder. They both refer to same because usually we programmers use Linux system and the folder in Windows is directory in Linux.
Okay, moving on, let's run this command. Let's go to that directory, open this HTML file. If you're not aware of HTML, that's fine. We're going to talk about it in our future videos. Let's click this Java comments. We have a description of the class. This program will demonstrate the use of Java comments. List of constructors that this class is holding. Currently it's the default one, and since we didn't provide any documentation comments for this constructor, it's showing nothing. But we do have documentation comments for method, addition, and then the signature of that method, a quick summary of that method. Using annotations, we have described the parameters. Now you can observe why we have annotation. It will just give a proper separate section dedicated for that parameters. And the returns annotation, here's the description for it. Third-party programmer who's going to use your class file to use the functionality can take a look at this HTML document and get a sense on what these methods or constructors are doing. Let's go back. And do take a note that we can also use tags in here. These are HTML tags. Again, you might not be aware of HTML. That's okay, we're going to talk about it. So that's it. Oh, but wait a minute. Since the documentation comments is not of utmost importance, I'm not going to go deep into this because I feel it's not worth it, at least at this point of time. When you enter the mainstream, you'll be forced to do documentation comments anyway, so it's not really worth spending time going deep into this. We have a mountain of other topics to be covered and understand, so let's not waste time in here. But just in case, although I'm not recommending, if you wanted to go through all the description of Java doc and go through and understand what are all the tags that we have, then you can get inside this link. Here you can see the introduction of it. You also have a tool, document checking tool. This will check to see if your documentation comment is in proper format or not. It's really important that you give proper formatting, or you need to follow certain guidelines while providing the doc comments. Otherwise you will see your text not getting populated in here. So it's always good to use this tool, because in mainstream you'll have a book of documentation in each source file. So it's always better that you run your file through this tool and then see if there are any formatting errors. It takes a lot of time to manually verify the documentation comments and see and guess what's going wrong. So this tool will definitely come in very handy for it. You can also go through all this description and all these tags in here. We've already used this param tag, the return tag, etc. Alright, see you in my next video.
In this video I'm going to talk about the static keyword, and for this purpose I have created this class called car with 3 variables: wheel count, gear count, and the height of the car. We have a constructor that will initialize these variables, and we also have a display method that will just simply display these variables that the current object holds. In our main method we have instantiated 4 objects of class car, and we're just invoking the method display. Let's try to run this program. Cool. Let's go to whiteboard and see how the memory management is done for this program. And do keep a note that we have 4 different objects created. So in our heap we'll have 4 different objects created of class car. Now if you have noticed, there is one variable in this class whose value is common for all the objects, that is number of wheels available. For any car, the number of wheels available would always be 4,
At least for the sake of explanation, let's assume so. When we're creating 4 different objects, we're also creating 4 different memory locations for the variable number of wheels. So this would result in creation of 16 bytes of memory, since integer takes 4 bytes of memory. This is not the efficient way of memory management. So what we're going to do is we're going to mark this variable as static. What that would result in is this variable will no longer be associated with the object. Instead, it will be associated with a class. And this variable will be moved to a new memory location called permanent generation. And whatever resides in the permanent generation space is actually associated with a class, not with an object. And now, instead of creating 16 bytes of memory, we're just creating 4 bytes of memory. And this memory location will be shared across all the objects. All the objects will be able to access this memory location and be able to get the value or even change the value. Now let's go back to our program and see how it's done programmatically. So every time we're creating a new object, we're also setting the value of number of wheels available. Now we can get rid of this. Of course, we'll have errors here because in our constructor, we're expecting a parameter, number of wheels available. Let's get rid of that. Let's make the wheel count static. Everything looks good. Let's try to run the program. Good, we got the same result. Now this particular program doesn't necessarily demonstrate the use of static keyword. Let me give another example. Let's say we wanted to count number of objects created for a particular class. For that, let me just get rid of this, or maybe I'll just comment this out with /* and */. We'll talk about comments in future videos. And what I'm going to do here is I'm going to create a new variable which is static int count equals 0. And in our constructor, every time we invoke the constructor, we're just going to increment the count. So every time we create an object, we're also invoking its constructor, and we're just going to increment this static counter. Now in order to display this, we can just access this variable in here count without using the object of this class. Like I said, when I mark a variable or a method as static, it's no longer associated with an object. It's associated with a class. So we can access this particular field even without creating an object. Let's see how it's done. System.out.println car, which is the name of the class, and the auto suggestion shows the count. Now let's try to run the program. Which is expected. Let's not make this a class variable. Let's make this an instance variable. And now let's try to run the program and see the output. Since this variable is no longer associated with the class, we cannot access with the class name. We can access with the object name, and whichever object you're going to use, we get its associated value. So I don't see any purpose in demonstrating this. Let's get rid of this, and we're just going to rename this back to static. Save the file. In the similar fashion, we can have static methods as well. And just as static variables, static methods are linked to a class, not with an object. Let me just demonstrate it. I'm going to create a new method here, which is static void static method. and I'm just going to do system.out.println count. And in here we can get rid of this statement. Instead of saying car.count, I'm just going to call that method car.static method. Let's save the file and run the program. There's one key point to understand here. This static method in here is not aware of the objects that are created with that class. Essentially what that means is, when we're calling a method using an object, we send the current object as a parameter implicitly. But that's not the case with the static method, because we don't have an object in first place. We're just simply using the class name. And with that being said, in our static method, we cannot access any instance variables. We can access only static methods or static variables. The count in here is static. If we get rid of this statement in here, we're going to get an error, and that's pretty expected. So from static method, we can only call other static methods or static variables. Now, can you try to figure out why main method is static? Pause the video and try to guess. Okay, let's assume that main is not a static method. Then somebody has to take care of creating an object of this class, and then we invoke this method main. Who is creating it? Nobody. The JVM way of solving this problem is, it will expect us to write a method with exact same name, main, including the case, and it has to be static, so that JVM can easily access this method using the class itself without creating an object. Because when we create an object, it's going to result in creation of memory location as well, which is not required. So that makes sense, right? Also, in fact, we've been using the static method throughout our course so far. Let me show you what I mean. The system.out.println. What is this? System is a class in which we have a static member, out, which in itself is a reference variable, and out.println is nothing but we're just calling the println method of object out. Hope that makes sense. Now, the static variable doesn't necessarily have to be a primitive type. It can also be a reference type as well. There is one risk associated with static variable. Let me show you what I mean. Since this static variable is accessible across entire application, from anywhere in the program we can change the value, and that will impact all the objects across the application, which is not intended. For example, I don't want anybody to change the value of number of wheels available, because I know it would always be 4. So how do we handle this? We can handle this by using the keyword called final. Let's go back to our program. So instead of just calling it static int wheel count, I'm going to call it final static int wheel count. Now from the display method, I want to change the value of wheel count. It just won't allow me to do that. Now see the error. Cannot assign a value to final variable wheel count. Great, I guess we're good.
Alright, in this chapter we're going to talk about packages, and especially in this video we're going to talk about how to use packages, how to import them, etc. Take a look at this folder. We have multiple files in here. Some of these files are related to music and some of these files are related to cooking, and we got few other random files. Now the problem with this is everything in here looks very tedious. These files are not organized. Also, if you wanted to create another file with the same name, say some name, it's not possible to have two files with the same name in the same folder. So what is the solution? How do we make things look a lot cleaner, more organized? Is by creating folders. So let's do that. I'm going to right click and create a folder. I'm going to name it as music, and files that are related to music will go inside that directory, which is favorite artist list and songs list. These two files will go in here, and now we can have another directory, say cooking, and then we're going to move these two files in here, another directory with say random or whatever. We're going to move everything in here. Now if you wanted to create another file with the same name, say Apple, you can't create in the same directory, but you can always create in another directory. That's very obvious, right? But let's see how we can similar behavior in our Java project using packages. Let's go to our project. Now actually I have created this video long ago, and after I finished recording all the core Java videos and when I'm trying to edit, I found out that this video, which talks about packages, is corrupt. So I have to remake this video. So you may see a slight mismatch between this video and the next video. I'll try to keep it smooth, but you may see a slight mismatch. So let me just get rid of the folders which I have created in here, or the packages that I've created, and I'll try to explain it again. Let me get rid of these two. I'm going to say delete. Yes. Now what I'm going to do is create a new package and see what it is. I'm going to right click on the project, say new, and say Java package. I'm going to name it as new package. I want to leave the name as it is. Click finish. The moment you create a package, if you go into the project directory, you can get the path of the project by right clicking on the project, click on properties, and here you get the path. Let's go there. And once you go there and click on directory named src, stands for source, you're going to see that package in here. Essentially it is represented as a folder in Windows or directory in Linux. Same way, if you create a folder in here with say some name, it's already there, so we can't have the same name. I'm going to call it some other name, and that way if you go here you see it created here. You can do it either way. Either you can create a package and see a folder there, or you can create a folder there and see a package here. Now let's try to create a class inside that folder or a package. So you're going to right click on that package and say Java class. I'm going to leave the name as new class, or you can give your own name, whatever. Finish. And once you do so, when we auto generate the class, you have seen we got all these unnecessary comments which we can get rid of, but the key thing is you can see this particular statement which says package new package, which means this class is actually residing in a package named new package. If you try to give a different name or the name of a different package, that's going to throw an error. For example, we can't give the package name which we have just created. Let's say some other name. That doesn't work. You get a compile time error. So now just as we have seen that we're able to keep files organized, we can also achieve the same thing in here. Now we can also create a class file with the same name, new class, on a different package. Let's say copy, and you can paste it over here. Refactor copy or just copy. Refactor copy would let you make changes to the name or whatever. So now let's click this, but obviously you get an error because we're not supposed to give the package name as new package, which is the package name of this. This is supposed to be some other name. Now things work pretty well. So that's the beauty of packages. It will help you keep things or classes in more organized fashion. You can keep related class files in a certain package. Now let's say in here what you wanted to do is you wanted to use class files which are residing in another package. How do we achieve that? Let's say I wanted to use class called this somename.java, which is residing in somename package. I want to use it in my class. So if I try to create an object of somename, it just doesn't work. New some name, it throws an error. What you can do is you need to import this particular class into your project or into your package. What you need to do is you need to import this class into your class file. How do you do that? You're going to use a keyword called import, and then you're going to specify the package name, basically the package wherever your desired class file is residing. So it's going to be some name dot, and you already got suggestions. You can just use arrow keys and select that class file that you wanted to use. And now we should no longer be having this error, but still we have. That's because we don't have the name correct. It has to be lowercase s. We already know that Java is super case sensitive and it gets annoying at times, like we've seen just now. So let me just get rid of this once and make sure we see an error. Let's save the file. You got an error. Let's undo, get rid of that error. Now you can call all the methods inside this class without any problem, and I don't think I need to do that. So that's how packages will work. Also say that you wanted to use all these classes residing in the package somename. Then you don't have to import each and every class. You can just import the entire package like so. You can use star character, and that would let you use any or all the classes inside the somename package. Alright, that's it on packages. It's very simple and easy. Now you may ask me, if these are packages, then what are these? These are all just logical entities created by your IDE, like NetBeans or Eclipse does the same thing. It is just for our convenience. These are not actual folders. If you go into the project directory, you won't see those folders. This logical entity called source packages will actually have source files, and this logical entity test packages will have the test files. Now you probably don't know what a test file is. You will get to know when we talk about JUnit or Mockito, etc. So that's going to be a different chapter altogether, or rather different course altogether. So at least for core Java, you're not really bothered about this logical entity called test packages. What you should be concerned about is the source packages, libraries, and test libraries. Again, you don't need test libraries. Libraries are just all the libraries that you're using in this particular project packages. So you're using all the JDK libraries, which is a default library, or you could import some external libraries to use them in your project. We'll talk about them pretty soon. So these are not actually residing in this directory packages. This is just a logical or these are just logical entities created by the IDE for your convenience. Alright, see you in my next video. Okay, in this video we're going to talk about access restriction or access specifiers in Java. Let's assume you have a robot. Now I have to admit that this is not the best diagram, but this is the best I can do. The robot looks more like a robot which is yelling, but I suggest you to ignore the quality of this diagram and stay focused on the topic. So let's assume that you own this robot and it's just robot without any intelligence in it. You'll have to write your own source code so that the robot will perform a certain task. Let's say you wanted robot to perform the task of getting the pizza from the nearest store. Of course, it's beyond the current technology. We don't have our artificial intelligence technology developed to an extent where a robot will physically move to a physical store and get you pizza. But let's assume so for the sake of example. But at the same time, you don't have knowledge on programming. You do have knowledge, but it's very limited. You can only give the basic instructions to the robot, but you cannot write the entire program to perform your task. So what you're going to do is you're going to purchase the code from outside, from a different company, and you're going to use that code. Let's say I'm the guy who is providing you that code where it will have a lots of tasks. Basically, it's just a class file called robot, and it will have lots of methods like walk or run, get pizza, ignore the handwriting, and a lot of other tasks. Each one of these methods will perform a certain task. For example, the method walk will have instructions that will instruct the robot to walk. Same as with the run, same as with get pizza. Now you purchase the code from me, and then you create an object of this class, and then you'll try to use all these methods. Now do take a note that I'm not going to give you the source code. What I would do is I will compile my class and I'll give you the class file. So you don't have visibility on the source code. You can only use my code, but you cannot edit it. Now in your robot class, you're going to create public static void main, the main method, and then inside that, you're going to make use of all the methods, whichever is required. So in order to perform your task of getting pizza from the nearest store, you're going to use the method called walk, and you're going to use the method called maybe get into the car. Okay, let me list down here. Walk, get into the car, and start the car, etc. These are all methods which are residing on my class. Similarly, you keep instructing the robot to perform the task of getting the pizza. Now there's a problem here. You could go wrong with the sequence. For example, if you put walk in the end, then the robot will not even approach the car, and so it cannot get the pizza. So there's a possibility of messing things up. So what I do to solve you that problem, I'm not going to expose all the methods which are not really required. For example, walk, run, get into the car. These are all methods I don't want anybody to access. What I want people to access, people like you to access, is the method like get pizza.
And all these methods, I'm just going to use them internally. If I don't want you to use these methods, then I'm just going to mark them as private, so that your source code does not have any visibility of these methods. And for the methods like getPizza, I'm going to make them public. That means this method is available for you to use. This is not any security measure. This is for the convenience. This is to provide you the convenience so that you don't mess up with the logic. So now by doing this, you don't write this, because you cannot. For example, you cannot access the walk method or get into the car, etc. All you can do is to access the public methods, which in this case getPizza. So that way I'm sure that whoever is purchasing and using my code will not mess up with the logic. I hope I made myself clear. So now the question arises, which method to mark as public and which method to mark as private? For all the methods which has the scope of changing over a period of time, you want to make that method private. For example, let's say we have this method, get inside the car. My current logic is allowing the robot to get inside any car that it sees. This is clearly inappropriate because we don't want robot to get inside somebody else's car. We want robot to get inside our own car. So now I have decided to make changes to this method by adding additional arguments to this method, like which car to get in, the number of the car, and the location of the car. The user will send the parameters, but we have a problem. If I make this method as public, then you will have an error because you're using this method without sending the arguments. But now you will have to send parameters. So because of my change in the code, you will end up having an error in your code. And there are hundreds of people who are using my code like you are. And that's going to cause a lot of problem. And in fact, it's going to destroy my reputation as a company. So I will not make this method as public. I would make it as private, so that I'm pretty well aware that nobody can access this method. So I'm free to make changes, the arguments or with the logic. And whichever method is public, you should not make any changes to the signature of the method or the logic inside. You can make changes of the logic inside that method, public method, but no drastic changes, because we know that these methods are being used by hundreds of people out there. Hope that makes sense. So basically, to get the definition of an access specifier or access restriction, the keywords like private, public, and there are a couple of other keywords are actually used to restrict the visibility of member variables, member functions or methods, and even constructors. We'll talk about access restriction on constructors in our next video. In this video, let's take a look at a few examples of access specifiers in our Java code. Let's go to our workbench. But before that, let me just mention that we have 4 different types of access specifiers: public, private, protected, and default. Default in itself is not an access specifier. It's not an official access specifier. When you don't specify any of these to a method, field, or a constructor, then by default access specifier will be considered. So we'll see what all this in our examples. Let's go to our workbench. I'm in the workbench. Let's expand this project. We have a class called packages from our previous example, and the class sum name. Now if I make this, okay, the method in here, the current existing method, is marked as public.
If a method or field or a constructor is marked as public, that means that method is accessible within this package as well as in other packages. If I don't specify any access specifier, then that means it's a default access specifier, and the default access specifier means the method is accessible only within that package. Now we got an error here for obvious reasons, because this method belongs to a different package and the access specifier is default, and we got an error that it cannot access the method. So we need to make this public. Let's try to create another class inside the same package. Let's copy the file and paste it. Let's do refactor copy, give it some name 1, whatever. Inside this, what I would like to do is try to create an object, basically the same steps what we have followed here. Let's copy that and paste it over here. Let's save the file. Alright, actually we're going to need the public static void main because this has to be inside a method. Let's copy that as well. Copy and paste it. We didn't have any error in here. That's because this is a default access specifier and is accessible within the package. Let's make it private. Now private meaning this method is accessible only within this particular class. So we get an error here, very obvious. So we've understood what is private, public, and default access specifier. Protected is something that we're going to cover at later point of time once we understand the concept of inheritance. For now this will do, but now let's just take a look at, okay, let's put the default one or the public one, public access specifier, save the file. Now let's take a look at the access restriction for member fields or variables. Same as methods, if I make this as private, let's save the file. Nobody outside this class will be able to access this particular variable. Let me prove it right away. So object dot, we just got the variable y, but x is missing because we have it marked as private. And if you don't specify anything, that's default, so it shouldn't be accessible outside the package. So let's try to access. So none of those two variables are accessible. If we make this public, let's save the file, and now we should get the variable x in the suggestion. That means it is accessible. Let's undo those changes. Save the file. Let's get rid of this. Save the file. And that's it. Now we've understood the usage of access specifiers for methods. Now let's try to understand the real advantage of access specifiers on the variables. There are two good reasons why you want to use access specifiers on variables. One, if you want to restrict the users of your class to not update the value that the variable is holding. At the same time, you want them to read the value. Let me show you what I mean. Let me save your time by writing the code and I'll get back. But maybe I'd show you something. Go to source and then click on insert code, click on getters and setters, choose these two variables in here and click generate. So basically these methods are to perform read and write operations on these variables. Get x meaning we're just returning the value of x, and set x meaning we're writing something to this variable. So from outside this class we may not be able to write or update the value directly, but we can update the value using the set x method, because this is public and this is private. Save the file, Control S. Now let's say we don't want any write operations to happen, so we're just going to simply get rid of all these set methods in here and save the file. Now guess what? You can only read these values using these methods, but you cannot do any updates on these variables. If you want to see the example, object dot, those variables are not directly accessible, but you can know the value from these getX and getY methods. Right? So that is one advantage. The other advantage is, let's do Control Z. We have the setX method here, and let's say you only want to store a value which is of multiples of 10. So we cannot just let any value to be stored in here. For example, if user enters 10, then we're going to straight away store the value of x to 10. If it is 100, since it's multiples of 10, we're going to store it. If it is, say, 97, then we're going to update the value, maybe a default value, to 10. If this is a dog class, then if the variable x is to mention the height of a dog, then user can't just enter 10 feet or 100 feet, because that would never be the height of a dog. If the user enters an inappropriate value, we'll store the default value. So we can have the logic in here. If x 10 equals 0, if the remainder of x when we divide it by 10 is 0, then yes, we want to store the value. Else this dot x, we want to give some default value, which would be, say, 10. Let's save the file, or better yet, let's make it 0. Now from outside the class, I want to do write operation, object dot set x, I'll do 100, system dot out dot println, object dot get the value of x, go to the end and delete. Let's save the file and try to run the program. Great, we got 50 and 100. Not sure where's this 50 is coming from. Alright, I guess we are printing it somewhere in here. Okay, we got method, I guess. Well, yes, we're calling it over here. We'll let that be there. Now let's try to give a value of 99 or 97 that is not divisible by 10, and this should give us 0. There you go, it's 0. So it's sort of letting us restrict or letting us feed the right value into the fields. Now I want to point out something in our whiteboard diagram. Let's go there.
Now this brings me to talk about one of the greatest features of object-oriented programming language is encapsulation. Encapsulation means hiding the inner details and exposing only the essential details is called encapsulation. To give you a real-time example, take an example of a car. As a car user, you don't need to know how the engine works, etc. You just need to know how to use the brake, how to control the steering, how to change the gears, etc. All the details like engine and all the technical details will be hidden from you. So that's sort of like the manufacturer hides all those internal details and will expose only the details that are required for you to perform your task. And that's exactly what we're doing here. By marking a lot of methods as private, we're hiding them. We're hiding them from the users, and we're only exposing the essential details, the public methods. And that's called encapsulation in Java. We'll talk about more object-oriented features as we come across with those examples. So pretty soon you will be an expert in Java, trust me. In our next video we're going to talk about access restriction for constructors. In this video we're going to talk about access restriction for constructors. Now in this class, AR constructors stands for access restriction constructors. We have everything static. We have static methods, and whatever we're going to use inside the static method are going to be static as well. So we have our variables as static. Now a question for you, does it make sense to create an object of this class? When you don't have any methods or variables that you can access with that object, what is the purpose of creating the object? There is no purpose. And we're trying to do the same thing in here. So we don't want users to create objects of my class, AR constructors, to save their memory. So what I'm going to do, I'm going to create a constructor, so that will override the default constructor. Control C and Control V. And that's it. This is a default empty constructor. Still we'll be able to access. But if you make this as private, then guess what? We cannot create an object. We cannot instantiate a class. We get an error. That's because this constructor in here is only accessible within this class and is not visible outside this class. As simple as that. We're saving memory. So this is one purpose why you want to use a private constructor. Okay, let's do Control Z and save the file. We have another usage of private constructors. If you want to follow a singleton design pattern, a singleton design pattern is nothing but we won't let anybody create more than one instance of a class. Take a look at this class. We cannot instantiate or create an object because we have only one constructor, and that is private, like we've seen in our previous example. But we're going to let we're going to let the user access this method. Since this is public, anybody would be able to access this method, and what we're returning in this method is the instance of this class itself, because we have access to this constructor within this class. So we sort of created an instance using the new keyword, and we returned that object to whoever is calling, and that's exactly what we're doing here. Let me uncomment these lines. Let's save the file.
I've created a couple of instances. In fact, I didn't create a couple of instances. Let me explain you what I mean. In here, I've requested for this instance. As we discussed when we talked about the static keyword, that all the static variables are associated with the class, not with an object. So regardless of how many objects we're creating, we're ultimately pointing to the same field, and that is associated with the class. Whatever we're returning in here, object, is of static. You may want to revisit that video where we talked about the static keyword if this sounds confusing. But in here, we're sort of got the instance of that class, the static instance, I would say. We have B, we got the same instance. If I update the value of X variable in here using the first instance, then it's going to reflect in the second instance as well. So in these two lines, I'm printing the value of X using both the objects. So even though I used the object A to set the value of X, it will get reflected in here as well. So the output of these two would be same. Let's try to run this program. There you go. Now I'm using the terms object and instance. They both essentially mean same. We're going to create an instance of a class and we call it an object. So don't get confused. Hope that's clear. See you in my next chapter.
In this video, I'm going to talk about method and constructor overloading. You might want to import this project classes and objects extended, and in that open up the file overloading.java. Let's expand this. Sometimes you want to give two methods the same name, just as here. But in that case, they should vary in terms of signature. These two methods in here are having the same name, including the case, but they vary in terms of signature. When I say signature, it can vary based on the number of parameters that we send. In this case it's 2, and in this case it's 3. Or it can also vary in terms of the data type of these parameters. Now when we call this method, depending on number of parameters, the method will be called, or depending on the type of data as well. I've created an object of maths class and then I'm calling object.addition and with 2 parameters. Now any guess on which method will get invoked? It should be this, since we're taking 2 parameters. By the way, why do we want to have 2 methods with same name? That's because these 2 methods are essentially doing the same. They're trying to find the sum of all the parameters that you send. For the sake of readability, you might want to give the same name for both these methods. Okay, now going back, if we have another parameter here, which is 60, now this statement will call this method, and this statement will call this method. If you try to run the program, you would get 30 as the result of this instruction, and you would get 110 as the result of this instruction. Now let's try to add another method. Let me copy this code, this method, and change this to double. We will have a compilation error here because we're trying to find the sum of a double variable and an integer variable. Double takes more memory than integer, so obviously the result cannot be of type int, so the return value that we send must be double as well. Let's do Alt-Shift F to give proper indentation. Now we can change, or let's add another statement. We can say 10.1 or 10.3, whatever. This instruction would result in calling this method. Although these two methods are having the same name, including the case, as well as same number of parameters, they are differing in the signature in terms of the data type. If I get rid of this method, do we see errors? We don't. Let's save the file. Why do we not see the errors? Because we're sending a couple of parameters, and this method would certainly suffice it. The parameter 10 is of type int while sending this parameter, but when receiving it, we have typecasted it into a double value. And it's not possible the other way. For example, if I'm sending a double value from here, and if I'm expecting an integer variable, then that's not possible. If you have gone through my video on typecasting, you would better understand this. So this works like charm. Let's undo, save the file. Now what if I change this type to double? We do get, okay, let's change the return type here. We do get an error. Where? Here. Because there is an ambiguity. We're calling addition and we're sending a couple of integers. Now compiler is not able to figure out which method to be invoked. Should it be this or this? This ambiguity causes the compilation error. Let's undo those changes. Let's run the program. Great, the result is as expected. Now let's take a look at constructor overloading. Same as methods, we might want to have constructors with the same name but with different signature. I don't have any constructor in this class. That means a default constructor is created. However, I can create my own constructor. Maths, int x, int y, and let's have a couple of variables in here. Int x, int y, and I said this dot x equals x, this dot y equals y. We will certainly have an error here because when we write a constructor on our own, there won't be any default constructor generated. While creating this object, we're not sending any parameters, so either we have to send a couple of parameters here or we have to write a constructor without any parameters, like so. And in this, I just don't want to do anything at all. So I could create another object with parameters 10 and 40. Need to give a different name, say object 2. This instruction will call the no parameter constructor, then this will call the constructor with couple of parameters which are of type int. Even in case of constructors, the signature matters, the type of variables and the number of variables that you're going to have as part of the constructor. Now sometimes you want to call this constructor from another constructor. For example, in this particular constructor, I don't want to set the value of x. I just want to take the value of y. So we get rid of it here as well. Save the file. Here we have a problem, right? Because we're not initializing this variable x. So how do we handle that? We call this empty constructor from here using the keyword called this. And as we've talked in our earlier videos, that this means the current object. And do take a note that the statement in here has to be the first statement. Let's say I do Control X and paste it over here. That's going to give me a compile time error. Let's undo. Now doing so, we're assigning our own value to y, and we're leaving the x to have the default value. Hope that makes sense.
In this video, we're going to talk about recursion in Java. When a method calls itself, it's called recursion. Take a look at this example. Let's say you have a method called example, and inside that method we'll have some logic, and within this logic we're going to call the same method, example. So this will essentially call itself, and every time the controller enters inside this method and comes across with this instruction, it will call itself again recursively. This mechanism is called recursion. One of the practical usages, or rather one of the most popular examples of recursion, is to find the factorial of a number. To find the factorial of number 5, we need to do 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. To find the factorial of 3, then that's 3 multiplied by 2 multiplied by 1. As simple as that. Now, how do we find the factorial of a number programmatically using recursion? Let's take a look. Let's say you have a method called factorial, and it's going to take one parameter which is of type int x. Essentially, we're sending the value to this method for which we need the factorial. The factorial of 1 would be 1. The factorial of 5 would be product of all this, that would result in 120. So in our logic, if the parameter equals 1, that means we just simply need to return 1. However, if it is greater than 1, then we can find the factorial. How do we do that? Any guess? It's just one line of code that will do the magic. Can you try to figure out? If you observe this line, then we're finding the factorial of a number in this manner. To find the factorial of 5, we're going to say 5 multiplied by 5 minus 1. And whatever is the result, in this case it's 4 multiplied by 4 minus 1. Again, whatever is the result of this, the result of this would be 3 multiplied by 3 minus 1. So ultimately we're trying to find 5 multiplied by 4 multiplied by 3, so on until we reach the value 1. So the result would be 120. We're going to have the same logic in here. So we're going to say else, if the value is not 1, then return x multiplied by factorial of x minus 1.
Now try to think about this logic. You will definitely find the factorial of any given number. Let's say we wanted to find the factorial of 5, and that's what we sent as a parameter. Since 5 is not equals 1, we're not going to return the value 1. So we will enter inside this else block. In else block, we're returning something, x multiplied by factorial of x minus 1. What this statement essentially does is 5 multiplied by the factorial of 4. So 5 multiplied by the result of this method call. Whatever gets returned from this method call will be multiplied with 5. But in here, we're calling this method again, and this time the value, the parameter that we're sending is 4. So once again, 4 is not equivalent to 1, so we'll enter inside the else block, and hence the equation would be 4 multiplied by factorial of 4 minus 1, which will become 3. Again, 3 multiplied by factorial of 2. It keeps going until the value is 1. Once we hit the number 1, we're not calling this method anymore. So ultimately we're finding the product of 5 multiplied by 4 multiplied by 3, so on and so forth, and we get the result as 120. And there's one important thing to understand. Whenever you are using recursion, it is your responsibility as a programmer to put a terminating condition. Otherwise, the method will keep calling itself and will cause errors. The error that it causes is called stack overflow exception. The reason is every time we call a method in our stack memory, a new section will be dedicated for that method to store its local variables, etc. If you keep calling the method again and again, the stack is going to get full, and within no time you'll get an exception, and that exception is stack overflow exception. Let's take a look at example of these two. Let's go to our workbench. For this, you need to open the project classes and objects extended. In that, open the file factorial example. The logic in here is exactly what we have seen in our whiteboard. We have x equals 1, else we're using the recursion mechanism to find out the factorial of a given number. In this case, I gave 5. Let's see the result. Let's run the file. The factorial of 5 is 120. Let's give another value. Let's say I want to give 10. Let's save the file and again run the file. The factorial of 10 is this. We're good. Now let's take a look at this, the stack overflow exception. Now we haven't talked about exceptions yet. We will in our future chapters, but essentially you can think of it as an error. Let's take a look at this example. Let's run the file. So what are we trying to do here is we call this method in here. The controller enters inside this method, prints out this statement, and in our second line of this method we're calling the same method again. And there is no condition that will stop this. In case of factorial, we have this condition. If x equals 1, then we're going to terminate. Whereas in here, we don't have such condition. And moreover, do take a note that this message will never be printed, because we just simply kept calling the same method again and again.
every time the controller comes in here, it's just going to go back to the beginning. So if you take a look at the output, we got, for every method call, there's a new section in the stack created, and after some time, when the stack got full, we got stack overflow error, and that's what it is messaging, and ultimately our build failed. So there's a risk associated with recursion. You need to use it very carefully. Always put a terminating condition. Let's go to whiteboard. Another practical example of using recursion is Fibonacci series. So what is Fibonacci series? It will start with 0, 1. We'll find the sum of these two, which will make it to 1. And then we find the sum of these last two digits. So that will make it 2. The sum of these two digits, we get 3. These two, 5, 8, 13, so on. This is called Fibonacci series. And the logic we're using in our program is somewhat like this. We have these variables declared and initialized. Now we're going to straight away print first two values, 0 and 1, using system.out.println. And in our method Fibonacci series number, we're going to send a parameter. Let's say we send the value 1000. We want Fibonacci series until 1000. So the way we are dealing with it is using these three variables. We're going to find the sum of A and B and store whatever is the result in this fibnum. And then, so that means essentially, let's say the value of initially the value of A and B, or 0 and 1, we find the sum of A and B, that will make it to 1. So the fibnum value would be now 1. I'm going to store the value of B into A, and we're going to store the value of this result into B. And we're going to print this number, fibnum, using system.out.println. Now the values of A and B are updated to 1 and 1. And again, we'll try to find the sum of A and B, so that will make it to 2. We're going to assign the value of B in A, so that will make the value of A to 1. And then the value of B will become 2. So we got these two values. Again, we'll find the sum of these two values, store the value of 3 in fibnum variable, and A will now hold the value of 2 and B will hold the value of 3, so on and so forth, and we'll have a terminating condition. Whatever is the value that we send to that method is the maximum value, and we don't want to generate any Fibonacci numbers beyond that number. Now let's take a look at that example in our code. Here it is. We have these three variables in here. We have the max limit of 1000. We're just simply printing the values. The first initial values would always be 0, 1, so we're just right away printing them. And we're calling this method Fibonacci series. This has the logic which I'm talking about, and this is the line that does all the magic. It's going to call itself recursively until this condition fails. Let's try to run this program. There you go. Let's give the value of 10,000. Let's save the file. Run it again. There you go. Hope you've enjoyed. In this video, we're going to talk about nested classes. Take a look at this. Let's say we have class A and class B, and all the members of class B are public, And the only reason why class B's members are public is because class A is using them. Class A needs access to all the members of class B. Now let's say class A is not there, then we can gladly mark all the members of class B as private. Now just because of one class, we are making all the members of class B as public. This is clearly a problem. This will impact one of the major features of object-oriented programming language, is encapsulation. We need to try our best to make as many members as possible to private. But Java gives us a solution to this problem. We can make a class sit inside another class. So a class inside another class. In this case, we just simply put this class A inside class B, so that A being a member of class B, the class A will have access to its private variables, to class B's private variables and private methods. So the problem is solved. Now we can gladly make all the members of B as private. This will improve the encapsulation, and that's clearly a great advantage. Coming to the syntax, it's pretty simple. We have class B. It will have its all member fields and member methods. And within this curly braces, we'll have another class defined, class A, and then it will have its own member fields and member methods. As simple as that. So we're basically nesting a class inside another class. It's called nested class. In that we have static nested class and non-static nested class. This is also called as inner class. Now let's take a look at both these examples in our workbench. See you there. Let's talk about static nested class first. So in here we have the outer class, and then inside it we have another class defined. Within this class we have a method that just simply prints a message. But do take a note of this keyword, static. When we say static, this class in here will not have direct access to the instance variables, because when we have a static member, just as static method, a static class is associated with the class. It's not associated with an instance. In order to access this method met from outside this class, this is how you would do. This is the name of the outer class and then the inner class with the dot operator. You'll give it some name, and then new, you're going to repeat the same thing so that we got an object of the nested class. You can call the method like so. Now this statement makes complete sense, because let's say we have a method which is of static. How do we access that method? We use the class name. That's exactly what we're doing here. This class in here is more or less like a member method. So in order to access this, we can just use the class name, since this is static. And that's what we did. We use the class name to access its member. In this case, it's just another class. And then we do need to create an object of the inner class. That's because the member function that we're trying to access is not static. So we need to have an instance or an object to be able to access this method. So in here we have a new keyword used that will create a new object of the inner class, and using that inner class object we're able to call this method. And let's say if this is static for the time being, let's save the file And then I bet we would be able to access it directly, like so. There it is. Let's undo those changes. If you run this file, then you would just see this message printed. Let's give it a try. There you go. Now let's take a look at non-static nested class or inner class. We have the similar syntax for this. We have an outer class, and inside that we have an inner class. But there's one key difference. This class in here is not static. And the way we access the member methods of the inner class is like this. First of all, we need to create an object of the outer class, and then we will create the object of the inner class using the reference of the outer class. We'll take a look at how it's done, and then we'll be able to access its member methods. So this is how it is. We have an object of outer class, and then you need to have the following syntax to be able to get the control of the inner class and access its member functions. You have the name of the outer class, and then name of the inner class with the dot operator. You give any name in here, and then the object of outer class dot new. This is very important. This is what does the magic. It will create an instance of the inner class, and then here it is. We're able to call that method. If you run this program, you would see this message. Let's quickly do that. There it is. Let's talk about some of the key differences between these two types of nested classes, static and non-static nested classes. Unlike a static nested class, the inner class will have access to the instance variables. For obvious reasons, because this class is not static, hence it is associated with an instance, not with a class. If we have a variable defined in here, then we can gladly access those member fields of the outer class from the inner class. But that's not the case with the inner class in here, because it's static and it does not have access to instance variables. Now that being said, Java does not encourage us to declare any static members in here, be it static fields or static methods inside this inner class. There is one good reason to do so. That's because it will violate the definition of static. When we say a member is static, that will signify that we shouldn't be needing to create an instance to be able to access it. We should be able to access it with just the class name. But if we have a static member in here, for example, there's no way we can access it without ever creating an instance of its outer class. Because only when we create an instance of the outer class will we ever get control of its inner class. So it just doesn't make a lot of sense, and hence the designers of Java decided not to support static members inside a non-static inner class. But that being said, we can still create constants. For example, static final x equals 10, or static final the pi is 3.14, etc. That is allowed inside this class. You can give it a try if you want. And one of the beauty of these inner classes is that you can make use of the access specifiers just as you do on member methods. You can have public, private, protected, and default access specifiers on a method. In the same way, you can have all those access specifiers for inner class as well. For example, I can make this private, doing so, obviously we will get an error here because we cannot instantiate the inner class anymore. We can instantiate it, but only within the class in which it is residing. Only the outer class will have the permission to create instance of the inner class. Let's undo that. Now you might be wondering, when we don't have access to, okay, let's go here. When we don't have access to the instance variables, what is the real reason why we would ever want to use a static inner class? One of the key examples which I can explain right now is this in here will have access to private constructor. Let's try to create a constructor. With some message from private constructor. Alright, inside this method we can create an object of this class. Let's comment this line. And now from here, if you run this program, we'll call this method, and we have access, we have created an object of the outer class. But take a note that you cannot create an object of a class whose constructor is private. We cannot create the object directly from this class, but we're able to do so in here. That's because this is a static class, and we're able to call this method without ever creating an instance of its outer class. In here we have never created the instance of the outer class. But whereas coming to inner class, the non-static inner class, we do have to create the instance of the outer class, and we cannot if we have a private method in here. Now let's try to run this program. Run file. Message from private constructor. Great. See you in my next video. In this video we're going to talk about shadowing. Take a look at this example. We have a class, and inside that we have another class which is an inner class. We also have the main method from where the execution begins, and all we're doing inside this method is we're calling the method inside the inner class, and we're sending a parameter. Now if you take a note, the name of all these variables are same. One is sent as a parameter, which will be the local variable of this method. The other is the instance variable of the inner class, and the other is the instance variable of the outer class. Now when I try to run this program, what would be the output of this line? Any guess? Java will shadow both these variables, and it will give priority to the local variables, which is, in this case, it's 5. If you want to access the instance variable of the inner class, then you have to use the keyword this with the dot operator. This will refer to the current object, which in this case is the inner class object. So this statement will display 1. If you wanted to access the instance variable of the outer class, then you're going to do it this way. The name of the outer class, and use the keyword this dot the variable name. Let's try to run the program. There you go. The result is as expected. In our next video, we're going to take a look at local classes. Stay tuned. In this video, we're going to talk about local classes. Unlike an inner class which acts like a member of a class, A local class is local to a block. And when I say block, it could be inside a method, it could be inside a for loop, or even it can be inside an if condition, etc. Now take a look at this. We have the main method from where the execution begins. We have an object of the outer class using which we are calling a method inside it. Inside this method, we have another class defined which is called a local class. And we've also created an object of that local class to be able to access this method inside that local class. Now this local class acts more or less like an inner class. It will have access to all the private members of the outer class. And just as inner classes, a local class does not encourage us to put static members, no static variables or static methods, except the constants, the final static variables. Now that being said, there are certain differences between the both inner class and the local class. For example, we cannot instantiate the local class outside the scope wherever it is defined. For example, this local class is within the scope of this method, so we cannot create an object of this class outside the scope. And this local class cannot have the access specifiers like public, private, protected, whatsoever. And for obvious reasons, that's because inner class is like a member of a class, and every member of a class can utilize the access restriction. Now this is inside a method. This is not a member of a class, and hence access specifiers or access restrictions is not applicable for local class. Also, whenever a local class is using a variable that is local to this method, be it a parameter or a variable which is declared and initialized inside this method, it should be a final variable. Otherwise, we get a compilation error. There is a very good reason to do so. This class in here does not have visibility of the local members or local variables of the enclosed scope, or in this case, the local variables of this method. But Java does a little trick to this. When we compile this program, Java will actually create a copy of these local variables and make them part of this class. And at the same time, Java will also create a constructor to give the initial values, which would be the same values whatever we have here. So Java is essentially, during compile time, is just making a copy of all these local variables and pasting them here with a constructor to initialize them. So during runtime, if the variable is not final, then there is a scope of changing, and that will definitely cause confusion. Let me explain you what I mean. Let's say I have assigned the value of x to factorial of x. Of course, we don't have this method, that's why we're getting compilation error. But just for the sake of explanation, let's assume we're finding the factorial of the value x and then assigning it back to the same variable. Now, if you observe, Java is actually creating a copy of variable x during compile time, but this computation happens during runtime. Java cannot predict ahead of time during the compile time the result of x. So the only way we can restrict to not make changes to these local variables is when we make it to final. So that's the very reason why we have a compilation error. Okay, let me just show you updating this value x to 30. Error. Hope that makes sense. Now you may ask me, this variable in here is not final, but still we didn't get a compilation error. This is not final, but this is effectively final. Since Java 8, they removed the restriction of making a variable as final, but it should be at least effectively final. What that means is I didn't make any changes to this variable, so that means effectively it's a final variable, and Java will allow me to do so, allow me to access. Now let's say I update the value to 40, let's say. Now this will definitely show an error saying local variables referenced from the inner class must be final or effectively final. Makes perfect sense. Let's get rid of this. If you run the program, you would definitely see the value 10. Let's do it. There you go. See you in my next video. In this video, we're going to talk about string data type. String in Java is nothing but collection of characters, just as a word in English language, which is collection of letters. This is how we represent a string in Java. Now, by taking a look at this statement, you may think that string is a primitive data type, but actually it isn't. String is a non-primitive data type or user-defined data type. So essentially, string is a class, and we're in fact creating an object of this class to be able to create this string. Well, we're not explicitly creating an object using the new keyword, but Java does that for us. So this statement in here can be represented in this manner as well. We have a character array which has all these characters, A, P, P, L, E, and we're sending that character array as an argument to the constructor of string class. These two statements in here does exactly what this single statement does. For the convenience of the programmer and to save time and effort, Java designers gave a shorter way of representing these two statements. So let me comment them out. Save the file. If I try to run this program, then we would see Apple as the output. Let's do that. Let's comment this line and try to run the program by uncommenting these two lines. We would see the same output. Great. So why Java designers decided to have string as a non-primitive data type? That's because it gives us lots of flexibility. There are lots of methods in this class string that we can utilize for our own convenience. For example, let me just uncomment all these lines of code. Save the file. Now by calling a method inside that string class called length, we can get the length of that string, whatever the string is. Similarly, we can convert that string to uppercase by calling this method called toUpperCase. We can replace a character. We can find the position of a certain character. We can also extract the substring of a string. For example, in the string apple, we might want to get a substring like PLE or something like that. Now let's see how this program works. Let's run the program. Here it is. We're able to utilize that string class and perform certain operations on the string. There are many such methods in string class. For more information on them, you can refer to this link. Actually, you don't have to go inside this link. If you just use the dot operator, your IDE will suggest what are the methods available that are of public. And we also have explanation of each and every method, so you can just go through it. It's pretty much self-explanatory. Let's undo and save the file. In our next video, we're going to talk about string as immutable. Open the class called string immutable under the package string package. Let's expand it. Can you make a guess on the output of this program? We have a string here we're trying to convert that string to uppercase and we're printing it. Would the output be uppercase apple, or would it still be apple? Alright, string is said to be immutable. That means once the string is there in the memory, nobody can ever change it. And when I say string is immutable, I'm only talking about the literal, the right hand side of this equal sign. We can always change to which object this reference type points to. If I run this program, you will not see the uppercase apple. You would still see the apple, lowercase apple. Let's run the program. Now before you start yelling, what the hell is going on, I'll take you to the whiteboard and explain you in more detailed fashion. Let's go there. So again, we have our stack memory and heap memory. Now this statement in here, as we've looked at in our previous example, will essentially create a new string object using the keyword new. So the reference type would reside in the stack and will point to an object inside the heap memory, which in this case it would be string apple. This is not the case in case of string. What actually would happen is we have a special memory inside this heap which is called string pool, and this string object would be created in here, and this reference type would point to this object. So why do we have a string pool? You will understand that in a minute. You will also understand why string is immutable. Let's say I have another statement that says string str2 equals apple, the exact same string what we have here. So this being reference type, we'll have it inside the stack str2. This statement will not create a new object inside the string pool. Instead, it would just point to the exact same object because they're essentially holding the same exact string, apple. Now can you guess why Java designers made string as immutable? That's because let's say we have a statement that says str.to uppercase. If the string is mutable, then this statement will make changes to the actual object, and this will impact str2 because it is pointing to the exact same object. Likewise, there could be many number of string references which are pointing to the same object across all the programs. So we cannot let the programmer make changes to that string at any given point of time. So this answers why string is made immutable. But why do we have string pool in here? By now you should have understood it. We have string pool primarily to save the memory. So these two string reference types are pointing to the same object. We didn't create two different objects for these two instructions. That saves the memory of one object. If we have 100 strings created which are holding the same name, same string, apple, then all of them would actually point to the single object in the string pool, and it won't create multiple objects. So there's a great memory advantage. But just in case if you decide to not bother about memory, and if you decide to create string object in heap memory, there is a way to do that as well. So this is how you do that. String s1 equals new string, and then you will pass
the string as an argument to the constructor of this class, which would be, say, banana. This instruction will create an object inside the heap memory, as well as a copy would be created inside the string pool. Now let's say we have another statement, the exact same statement but with a different name. New string, say banana. Ignore the typo. Now this will create another object inside the heap memory. So although the strings are same in this case, two different objects would be created in the heap memory. Now let's say we have one more statement, say string s3 banana. Would this create a new object in the string pool? It won't, because by doing this statement we've created an object in heap memory as well as in the string pool. So this statement, the s3, will point to banana in the string pool. Hope that makes perfect sense. Let's go back to our program. But before that, let me just show you one of the security threats had it been the case that the string is mutable. Let's say you have two computers. Computer 1 is authentic and computer 2 is insecure. It has some malicious software in it, and you don't want to access that machine from your program. In your program, you have a method that says connect, and you're going to send the IP address or the system name as a parameter. Your program will check to see if the connection is secure. If it is not secure, then you're going to exit. If it is secure, then you're going to go ahead and connect and do some operations. Now let's say you sent argument as computer 1. This check will pass because it's a good computer. But before you reach the statement connect, some other program would modify this string to computer 2. So you're actually connecting to a computer which has malicious content in it. This is a serious security threat. Thankfully, string being immutable, nobody can ever change this, computer 1. Hope that clarifies. Let me just uncomment this code in here. In our previous example, we have already looked at the use of double equal sign for primitive data types. But this operator will also help us in checking to see if these two reference types are pointing to the same object or not. Can you make a guess on the output of these three instructions? Okay, this line will create a new object in the string pool and has the reference A. We have another reference B and will actually point to the exact same object created in the string pool. So hence the output of this line would be true. These two reference types are actually pointing to the exact same object in the string pool. Coming to this instruction will create a new object inside the heap memory, and this instruction will also create a new object in the string pool. This will point to the object residing in the string pool. But these two are two different objects. One is in the heap memory, one is in the string pool. So this statement would return false. Now how about this? These two are two different objects in the heap memory, and hence this would be false. Let's try to run the program.
There you go. There could be times where you want string to be mutable. That means changeable. In that case, you want to use string buffer class. Let's expand it. I have an object of string buffer, and I'm sending a string as an argument to its constructor. I'm also calling a method inside it, append. This will append this string, basically whatever I send as an argument to that method. And this works. This statement in here will club both these strings and print as a single string. The key thing to understand is we're able to modify the string itself. So what is one good reason why you would want to use string buffer? Is it has a performance advantage. For example, take a look at this line. We have two strings, and using the plus operator we're performing concatenation. Although this line looks simpler than these three lines, in terms of performance this will perform better. Also, there are some methods that are part of string buffer that you can utilize. For example, we can insert some text at a particular point in that string. In this case, we're trying to insert this text at index 10, and we're printing this statement. We can also reverse the string. This will reverse the string. Let's run this program. These two strings are clubbed. I'm able to append this string, and in here we inserted this text at index 10, so that's some text inserted, and we reversed everything, the entire string. It's better to use mix of both. So once I do all sorts of manipulations that I need to do with the string, it's better that we convert that string buffer to a string class using the method toString. So once we convert this to string, then again the string will become immutable. So you can utilize the advantages of both string and string buffer. We'll talk more on the string buffer, string class, and string builder at later point of time once we cover the concept of multi-threading. For now, this should suffice. See you in my next video.
In this video, we'll talk about Java Virtual Machine architecture. JVM is a pretty complex architecture. That being said, we don't need to know each and every component in it. I'm just going to walk you through some of the major components that will add some value to your learning. Moreover, there are multiple vendors for JVM, and each vendor will have their own architecture for their JVM. So no matter what architecture I introduce to you, it won't be a complete architecture. So let's just focus on some of the major components that are commonly found in any Java virtual machine. And I bet you don't need to know anything more than that. First of all, you have your source file or the Java file. We compile it and then we get a .class file or the bytecode. Now this .class file will be fed into the Java virtual machine. And this is where all the magic happens. Now let's go deep into it. At a very high level, there are three major components in JVM. Number one is class loader subsystem, which is majorly responsible for loading all the required class files into the system. Now, I'm not going to write the complete words, that would mess up everything. So I'm just going to represent with few uppercase letters, like so. You may want to pull a pen and paper and take down the notes if you're interested. Now, the second major component is execution engine, and we'll have things like just-in-time compiler, interpreter, etc. And the third major component is runtime data access, and is majorly responsible for fulfilling all the memory needs for JVM to run your code. Now let's go deep into it. The first component that comes into this picture is class loader subsystem. The class loader subsystem is majorly responsible for loading the class files, and in order to perform loading, there are a few other subcomponents that come into picture. Number one is loader. The job of loader, as the name suggests, is to load all the necessary files into the Java virtual machine to run the program. The loader is actually a combination of three different things. One is Bootstrap class loader. Bootstrap class loader is a program that will load all the class files that are essential to run your program. Essentially, it's rt.jar file from your JDK directory. RT stands for runtime. And without loading rt.jar into the system, JVM is virtually useless because the rt.jar constitute all the key files that JVM uses to run your program. Also, it's worth noting that this Bootstrap class loader program is actually written using a native language like C, C++. The second subcomponent of loader is called extension class loader and is responsible for loading all the .jar files that are in extension directory. This is essentially the folder named ext in your JDK directory. And typically, if you want to use any external class files or .jar files, you would keep them in this extension directory. We've already talked about a scenario where you're using an external .class file. By the way, if you don't know what's a .jar file, for now you can think of it as combination of one or more .class files. So whatever you keep in the extension directory will automatically be taken into the JVM. Now the third subcomponent of loader is called application class loader, which is responsible for loading all the class files from the class path. In the beginning of this course, we've talked about configuring the class path. Whatever resides in that class path will be loaded into JVM by application class loader. Now the second component of class loader subsystem is linker. The job of linker is to verify that the generated bytecode is in proper shape. Basically, it would sort of perform a compliance test and would see if the bytecode is compliant or compatible with the Java virtual machine. If there is any problem with the bytecode, we would see a runtime error. You would almost never come across with this error though. The linker will also allocate memory for all the variables present inside the class file, which also includes static variables. And not just allocating the memory, but also updating the variables with their default values. For example, for integer, it's the value 0. And finally, we have initialization phase. This is where all the variables will be assigned with their actual values. And this is also the phase where all the code in the static blocks will be executed. Now, I guess I haven't yet talked about the static block, but we'll talk about it pretty soon. The second major component of JVM is runtime data access. In this, we have something called method area. I said that the loader will load the class files, but where does it load? It's in this method area where all the data will be stored in class structures. And the data gets stored in certain format so that the execution engine will be able to execute the code comfortably. Also, the data in the method area would be identified with a unique address. The second memory section we have is heap area. We've already talked about heap area many times and we know what it is, so I'm not going to go through it once again. Now guess what? We have stack area and we know what it is. We've talked about it in our previous examples. And then we have something called PC registers or program control registers are there to hold the address of the current executing instruction in the program. Once the current instruction is executed, the PC register would be updated with the address of next instruction. That way it keeps on getting updated till we reach end of the program. Let's talk about execution engine. As I've already mentioned, this would have components that will help execute the program. So this will have the interpreter, and we know what it is. It has just-in-time compiler. We've talked about it in the beginning of this course. And finally, we have garbage collector, which is a process that happens periodically where all the unreferenced objects will be wiped off from the memory to save the memory for other objects. And we have something called native method library. These are all libraries that are essential for you to run a native program. For example, let's say that you wanted to run a C program from your Java program. So you would make use of these native libraries to be able to do so, because JVM is meant to run Java programs, not native languages like C and C++. And we have JNI, stands for Java Native Interface. It is basically an interface which the execution engine uses to kind of access the native libraries to be able to run the native program. There is also a separate memory section dedicated for running native programs, and that is called native method stack. All these components sort of work together to accomplish the task of running your Java program. Isn't that amazing? Also, I just want to quickly talk about the role of JVM in multithreading. Now, we probably don't know what is multithreading. We have a chapter dedicated for that. It's a pretty big chapter, by the way. But just for the sake of this video, for the completeness of this video, I'm just going to give a quick overview on what is multithreading. Let's say that you have a program and say that you have few instructions that will help you download a file, and say that the download will take around 10 minutes of time. And then in another section in the same program, you're doing some kind of a mathematical operation. Now, if you observe, these two operations are completely independent of each other. The mathematical operations that you perform has nothing to do with the file download. Now, the problem here is, if you run this program, this section will have to wait until the file gets downloaded. Why should we let that happen? This is where the multithreading will come into picture. If we can separate these two tasks into two different threads, say download operation in thread T1 and this mathematical operation in thread T2, now these two threads can actually run simultaneously. That way we're saving a lot of time. If this sounds confusing, then you'll have to wait until we get to multithreading chapter. But the reason why I'm explaining you this is, let's go back. These two memory sections, PC registers and native method stack, will be allocated for each and every thread, while method area, heap area, and stack area will be shared across all the threads. So say that you have 10 threads, then for each and every thread, you got an individual PC register and native method stack. But all those 10 threads will share all these three memory sections. Again, if this sounds confusing, you'll have to hold on until we talk about multithreading. Alright, that's it on this video. See you soon.
So far, we have used NetBeans IDE to run our Java programs, but now it's time to move on to Eclipse IDE. Now, I remember I told you that we're going to go through all these features in here, but I felt it's better that I talk about all these features in the Eclipse IDE itself, not to create any confusion. Eclipse is the most popular integrated development environment used in the software industry to help build the Java projects. Eclipse is also an open source supported by thousands of contributors, and it definitely makes a perfect choice for developing Java applications as well as the Android applications. So why should we wait? Let's go ahead and download and install it. Go to eclipse.org and then click on download. We have multiple versions of Eclipse. By the time of this recording, Eclipse Neon is the latest one. So let's download it. My PC is 64-bit and that's why I'm downloading 64-bit version of Eclipse. Let's click download. Our download started. Okay, I have that downloaded. Let's install it. Run as administrator. By the way, I have moved my operating system to Windows 10. The reason why I mentioned Windows 7 earlier is because by the time of this recording, Windows 7 is the most popular operating system. And hence I have told you how to configure your Java environment on Windows 7 operating system. It's exact same steps which you need to follow even in Windows 10. Let's move on. Click yes. We have Eclipse IDE for Java developers and an IDE for Java Enterprise Edition developers. We also have Eclipse for C and C++, so on and so forth. But what we want is either of this. Since we're in our future videos, we're going to get into Java 2 Enterprise Edition. Let's install that. Click on install. Accept the license, of course. Accept the license again. It's going to take quite a while. Click launch. You can give any directory that you wish. I'm going to give new Eclipse work directory under E drive. So this would be the place where all your projects would be residing. Click OK. If you're interested, you can go through these tutorials, samples, etc. But I would just like to skip. So here is the Eclipse, the most popular IDE for developing Java apps. Let's try to create a project. Click New. And what we're looking for is Java project. We have many different types of projects that we can create, but most of these are at the moment or not of any use. Select Java project, click Next. Give the project a name. First project. If you want, you can play around with these options. And let's finish. This will create a new project. Click Remember My Decision and click Yes. Here we have our project. Now right click on it, click on New, Class, give it a name, First Java Program. Now the beauty of Eclipse IDE is that you can play around with these options. If you want main method to be present, then you just have to check this checkbox. Similarly, if you want to have constructors from superclass, obviously you don't know the term superclass as of now. You will get to know about it when we talk about inheritance, etc. But just take a look at this and have a glimpse of what it is doing. Let's click Finish. So here we have our first program. Now here is a little surprise to you. Eclipse IDE is actually a lot easier than NetBeans IDE. As you can see, we have a menu item that is similar to a Word document. If you click any one of them, let's say source, and by just looking at these words, you would be able to figure out what it does. For example, you can generate getters and setters, etc. Obviously, we're going to be using majority of these functionalities pretty soon. Stay tuned. Okay, let's talk about our first Java program. Let me just insert a statement in here, which is a simple system.out.println. Let's expand this by double clicking it. So far, we haven't yet talked about our first Java program. If you take a look at other tutorials, they'll start right off with their first Java program and try to explain you everything. But now, I bet, by just looking at this program, you would be able to figure out what's happening. For example, we know what public is doing here, and we know what static is doing here, and we also know why main method has to be a static method. We know this is a written type. We're not returning anything from the main method, hence it's void. We also know what this statement does, as we talked about it earlier. The only thing that's strange to you is this. You can easily guess that we're sending a string array as an argument to this method main. But how do we ever send an argument to a main method? Let me introduce to you command line arguments. Before we take a look at how we send arguments to the main method, the string array, let's have a couple of instructions that will loop through all the elements of the string array and just print them. Now let's see how we can send arguments. Click on Run, Run Configuration, choose the program, click on Arguments, and send a couple of arguments here, like so, and click on Apply. I had already done that. Click Run. See, we have those arguments printed. This all looks complex, but essentially what we're doing is, remember our first Java program? Before even installing the NetBeans IDE, we had run our programs through command line. And when we do so, we use the command that looks something like this. We did Java and then program name. This is how we run our Java programs, through command line. But in addition to this, we just send some arguments, some random text with the space as a separator. Whatever you enter here as an argument separated by a white space would be sent as an argument to the main method, and that's nothing but command line argument. The Eclipse way of doing this is by going to Run Configuration and then Arguments, provide your arguments. Now I know this all process looks a little complex. You're probably annoyed at the moment looking at all these tabs, etc. Trust me, in just a few chapters you feel absolutely comfortable with Eclipse IDE. It's pretty easy to use and is meant to make your life easy. Let's close. See you in my next video.
Let's talk about JShell, which is one of the main features introduced in Java version 9. You can think of JShell as a fun little toy, or rather a professional toy that a beginner Java programmer can play with. Well, what do I mean by that? JShell is actually a command line tool which will read the input from the user, and the input that a user can enter can be any valid Java expression, something like integer x equals 10 plus 5. The same would be executed, meaning that it would calculate the sum of 10 plus 5 and store the value inside the variable x and same would be printed on the console as x equals 15, which will then be seen by the user. And the same process would be repeated again and again, which means it's going to allow the user to enter something once again. It's going to execute it and print some results. So that's read, execute, print, loop. Read, execute, print, loop, or simply REPL. But what's the significance of this? Well, it is to create a good first impression on Java programming for someone who is getting started to learn Java. Let me explain it with an example. Say that you are a beginner programmer and you've heard a lot about Java programming being one of the best languages to ever exist. You're pretty excited to learn Java, and so you just wanted to try with a very simple application, which is probably a Hello World application. So for that, what you have to do is you need to create a class and then introduce a method with the signature public static void main, string args, and only then will you actually introduce a statement that will print the message that you wanted to print. And it's not enough that you write the source code. You actually need to create a Java file, copy that source code inside the Java file, and compile the Java file so that you get the bytecode, and then you run that class file, only after which you will see the results. Now think from the perspective of a complete beginner who doesn't know anything about programming and he wanted to learn Java. This is surely going to create a bad impression because he wanted to experiment with Java by just printing a simple hello world message, which is this part, but he's also required to pay attention to a lot of other things which might take a while to understand. Like they may be having questions: what is public, what is static, what is void, why the method name has to be with the name main, and what are string args, where are they coming from, and what are they doing, and why is this called a method in first place, not a function like in other programming languages. So they get all these questions, and ultimately they come to conclusion that Java is a very difficult language to learn when it actually isn't. So JShell will come into rescue in this case. It will allow them to enter some Java expressions and instantly see the results without having to introduce the class or main method or even compile the Java file, etc. And when they see results based on what they enter, that will give them some confidence that they can learn Java. So JShell would actually give that first good impression about Java programming for someone who is getting started with Java, so that it will motivate them to learn more and execute better Java code. It's like if you make a good first impression with your crush, then your journey would be smooth. Otherwise, if you make a bad impression in the very first go, then obviously, no matter how hard you try, everything would look very complicated. But that being said, you might be coming to conclusion that JShell is not a tool for somebody who is experienced or somebody who already knows Java programming. Well, that's not the case. I mean, let me try to give you a use case where JShell can be useful for professionals. Imagine that you are working on a real-time project and you're required to validate the user-entered form. One of the things that you might do is to check the length of the person name, and you want it to restrict to only 10 characters. You're probably going to use one of the methods available in string, like the length method, that would give you the length of a given string. Now, you don't know if the length method would consider whitespace as a character or not. And if it does, you don't know if the length method would consider multiple whitespaces as a single whitespace or multiple whitespace characters. In order to figure this out, you would either need to write a test case that will test multiple scenarios, and this is definitely a lengthy process. A better approach, however, which I usually used to do before JShell, is to create a Java file, have a sample code with bunch of variables, and experiment with the string manipulation methods and see if result is as expected. But that still takes a bit of an effort, because inside Eclipse, if you want to run Java program, you have to actually create a Java project. Once you do that, you have to again introduce a class file with public static void main, and only then you can experiment with your code. With JShell, however, you can just execute this statement alone on the console, and you'd get the results instantly, and you can figure out how the length method is working. This definitely is a lifesaver at times. Next, we're going to take a look at how we can play with our professional toy. Alright, let us try to play and experiment with JShell. In order for JShell to work, you need to first install Java, which I assume you did. In case if you want to verify you've successfully installed Java, just type in the command java-version and you should be able to see the version of Java that you've installed. Once you do that, type in the command jshell. Just as you have the commands Java and Javac, you also have the JShell. And once you hit enter, you're going to see a welcome message. Along with that, it has also indicated us to take a look at the help document by typing in help. So this is all that JShell has to offer us. What we're going to experiment with right now are vars or variables and methods. I'm going to say I equals 10 to start with, and this is going to show us an error. If you're an experienced developer, you probably know what this error means. This means that we don't have a variable I in order to assign a value to it. Java is a strongly typed language, and when you declare a variable, you have to be specific about the type of data that a variable can hold. But if you think from the beginner perspective, they probably don't understand what this error means. And in order to understand this, they're probably going to do a Google search. And when they do a Google search, they're probably going to come across with public static void main, and they'll be lost in a different world altogether. So this is something that I wish that the Java community might want to improve upon. They better be more specific about the errors so that a beginner can actually understand it in better fashion. So instead of saying I equals 10, I'm going to say int I equals 10, and this works. I'm going to initialize another variable, j equals I plus 20. So this is an expression, and that has been evaluated to 30. We can also type in any valid Java statement, system.out.println hello world or whatever, and it works. We can also write methods. I'm going to say void math accept no arguments, and I'm simply going to print out something. System.out.println sum is, I'm going to say I plus j. So this should ideally be printing 40. Okay, method has been created, and the way you call it is, you don't have to create instances. You can say math, and that would execute that method. Now you might be wondering how JShell is able to memorize the data that we've entered, the variables, the methods, etc. Well, behind the scenes, it's actually maintaining a class file with whatever the methods and variables that we're trying to experiment here. But it's going to abstract all that stuff from the user because of the fact that it is assumed that beginners would actually play with this tool, and they don't want to complicate things. Obviously, that's the very reason why JShell even come into picture. Going back to our earlier example where you're a serious professional who's trying to understand the length of a string, you can enter John Doe dot length, and this should print the length of John Doe. You want to verify if the length method would also consider white spaces as a single character. I'm going to enter multiple white spaces and hit enter, and it shows 18, which means I can conclude that the length method would consider white spaces as a character. Let's take a look at what else we have under the help document. We have list. It's going to list the source you have typed. Let's do that real quick. If I say list, So these are all the set of commands or the expressions that we've entered. You can also edit a specific item by its ID. So these are the IDs. Let's say I would like to change the value of I to something else. So I'm going to say edit 1. Okay, this has shown us a cute little prompt where we can actually do some edits. I'm going to change this value to 100 and say accept. So the value has been changed to 100. Now if I call math, obviously this will show the updated value. And likewise we got other commands that we can run. You also got save in case if you'd like to save this session. By the way, if you exit out of the J shell by entering exit, then everything would be lost. So maybe you want to save it. You can just save it into a file and then you can open it by pointing to that file so that you can continue working from where you have left previously. Imports would just show us list of imports. It's pretty straightforward. So that's pretty much what J shell has to offer. But like I said before, this is not a full-fledged, complete, beginner-friendly tool. Because as a beginner, if they want to experiment with variables and methods, they probably need to know what is a variable. And in order to know that, they need to write a program. And to write a program, there they're going to see public static void main and questions would start popping up. So we can think of this tool as something that's more like a confidence builder than to do anything significant. But for an experienced developer, this is a quick tool that you can just simply launch and execute few statements if the need arises.
In this video, I'm going to talk about inheritance. Let's say we have a person A and he's pretty good at playing tennis. Let's say A gets married and gives birth to Mr. B, who is pretty good at playing football. Now B will also inherit some of the properties from his father A. That means apart from B's ability to play football, he can also play tennis because he inherited such properties from his father. And B is naturally talented in playing tennis as well. Now let's assume B gets married and gives birth to Mr. C. C will inherit properties from his father as well as from his grandfather. So C can play tennis as well as football. Apart from this, he will have his own individual talent of playing hockey. What I'm talking about here is the inheritance, the ability of a person to inherit some of the properties from another person. How do I explain this in the context of Java? Let's say we have a class called animal. If I have to write a Java program for the animal class, then I would have the following methods: walk, run, or maybe sleep, etc. Now let's say I have to write another class for dog. Now dog can again walk, it can run. Apart from these two, it can also bark. So why should we write this code again? Instead, why don't we just inherit such behavior from its parent animal? Every dog comes into the category of animal. So it's okay to inherit some of the properties and behavior from the animal class. The Java way of inheriting properties and behavior from another class is by using the keyword called extend. So we say dog extends and then the class name animal. So essentially we're extending the abilities and behavior of the dog. When we create an object, we can not only access the methods inside the dog class, but also we can access the methods inside the class from where dog class has inherited. That means the animal class. Hope that's pretty clear. Now we can also have another class, say puppy class, and it can inherit some of the properties from dog. So as we go down the hierarchy, we're becoming more specific, and as we go up the hierarchy, we're getting more generic. So that's what is inheritance in Java. In this example, the animal class is called a parent class or a superclass or a base class, while the dog class is called a child class or a subclass or a derived class. Dog is a child class of animal. Puppy class is a child of dog class. Hope that's clear. Let's take a look at one last real-world example. Let's say we have a robot class. Then it can have methods like start, walk, use navigation, something of that sort. Now we can have another class which is a cleaning robot, and it will extend the behavior from the robot class. And in addition to all these behaviors, cleaning robot can also do the job of cleaning. If you observe one thing, everything in here is having an easier relationship. That means dog is a kind of animal. A puppy is a kind of dog. Similarly, cleaning robot is a kind of robot. Hope that makes sense. Let's talk about types of inheritance. We have 5 types of inheritance in Java. If we have 2 classes A and B, and if B extends A, this is called single inheritance. And we have multi-level inheritance wherein we'll have 3 classes. C will inherit the behavior from B, and B will inherit the behavior from A. This is called multi-level inheritance. We have seen an example of this a moment ago. Similarly, we can have a class, say animal. We'll have class called dog, which will inherit the properties from animal class by extending. We can also have another class called cat, which will also inherit the behavior from animal class. This is called hierarchical inheritance. So essentially, dog class will extend the animal class, and even the cat class will extend the animal class. Let's talk about multiple inheritance, wherein we'll have a couple of classes A and B, and we'll have a class C which will extend the behavior of both A and B. Java does not support multiple inheritance by extending 2 classes. That means C cannot extend the behavior of A and B. We have a problem with that approach, and I'll discuss that at later videos. Similarly, we have hybrid inheritance, wherein we'll have class A, we'll have class B and class C. B and C will inherit from A, and we'll have class D, which will inherit properties from both B and C. Even this is not possible in Java. But that being said, Java does support multiple and hybrid inheritance using interfaces. So let's preserve these two for next chapter. In our next video, we're going to take a look at examples of these three. Now let's go through some of the examples. Before that, let me just show you how to import this project into your Eclipse environment. Click on File, click on Import, choose this option, Existing Projects into Workspace, click Next, choose this radio button, which is select Archive File, click Browse, choose the zip file that I have bundled along with this chapter, click Open, and click Finish. That should import this project into your workspace. Once you do so, open up these files. We have a class called Living Being, Animal, and Dog. What I'm talking about here is multi-level inheritance. We have three classes. Dog class is extending animal class. Animal class is extending the living being class. If we create an object of class dog, then it will inherit properties of both living being as well as the animal. That's exactly what I'm demonstrating here. We have a dog object here, and I'm able to call all the methods from these three classes. Since we talked about multi-level inheritance, this should also suffice for single inheritance. Now let's talk about hierarchical inheritance. For that, I have another class which is cat. Both these classes, dog and cat, will belong to animal category, and hence these two will attain the properties and behavior of an animal. Dog class extends animal, cat class extends animal. If I create an object of cat, then as you can expect, it can access the behavior or the methods from its parent and grandparents. Let's run this program. You can just run it right away from here. There you go. If you're interested, you can just go through all the output. All I'm doing is I'm just printing these strings. Hope that's pretty clear. And when we talk about interfaces, we'll cover the problems we have with the multiple and hybrid inheritance in case if we use classes to extend their behaviors. For now, they should suffice. See you in my next video. In this video, I'm going to talk about a keyword called super. Super is a keyword that we can use to access the parent class or superclass constructor, method, or member variables. Here is the example for that. I'm just creating an object of class dog that will invoke the dog class constructor. Inside that constructor, I'm using the keyword super to call the superclass constructor, which is animal. In that I have a default constructor with in which we're just printing a string. We're also able to call a method inside the superclass by using the super keyword. We can also access the member variables with the super keyword. This is essentially like this keyword that we had talked earlier, but super is for superclass. Let's run the program. It worked. Animal class constructor from this instruction, and we got walking from this instruction, and we're able to access the member variables without any errors. That's great. And finally, we're printing this string. Also note that when you're calling a constructor of a superclass using the super keyword, then it has to be the first line of the constructor. For example, if I just cut this and paste it in here, we get an error. Let's see what that says. It says constructor call must be first statement in a constructor. So that's invalid. I cannot keep this statement in here as well. It has to be the first statement. Even if you don't specify super in here, by default Java compiler will implicitly put a super statement in here. If you don't believe me, let me run this class and would get the exact same output as before. So Java has implicitly put the super keyword in here to call the parent class constructor. To demonstrate the same in more detail, let me just get rid of all these two. Let me just get rid of these two lines in here. Let's save the file. Let's do Ctrl+Shift+F to give a proper indentation to the code. We have a constructor in here. Let me also uncomment this constructor in living being class. Let's save the file. We have 3 constructors in all these 3 files. We no longer need it. Now by creating the object of the dog class, it's going to call this constructor, and implicitly Java will put a super statement in here. So super would be called. That means it will invoke the constructor of animal class. And even in here, the first statement of this constructor would be super. So it will call the constructor of living being. So we'll see this message first, and then we'll see animal class constructor, and then we'll see dog class constructor. Let's try to run this program. There you go. Now just in case if you get rid of the default constructor and make use of some parameterized constructor, let's say intex or something, we would get an error because it is expecting default constructor to be present. In order to fix this error, you'll have to explicitly use the super keyword and use that constructor of the parent class. That way we'll get rid of the error. Now this brings me to talk about a couple of other topics: instance initializer block and static block. Let's talk about them. Let's first talk about instance initializer block. Let's say we have a couple of more constructors in here with, say, int y and a default constructor. Save the file. Now let's say there is a piece of code that is common in all these constructors. I'll have to write it repeatedly in each and every constructor. There's a workaround for this. We use instance initializer block. It's just an empty block with a couple of curly braces, and inside which you write all the instructions that you want to be executed before executing any of these constructors. Let's do system.out.println. Now no matter which constructor you call, it's going to first execute this block. Let me demonstrate you that. Now instead of dog class, let me just create an object of the animal class. Let's run the program. So first, the living being constructor got executed, and then the instance initializer block, and then the animal class constructor. So what has actually happened? When we created an object of animal class, since we didn't send any parameters in here, it's going to call the default constructor. The first statement of the default constructor would be super. This will call the constructor of the superclass, and hence we have seen this message, living class constructor. And the next statement would be to call the instance initializer block, and hence we see this message, instance init block, and after that the actual constructor will get executed. By looking at the output, you may be tempted to think that this is called first, but actually the constructor will be called first, but the instance initializer block will be called before executing the statements in the constructor. So somewhere in here it will call instance initializer block. Hope that makes sense. So whenever we create an object, it will call the constructor first, and then the first statement of constructor would be super. If there is no superclass present, then the first instruction is to call the instance initializer block, and then the rest of the statements in the constructor would be executed. Hope that makes sense. Now let's talk about static block. The way you represent static block is the same way you represent an instance initializer block, but with the word static. We've talked about the keyword static many times before. When we say static, this block is associated with the class, not with the object. So this block in here will be executed only once per class, no matter how many objects you create from that class. And this would obviously take the highest priority. In fact, it's not about the priorities. Before even creating the object, this block would be executed, and then the rest of them would come into picture. Let's say static block, and let's run the program. Static block and rest of the instructions follow. So when will the static block gets called? A static block will get invoked when the class is first loaded. That means either when the object is created or when one of the static members is invoked. For example, we have, let's say, a method which is of static say void some method, and system.out.println static method. Let's save the file. Now I can just use the class name to access that method since it's static. So that's animal dot some method. Let's run the program. Fair enough. Static block and then the static method. Alright, hope this all makes sense. See you in my next video. In this video we're going to talk about instance of operator. It does exactly what it says. It will check to see if an object is an instance of the specified type, and it will give us a Boolean result. Let me just demonstrate to you what I meant. Let's say we wanted to validate this statement in here. So we want to check to see if this object is an instance of animal class. So what we're going to do is system.out.println, and we're going to say is any object, any obj, instance of animal. Of course, let's get rid of the statement. Let's run the program. True. Alright, let me just pause the video and comment out all these lines. They're a little misleading. Alright, here we are. Let's run the program. Now let's try to do the same for this statement. Let's do Control C and Control V. This will give us a compile time error because cat and dog are two distinct types, just as we got a compile time error in here. Let's try to do the same for, say, this statement. Let's copy this paste it over here. Any object belongs to dog. Let's try to see. It's not. Let's try to do type conversion. Save the file and try to run it again. Class cast exception, just as we got with this statement. Now instead of any object, let's try to do it with A1. I would expect the result of this statement, which means our explicit typecasting should be successful. Let's try to run the program. True. Great. Hope we got a sense of what instance of operator is, and this is going to be a pretty useful operator in future. Okay, in this video we're going to talk about polymorphism. Polymorphism is the ability of an object to perform the same action differently depending on the context. Let me explain you what I mean. Let's take a real-world example. Let's talk about a cat. Let's say a cat will run at a speed of 10 kilometers per hour. Now if a dog is chasing the cat, then it will run faster, maybe 15 kilometers per hour. So depending on the context, the cat is acting differently, but the behavior is same. Ultimately the cat is running, but the speed is varying depending on the context. That's exactly what polymorphism is. So in here, in the cat class, we have two methods. Both these methods perform the same action, which is running. But in this run method, the cat will run at 10 kilometers per hour. In this method, it's going to run at the speed whatever I send as a parameter. In our Java program, I've created an object of that class, cat. When I do cat object.run, it's going to call this method. When I do cat object.run, by sending a parameter, it's going to run this method. So what we have done is overloading, which we have seen in our previous example. The point I want to make here is ultimately the cat is doing the same job of running, but it is running differently. This is called compile time polymorphism. That's because during the compile time itself, the compiler will know which method to call. Although the name of the method is same, the signature is different. I mean, either the number of parameters or the type of parameter is different, just as we looked at in our example earlier. Now let's talk about runtime polymorphism. Just as we took real-world example for compile time polymorphism, let's take a real-world example for runtime polymorphism. Let's think of an animal. Every animal screams, but the way the scream will happen is dependent on the animal itself. Take a look at this example. In this animal class, we have this method screaming. But if you see, a dog will scream like a dog. So we have a scream method in the dog class, and it's going to scream like a dog. The thing here to understand is we have the exact same signature as to that of the scream method in animal class. What we did here is overloading, where we have two methods with the same name but different signature, and Java will not let us write two methods in the same class with the same signature. But it's possible in overriding, because in this class, this is the only scream method with this same signature. Now let's understand what is runtime polymorphism. In this class, we have an animal object, and using that object, I'm going to call the scream method. This instruction will call the scream method inside the animal class. But whereas if we have animal reference type, and if it points to a dog object, then this instruction will result in calling this scream method. So depending on the type of animal, the scream method will act differently. Ultimately, it's just screaming. Now again, if we have, let's say, a cat class, then we can have the same exact method. Scream like a cat. Now let's copy this code, paste it over here, cat and cat. Now this scream method is going to call the scream method of cat. Hope it makes sense. In order to make sure that the method that you wanted to override is indeed overridden, you're going to use the annotation called @O overwrite. This annotation will make sure that this method, the method that is next to it, is overridden. If you make changes to this method, for example, give it a different name, it's going to throw us an error. Or if you add another parameter, it's going to throw us an error. Let's see what the error says. The method scream int of type dog must override or implement a subtype method. We're going to override, but what is implement? We'll know about implement keyword when we talk about interfaces. But for now, let's undo the changes. Let's keep this annotation, it's a good practice, and I always encourage you to do the same. So the point I want to make here is, depending on the type of object to which this reference type is pointing to, it's going to act differently. Ultimately, all these objects are animals, but an animal can be a dog, an animal can be a cat, and depending on the type of animal, we want to trigger its respective behavior. Hope that makes sense. This is called runtime polymorphism. That's because during the compile time, compiler cannot make out which scream method to call. Should it be the scream method inside the animal class, or should it be the scream method inside the dog class? It just can't make out. So the JVM would be able to do that. It's going to override the method inside the animal class, and depending on the object it is pointing to, or we call it the true object. So this scream method will call the method inside that true object. Now where's the typecasting here? Java has done that for us. What has happened in this line is widening. Every dog can be an animal, so it's widening. But in case if you wanted to utilize the methods inside the dog, then you can always do explicit typecasting of this animal to dog. For example, you can have a statement that says something like this: dog D equals, just copy and paste it over here. The auto suggestion will actually fix the problem. It will automatically convert this object to dog. It will suggest us to convert this object to dog. And now you can always call attain the behavior of dog on the D object, d.bark. It's valid. But whereas if you're trying to do the same with any object whose true object is animal, then this would yield a compile time error. For example, you can't do this. It will result in compile time error, class cast exception. Let's undo those changes. Another point which I want to point out is this will actually make our life a little easier. Let's say we have a method that's just going to print the details of that animal, let's say. So print details static. This has to be static. The reason is this is a static method and we can only call another static method, and inside this we have something that does something. This is not going to return anything, and the parameter that we send is animal A. This way this method can accept literally any animal. And let's say we have 100 different types of animals like dog, cat, crocodile, elephant, etc., and they all inherit the behavior or extend the animal class. So we don't have to write 100 different methods for each and every object. We don't have to have the same method written for dog and the same method written for cat, etc. Instead, we can just send the parent class object by doing it in this manner. If you want to send dog, you can just have a reference type as animal, but point to a dog object and send this as a parameter to this method. And inside this method, we do narrowing, a valid narrowing that doesn't result in class cast exception. And we do anything that we wanted to do inside this method. Hope that makes sense. See you in my next video.
Alright, in this video I'm going to talk about typecasting in Java. We had already talked about typecasting for primitive data types. Let me just go through it once again a little bit. Let's say you have byte b equals 10, and we're trying to assign this b variable to int type. What's happening here is Java is automatically converting this byte value to int. This is automatic type conversion and is done by Java. But in case if you want to do it the other way, for example, if you have int I equals some number and you have byte b equals I, this is going to result in compilation error. That's because we're trying to convert a higher type value with higher range to lower type value, byte. Java does not typecast this implicitly. We programmers have to typecast this explicitly. So how do we do that? We're just going to typecast it to byte. Now since the range of byte is way less than this number, by doing this operation is going to result in some loss of data. We had discussed about how loss of data happens in the beginning of this chapter. But let's say we have int I equals 10 and byte b equals byte of I. Now in this case there is not going to be any loss of data. That's because number 10 falls in within the range of what byte supports. So in this case what we're achieving is widening. We're trying to convert a lower type data type to a higher type data type, and Java implicitly does typecasting. But what we're doing here is narrowing. We're trying to convert a higher type data type to a lower type data type. Hence it's narrowing. You can actually think of it in this manner. Let's say you have a box which is, say, int, and you have another box which is a smaller box which is of byte. You can easily insert this box inside the int box. But if you try to do it the other way, I mean trying to put in int inside the byte, then we can't, it's just not possible. There's definitely going to be some loss of material. Hope that's clear. In Java, typecasting is not only applicable for primitive data types, but also non-primitive data types. Let's take our example of animal. We have living being class, and we have animal class which inherits or which extends living being, and we also have a dog class which will extend animal. As we're going up the hierarchy, we're getting more generic, and as we go down, we're getting more specific. Now if you observe, every dog is an animal. It has an easy relationship, and every animal is a kind of living being, but not the other way. Every living being doesn't necessarily have to be an animal, and every animal doesn't necessarily have to be a dog. So when we're trying to convert dog to animal, it is called widening. It's acceptable. And Java does type conversion on its own. But when you're trying to convert animal to dog, it's narrowing. And just as for primitive data types, narrowing typecasting needs to be done explicitly. Let me just explain you with a couple of lines of code. Let's say you have a dog class object. You have a reference type of animal, and you're assigning this object to animal. Java does implicit typecasting in this case because it's, as I've explained, every dog can be an animal. But let's say if you're trying to do this, you got animal equals new animal, and then you're trying to assign it to a dog reference type. But for this, you need to typecast this explicitly by doing dog the animal object. What this is going to result in is class cast exception, because ultimately you're trying to convert animal class to dog class, and Java is not aware of your class and objects to deal with the loss of data, so it's just going to simply throw us an error saying class cannot be converted, it cannot be casted. So it's just going to throw us an error saying this conversion cannot happen. I just cannot convert a higher type data type to a lower type data type. So when do we ever be able to use explicit typecasting without an error? Is when you do this. You have animal reference type, and instead of creating an object or pointing to an object of animal, you're going to point it to a dog object. And this is allowed obviously because every dog can be an animal. Now you have a dog reference type, and you're going to assign animal object to this. Again, this requires explicit typecasting. Java does not do implicit typecasting. So what you're going to do is, I want to convert A to dog object. Now if you run this program, this is not going to give us any runtime errors. That's because ultimately it's the same type. Why do you ever want to do this? Is to achieve one of the major features of object-oriented programming language, which is polymorphism. We're going to talk about runtime polymorphism in this chapter anyways. Alright. In some cases, Java does throw compile time errors when we're trying to convert two incompatible types. For example, we have animal class and we have dog and cat. And dog and cat are inheriting some properties from animal class. Now in this case, if you have a dog class object, new dog, if you have cat or cat reference type, and you're trying to assign this object to this cat reference type, this is not possible even if you do explicit typecasting, because as a rule of thumb, just remember that when you're trying to do a typecasting, or if you're expecting an automatic typecasting, then both the data types must fall in the same hierarchy. For example, you can have living being here. If you're trying to do typecasting within this line, then it's allowed. You can't just do typecasting of these two independent types. And that perfectly makes sense, because dog and cat, even in the real world, are two distinct objects. This is the beauty of object-oriented programming language. You can always correlate all the concepts of object-oriented programming language with the real-world objects in the real world. Now let's go to our program and take a look at all these examples. So here we are. We have an object of living being, an object of animal, dog, and cat. Now I'm going to uncomment these lines one by one, and I want you to make a guess on the expected result. Let's uncomment this line. Is this valid? Yes, it is valid. That's because we have an animal reference type and we're assigning an animal object. So animal and animal, they both are of same type, no worries. Well and good. Now how about this? Animal A1 equals dog object. Dog is a lower type data type, animal is higher type. So this is widening, and Java does implicit typecasting, and hence this is allowed. No worries. How about this? This is essentially the same statement, except we created a new object right here, right in this line itself. Alright. How about this? Living being, and again dog object. Living being is a grandparent of dog class, and hence we allow this conversion to happen, and Java does implicit typecasting. How about this? What we're trying to do here is narrowing. We're trying to convert higher type data type to a lower type data type. So this is not possible. This is going to give us a compile time error, and we're expected to explicitly typecast this object to dog, to the destination type. In this case it's dog. Same is the case with this instruction. How about this? Cat and dog are two different data types, and Java does not support typecasting either implicitly or explicitly for objects of two distinct types. How about this? Again, it's two distinct types, cat and dog. Even if you do explicit typecasting, Java does not allow us to do so. It will throw a compile time error. This statement, it is possible. We're trying to explicitly typecast animal object to dog, but do take a note that this is actual animal object to where this reference type is pointing to, and we're trying to convert this object to a more specific data type, dog. This looks as though it's not causing any problem, but when we run this program, it is going to cause a problem. Let's save the file and try to run the program and see the error. We got class cast exception. Ignore all these statements because this is from our previous programs. We're just calling the constructors. What we're interested in is this statement, class cast exception. Animal cannot be cast to dog. Makes sense. We'll talk about exceptions in our future videos for sure. Let's comment. Let's uncomment this line and this line. Now what's happening here? In this case, we are trying to achieve narrowing by trying to convert animal to dog, but take a note that this animal reference type is ultimately pointing to a dog object. So this is not going to yield any errors. Let's try to run the program, and there you go. No errors or whatsoever. Let's save the file. How about this and this? Object is a class that is parent of each and every class in your project. If you don't define an extends keyword to extend the behavior of your class, implicitly Java will extend this class object. So all these three instructions are perfectly valid. We're doing widening. Great. The real usage of typecasting will be explained when we talk about runtime polymorphism. See you in my next video. In this video, we're going to talk about final keyword for methods and classes. Take a look at this example. Let's say we have this method which will just print how many legs does a
does the dog have? I have another class which is German Shepherd class, and it extends the dog class. What this class does is it has overridden the behavior of the dog class for the method number of legs, and it has its own instructions. In this case, it's printing a wrong message. German Shepherd have 2 legs. This could be accidental or intentional. This is certainly not right, because every dog will have 4 legs and it can never be changed. In case if I want somebody to use my class, extend my class dog, but I don't want them to override this method. For that, I just have to use the keyword final. Now we get an error here saying remove final modifier of dog number of legs, but we don't want to. We just want to get rid of this method instead. Hope that makes sense. And if you don't want the class to be extended at all, then you would mark the class as final. Again, we get an error here because the type German Shepherd cannot subclass the final class dog. So we can't extend that class anymore. When you have a class as final, there's no point or there's no meaning in having final methods. That's because anyways we cannot extend this class, so there is no possibility of overriding anyways. So far throughout our course, we have used final class. Can you guess what class it is? It's a string class. That's because, as we know, string is immutable. It is immutable because the string class is final. Alright, this might sound confusing a little bit, but we'll understand it at a later point of time. But for now, if you have a class as final, then you can never extend it. And as a rule of thumb, whenever you write a class, keep inheritance in your mind. Design the class in such a way it will fit for inheritance. In case if you're not thinking about inheritance while writing a class, then just mark that class as final. Hope that makes sense. Now another thing which I want to talk about is static binding and dynamic binding. Binding refers to a bond between method call and the method definition. This is the method call, and the method definition is this. During the compile time itself, the compiler knows which method to call. So this is called static binding. This is also called early binding. Coming to dynamic binding, the binding between the method call and the method definition does not happen during the compile time. That's called dynamic binding or late binding. And this is a perfect example for that. Hope that makes sense. If you're ever calling a method which is static or final or private, then there is no scope for dynamic binding. That's because a private method can only be called from within that class, and hence there is no overriding or polymorphism concept. Hence there is no dynamic binding or runtime polymorphism for that method. If you're talking about final method, then that means that method can never be overridden, and hence again there is no polymorphism here. So it has to be a static binding. And if the method is static, then it's not even associated with the object. The method is associated with the class, and the method gets executed when the class first loads. Again, even in this case, there is no dynamic binding. See you in my next video.
In this video, I'm going to talk about abstract classes and abstract methods. A class is said to be abstract if it has at least one abstract method. But what is an abstract method? Take a look at this example. We have an animal class, and inside that we have this method shout. If you observe, there is no specific sound that every animal makes. Dog will shout like a dog, maybe bow bow, and cat will shout like a cat, maybe purr, something of that sort. So it's not really appropriate to have this method in the animal class. One solution for this is to override this method and give dog its own behavior. For example, I just copy this
paste it over here. With the override annotation, I'm going to say bow bow. Great, but this doesn't really solve the problem. The reason is, let's say we have another animal class, maybe say pig. It's going to shout differently. And let's say I forgot to override this method shout in the pig class. Now when I create an object of pig class and call this method shout, it's going to result in calling this method and the behavior is inappropriate. Pig supposed to shout like maybe oink, oink, but it's going to shout differently like an animal, which is completely inappropriate. So what is the solution for this? We use abstract methods. An abstract method does not have any implementation at all. That means we just simply get rid of this. There should be nothing inside this. And since there is nothing, there is no meaning of this curly braces. We delete that as well. But every statement ends with a semicolon, and we end with a semicolon. The reason why we have error here is we haven't yet marked this method as abstract. And when we have at least one method which is of abstract, we're going to have to take care of marking that class as abstract as well. When we have a class as abstract, there are two things that's going to happen. One is whichever class is extending an abstract class is forced to give implementation for all the abstract methods. So I'll have to copy this and actually we do already have that method implemented in here, and there is no purpose of override annotation here because we are now forced to give implementation. But in cat class we don't have the implementation for the abstract method shout, so that's what we're going to do. Copy this, and shout like a cat, whatever. We have another error here. Let's see what it is. Alright, we get rid of this word abstract. Well and good. Now the second thing that's going to happen when you mark the class as abstract is nobody can ever create an instance of this class. And that makes sense because there is no implementation for this method. For example, I create an object of this class animal and I call this method. Where are the statements? Where is the implementation? What would be the behavior? There's nothing. A class which is incomplete. So that's why we have errors in here. We can't have an object of that class. But what we can do is this. We can have an object of its child classes and have the reference type as animal. By doing so, you can always call the methods inside the animal class as well anyways. Hope that makes sense. Now just in case if you don't implement all the methods, for example I get rid of this in here, then you're going to have to mark this class as abstract too. By doing so, whichever class is extending the dog class will have to give the implementation for this abstract method. So inside our German Shepherd class, we're gonna have that implementation. But looks like we have an error here. Can you guess what this error is? Alright, the error is for this. We can't have a class which is both final and abstract. Now can you guess the reason? That's because when we make a class as final, then we cannot extend this class. And without extending, we cannot give implementation for abstract methods. So it has to be either one of these. I'll get rid of the final in here. And let's get rid of this object as well.
because that's going to cause compile time errors. Now since dog is also an abstract class, we can't create an object. Let's get rid of that keyword. And let's put back that method. Alright. Now you would definitely have errors in here as well, since we've made the animal class as abstract. So let me just comment that out. And I guess you are capable enough to deal with these errors that are going to come inside this class. Alright. Earlier we had talked about access specifiers, but we haven't yet talked about the protected access specifier. This is the right time for that. When we have a member as protected, then that member is accessible in all the classes in that package, as well as the subclasses in other packages. That's exactly what I'm demonstrating here. For this purpose, I have created a couple of packages. In one package, we have the animal class, which is this. In this animal class, we have a constructor, which is of protected. We have a member variable, which is protected, and we have a member function or member method, which is protected as well. We can't have a class as protected. So all these members should be visible in all the classes in the same package. So this is a class in the same package called cow, and I'm able to create an object of animal class to access its member methods. And this is working. Let's run the program. There you go. It called the constructor first and then the method. Now we have another class inside another package with the same name, cow. In this class we have the public static void main method. We have this method just to be able to call this method in here, some math, so that we can demonstrate what is happening. This cow class extended the animal class in here by importing it, and as expected, the cow class constructor can call the superclass constructor because it is protected and is visible. Similarly, we can call the method inside the animal class, and also we can access the variable. Let's run the program. There you have it. Let's say we want to get rid of this, then we get errors, obviously. Now you might wonder why this is not showing an error. By default, this has actually extended the object class. So this instruction would call object class constructor. Let's undo those changes. Now let's see if we can create an object of this class just as we did here. In the main method, we cannot because there is no visibility of this. Even the constructor is protected. We can't instantiate like this. Let's save the file. And that's it. See you in my next video. Garbage collection is a process that happens periodically on the heap memory. What this process does is it will scan the entire heap memory and it collects all the objects that does not have any references. Ultimately, all these collected objects would get destroyed out of the memory so that the memory will get freed for new objects to get created. So when do we say an object does not have its reference? There are primarily 3 cases where this can happen. Take a look at this program. In the first line we have the dog object. Now D1 is made to null. That means this reference type is not pointing to any object in the heap memory. Now this object does not have any references, so it qualifies for garbage collection. Similarly here we have a couple of objects of class dog. D2 is now pointing to the D3 object, which is this. So this object in here will qualify for garbage collection. And in here it's pretty straightforward.
we don't even have the reference type. So it's just plain object, virtually useless. So even this object will qualify for garbage collection. Another thing I want to talk about is the finalize method. Finalize method is method inside the class called object. And as I've mentioned, object class is the parent of any class in your project. Take a look at this class. The dog class is extending animal. Let's press Ctrl and then click this to open the file. Now animal is extending living being. Now living being is actually extending the object class implicitly. Even if you don't give the statement, it is doing the same. You give it or not give it, the result is same. So now going back, before the object gets garbage collected, the Java virtual machine will run the finalize method of that object. In this case, it's dog. So why do we have the finalize method? Is to free up any open files or database connections associated with that object. We don't want to keep the connections open, etc. We're going to talk about streams, database connections, all such sort of things in future videos. But for now, just think of it this way, like we should not be keeping any OpenDB connection when we are destroying the associated object. That will be taken care by the JVM itself. But in case if you wanted to override that method, you can do that. For example, you can say, I don't want JVM to perform its own action. I want to do something with the finalize method when my object is getting destroyed. In that case, you can always override that method like so. So we have overridden the finalize method from the object class, and we're just printing the statement. Every time the object gets garbage collected, before that happens, JVM will call the finalize method automatically. Now I said garbage collection is a process that happens periodically. That also means that it is not guaranteed. So if I run this program, there is no guarantee that the garbage collection process kicks in. In order to kickstart the garbage collection process explicitly, you're going to use the method inside the system class, which is system.gc. GC stands for garbage collection. If we run this program, then every time an object is getting garbage collected, it's going to call that object's finalize method. In this case, we have overridden that method and printing the statement. So ideally, since we're losing references for 3 objects here, we should be seeing this message 3 times. Let's run the program. There you go.
Alright, in this video I'm going to go a little bit deeper and make you understand this statement, system.out.println. Especially we're going to give attention to one of the methods inside the object class, which is toString method. In here I have a couple of lines of code. In the first line I'm just creating an object of string class, and I'm passing that object as an argument to the println method. But there is a lot going on behind the scenes. To analyze what's going on in this method println, I recommend you to go to this website, grepcode.com. In here, search for the class that you're interested to look at. I type in system, and then under this section, OpenJDK, click this link. This website will allow us to analyze the source code of the class files that you find in the JDK. Inside the system class, we must be having a static member variable, which is with the name out, and that's how we're able to call that member using the class name. So this is what it is. We have a static variable out, which is actually an instance of the printstream class. Let's click that, and inside this printstream class we must be having the println method. As you can see, we have many println methods. So what we are trying to achieve here is overloading. We had already taken a look at the example of overloading in our previous examples. Now out of these methods, when we are passing string as an argument, where would the controller go? Can you make a guess? It's obviously this. because in here we're taking in string as an argument. Let's go inside it. Inside that method we're calling a couple of other methods. One is print, the other is the new line. We'll talk about the print method. The new line method in here will just have some instructions which will help in printing a new line on the console. Essentially this is as good as pressing a written or enter on your keyboard. But what we're interested more is this method, print. We're calling this print method and we're passing the exact same argument, which is string. Let's see what happens inside the print method. Inside the print method, we're just checking to see if the object is null. If not, then we're going to go ahead and call this method write. Write is the method which does all the magic. That's where we see the code that will ultimately print the string onto the console. As simple as that. Now let's go back to our code. But what if we send an object to this println method? Let's take an example of integer object. You can think of integer object as the object representation of primitive type int with some extra capabilities. We're going to go and understand these classes at a later point of time when we talk about the wrapper classes. But in here, if you run this program, it's just going to print the value 1000. Here it is. Now let's dig in and understand what's going on behind the scenes for this instruction. Again, we're in the print stream class. Inside this, can you make a guess on where the control would go if you're sending the integer object as an argument to the println method? It's going to be this. Let's dig in. Inside this method, we have the same exact methods what we had inside the println method when we pass string as an argument. But before we call these methods, we're trying to do something in here. We're trying to convert the integer type to a string type. How is this done? Let's go inside this method. We're going to call the value of method which is inside the string class, and this value of method is going to take in this argument, the object, which in this case is integer type object. And this is possible because object class is ultimate parent of each and every class in Java. And integer class is no exception. Since integer is of subtype of object class, we can comfortably send that as an argument to this value of method. Now let's see what's happening inside this value of method. It's a pretty simple method. It just checks to see if the object is null. If it is null, we're just going to see this result, null, as a string in the output. For example, let's just go back to our code and let me just demonstrate the same. For example, if you make this null and save the file, and if I run it, it's going to show the null. Essentially what has just happened is, let's undo those changes. This method returned null. However, if the object is not null, it's going to call the toString method of that object. And currently this object is of type integer object. Now this gets a little tricky in here. We have overridden the method toString. The object class has the toString method, but the integer, which is subclass of the object class, has overridden the method toString. When we do object.toString, the control will go inside the toString method inside the integer class. Let's dig in. What we need to search for is integer. Again, we click this link. This integer class has the toString method. Here it is, which is overridden from the parent class object. And here we're just having one line of code in which we are calling the value of method inside the string class. But can you make a guess on what would be the value here? If you go back to our code, we have passed this value to the constructor of the integer class, and that constructor has initialized the value to whatever the value that you sent. In this case it's 1000. Let's go back. So we're passing the primitive type int. By the way, this is the value is of type is primitive int, and we're passing that as an argument to the value of the string class. Inside this, we're again calling the integer class toString method with a couple of arguments. So this toString method is going to call the toString method with 2 arguments inside the integer class. This is where the magic happens. Basically, this is where the conversion of the int to string will take place. So we're returning the string object from this method, which then goes back to the calling method, the value of, and ultimately we're returning the string object, only after which we're going to call these 2 methods. And we have already talked about these 2 methods. Hope that makes sense. So in short, this statement has converted the integer type object to a string object, and then we can comfortably pass that string as an argument to the print method, where the actual printing of the string on the console will happen. Let's go back. But what if we're sending a primitive type int? For example, int I equals 10, sys out, control space, and you print the value I. This println method is going to call this method, and it's pretty simple. It's going to call the print method, and again the write method inside this is going to take in only the string object as an argument. So before we pass the argument, we're going to convert this primitive type int to this string object. And how do we do that? Is we send the int primitive type as an argument to the value of method inside the string class. Again, we're calling the toString method inside the integer class with a couple of arguments. And ultimately we're sending back the string object, which comes back here, and we send that as an argument to the write method. And obviously these are just set of instructions that will print the string onto the console. So there is a lot going on behind the scenes, and everything is abstracted for your convenience. Isn't that amazing? Now let's take a look at something really interesting. Let's say I have created an object of my own class, cat object, new sysout cat object. Can you make a guess on the result of this statement? Let's run this program. You would see some random text. So what has actually happened here? Let's take a look. When we send our own object, it's going to call this method println, which takes in the object. And obviously before it does this job of printing onto the console, we need to somehow convert that object to type string, which we then pass as an argument to the print method. So let's dig inside this value of method. And obviously we didn't send the null, so the control would get to this point, and this would call the toString method inside that object. Now if you take a look inside our cat class, we don't have the toString method. So this is going to result in calling the toString method inside the object class. Now what does the toString method inside the object class do? It's going to simply print the hash code of the object. Now what is a hash code? We're going to talk about it when we talk about collections. You can think of hash code as a unique identifier for an object, but it doesn't necessarily have to be unique. We'll talk about it at a later point of time. Let's go back to our program and run this program. So the way the hash code is represented is we have the name of the class, the @ symbol, and then the hexadecimal representation of the memory location of that object. In this case, it's a cat object, and that's what it is printing. Obviously, from the user perspective, this doesn't really help. So, can you make a guess on how do we handle this situation? We will override that method toString. Let's make sure we are indeed overriding this method. We're good. Now if you run this program, due to the polymorphic behavior, it's going to call the toString method of the cat object. Now this makes sense. User can understand it is indeed a cat object. Pretty interesting, but it might take a while to digest. If you have any confusion, just go through this video a couple of more times. It's okay to go through the videos again and again until you are pretty comfortable with the concepts. See you in my next video. In this video, we're going to talk about enum type in Java. Let us assume that you have to write a navigation code for your robot. This is how the code would look like. You'll have a method that will take in a string as an argument, and we're going to pass that string to this switch statement, and based on the argument it's going to choose the direction. For example, if I pass in east, then these two lines will get executed. Essentially, we're going to let our robot turn towards east. Similarly, if we pass south, the robot is going to turn towards the south. If none of these cases are met, then we're going to just say the robot to don't turn at all. In here, I have the object of the same class, so that I could call this method turn and pass in some argument. I'm passing in east as an argument, and I would expect the controller to get inside this section of code, and I would like to see this message printed on the console. But let's see what is going to happen. Don't turn. It has entered inside the default block. The reason is the case. Here we have the lowercase e, and whereas we're passing in the uppercase e. This is clearly a problem. We have left some room for mistakes. Even though I'm intended to enter east, I ended up getting inside the default block, which is not my intention. So you have to take special care in giving the exact case name what you have in here. This is very difficult. Let's say you took a .class file from someone else and it has a similar method, then how would you guess which argument to pass? It's a nightmare. It's just you have to go in trial and error approach until you get successful. This is definitely not feasible. We need to address this problem. We also have another problem in here. You could create, or somebody else can create, a case which is completely unrelated to navigation or direction, whatever. You can just have some random case in here. Obviously, there is no such direction as SDF, 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 etc. So this is another issue we have. How do we address this problem? One of this problem can be partially addressed with the use of a class with some fixed constants. Like we have 4 variables in here: east, west, south, and north. And as you know, we follow a good naming convention for constants is to have all capital letters. It's just a good naming convention. We can make a variable constant when we have the static final keywords and fixed before that variable, and we have the associated values. Now instead of sending a string, I'm just going to send one of these variables inside the direction constant dot. Now we only have 4 options. We can only send one of these 4 variables. This is going to run smoothly, but still we didn't fix the problem entirely. Still, there is a possibility to send some random text. How do we fix this problem? The answer is enum type in Java. Just as class, a user-defined data type, enum is also a user-defined data type, but the difference is enum is specially tuned for this purpose, to address these kind of problems. Let's see how we can create a enum type. Right-click on your project, right-click on your package, go to New, and then choose enum. Give it some name. I'd like to give the name as direction, and click Finish. We have the direction enum in here, and we can just have some variables. We can have north, east, south, west. We end with a semicolon. Now, how is this enum type solving our problems? Let's go back. In here, instead of sending string as an argument, I'm going to send the enum type. I'll do Control C and Control V. Now, doing so, we are forced to fix those two problems. In here, I cannot have any case that is not part of this enum type. So there are only 4 possible values. Hence, there are only 4 possible cases I can have. So it has to be east. I cannot have any other name here, including the case. You can't have a small or lowercase t. It has to be capital, whatever you have it in here. Similarly, west, south, north. One of the problem we had is now addressed. The other problem is leaving the room for sending any random string. And in here, we have no other option but to use one of the values defined inside the enum type, direction dot east. Now this has fixed both of our problems. Now let's understand a little bit about the enum type. In here, we're able to access the variables inside the enum class just by using the class name. What this also tells us is that the east in here is a static variable, and that's exactly what it is. If you were to write the class representation of this enum, then it would look something like this. We're going to have public static final, and then north, similarly for rest of the variables, and we're going to have a static block that will do something. We'll get what these instructions are doing in here in a while. Let's go back. Now let me just talk about something really interesting. In here, let's just comment out this code. I'm just going to use a simple statement, sysout, and if I do direction constants, the class file that we have, .east, what is this going to print? Obviously, this value east, right? But what if we use an enum constant? Can you guess the output? It's going to print exact same variable name. So what's happening behind the scenes? In here, when you access this variable, it's going to straight away give back a string. But whereas when it comes to enum, there's a lot going on behind the scenes. Let's dig in. When we have the statement direction.east, it's actually returning an object, and we are calling the toString method of that object. Let me explain you what I mean. If you take a look at the class representation of this enum, in here we obviously have a final static variable, and the value of that variable is not a string, is just going to be the same object. We created a new object of the same class, and we're calling constructor with a couple of parameters in here. What are those parameters? One is the exact same word what we have here, the variable name, and the other is ordinal. We'll talk about ordinal pretty soon. So this is going to result in calling this constructor with a couple of arguments, and inside this constructor we use the word super to call the superclass constructor. Now what is the superclass of this enum type? By default, implicitly, any enum type is going to extend a class called enum, and inside this class, if you go inside the source code of it, let's go to its source code. Again, you can use the website grepcode.com to find the enum class, which is part of java.lang, and in here we must be having the constructor, which takes in a couple of parameters. Here we have it. This constructor is of protected, and this constructor is just setting the initial state for a couple of variables. One is the name and the ordinal. Now do take a note of this. We're going to see how we're going to make use of this name in a moment. Let's go back. Now we had talked about the toString method in our previous video. Same thing is going to happen here. We're going to pass this enum type as an argument to the println method. Ultimately, it's going to result in calling the toString method of the same object, which in this case would be the enum class. So in here we have the toString method, and it's just simply returning the name. Now we know what this name is, the exact same name as a variable, and that's why we're able to see this name in here instead of some kind of a value. Hope that is clear. Now besides just setting the name, we had also set something called ordinal. What is an ordinal? You can think of ordinal as the position of a particular variable starting with 0. The ordinal of north is 0. The ordinal of east is 1. South 2, west 3. And that's exactly what we are setting. 0, 1, 2, 3. In the same order we define inside the enum type. In order to get the ordinal value, we can call the method ordinal. I would expect the result to be 1. Let's run this. When are we going to use this ordinal is something we'll talk later when we talk about enum maps, etc. Alright, I guess that's enough for this video. We'll talk more on enum in our next video. Another method which I would like to talk about is the values method. Let's look at what it is. The values method is essentially going to return list of all the variables we have inside the enum. So that's going to let us loop through all these variables and do something with them. Let me just explain you what I just meant. We have for, we can use a for loop. Int I equals 0. I is less than direction dot. See, we have the values method dot length and then I plus plus sysout and direction dot values of I. We have all these. Of course we can get rid of this statement. So now we have all these list of variables in the same order how we defined inside the enum class. Now this is a very bad approach of looping through all these enum constants. There's a better way of doing that. We can use for each construct for this purpose, but we'll talk about it at a later point of time. For now, you can just simply follow the for loop. Sometimes you might want to set some variables associated with each of these constants. For example, when it comes to direction, we can associate it with the degree. For example, say for north, it's going to be 0 degrees. For east, it's going to be 90 degrees. And for south, it's 180. And for west, it is 270 degrees. The way we deal with this is we're going to have our own constructor defined to set a state. Let me just explain you what I meant. We can have, for example, 0 for north, 90 for east, 180 for south, 270 for west. Now obviously we have an error here. Essentially we're passing in an argument to the constructor of the direction object. If you go back and look at the source code, the class representation of this enum type, in here we're passing a couple of arguments by default. In addition to that, now we're having a third argument. So the constructor direction int is undefined. Now obviously we have an error here because what we're essentially doing in here is we're passing in an argument of type int to the constructor of the same enum type. But we don't have a constructor that takes in this argument, so we'll have to define one. We're going to have a variable int, let's call it degree, and we are also going to have a constructor which is private. We cannot have a public constructor inside the enum type. We'll talk about it pretty soon. Direction int d degree equals d. All well and good. The only thing that is left is to have a getter and setter for this variable. Source code, generate getters and setters, choose a variable and click OK. Now that's the beauty of IDE. It will provide a lot of convenience for the programmer. Let's make this private. Now these values are set. In order to access them, you can just now say dot get degree. Let's run the program. 0, 90, 180 and 270. And you can do something with this. So that's the beauty of the enum type in Java. Unlike enum type in other programming languages, Java enum will give you more flexibility. It will allow you to have methods, variables, constructors, etc. So that's a lot of flexibility provided apart from just set of fixed constants. Talking about methods inside the enum type, we can have methods. We can also have abstract methods, but I'll talk about it at a later point of time. For now, let's just quickly point out some of the important points to remember for enum. If you look at the class representation of enum, by default it is extending the class enum. What this also means is you cannot have another class extending, because in Java we don't support multiple inheritance. So if you say extends something, then it's going to throw us a compile time error because we have already extended the enum class. Hope that makes sense. Also do take a note that all the enum types are implicitly final, which also means that we cannot extend the enum type. Now you may have a question, if we have abstract method inside the enum class, how are we going to override without ever having a child class of this enum type? We're going to preserve that topic for a later time. Another point to remember, as I've already mentioned before, we cannot have a constructor that is of public. If I try to define one, it's going to throw a compile time error. Illegal modifier for enum constructor, only private is permitted. And due to that reason, we cannot have an object created using the new operator. In our code, we can't use the new keyword for enum type. For example, I can't do this. Let's undo. In some cases, you might just want to use the enum constant in a particular class. You don't want it to be accessible across the project. In that case, you can always have the enum. You can just copy this code, Control C, and you can just have it on top of this class. That way this is accessible within this class alone, not the entire project. Let me change the name, something like that. It's going to, now we can just use this just as before. Hope that makes sense. Let's undo all those changes. Alright, that's it on the enum type for now. Okay, one more thing. We've talked about the values method, but do you know where is this coming from? You may guess that it might be coming from the enum class, which is inside the lang package, java.lang, but that's not true. This values method is not part of any class. The source code of this values method will be generated by the compiler, because the source code inside the values method is dependent on the values that you set in here. So it is dynamically generated by the compiler. This is an exception case. Normally compiler wouldn't take care of putting the source code, etc. It's just going to do a conversion from your source code to a language that the Java virtual machine can understand. Nothing more than that. But this is an exception case. I think it's worth noting that point. See you in my next video. In this video, we're going to talk about interfaces. If you ask somebody what is an interface, they're going to say an interface is a collection of abstract methods and constants, which is right, but how does it make sense? And if you ask them what is the purpose of interfaces, then they're going to say the purpose of interfaces is to solve the problem of multiple inheritance, which is also true, but that's not it. Interfaces are not introduced to solve the problem of multiple inheritance. There's a different purpose to it. We're going to take a look at how it solves the problem of multiple inheritance, but let us try to understand the actual intent of introducing the interfaces. Take a look at this. Let's say there are three software companies, S1, S2, and S3, and they all specialize in providing the source code for robots. Let's assume they have class files, say R1, R2, and R3. Inside these class files, they write the source code for the robot. So it can have methods like move, and inside this method it will have some instructions to instruct the robot to move. Similarly, there can be stop method, etc. And here this can have walk method and halt method, and here it can have again walk and pause, so on and so forth. If you observe, the task performed by all these methods, stop, halt, and pause, is essentially to stop the robot. The goal of this method is ultimately the same, is to stop the robot. Keeping that in mind, let's assume that you have a robot, and since you're not such a big techie, you can't write a code similar to this by yourself. All you know is basics of Java. You know how to create an object of a class and make use of the methods inside that class. Nothing more than that. So since your knowledge on writing the code is pretty limited, what you're going to do is you're going to purchase the code from company S1, essentially the class file, the bytecode of the source code, and what you're going to do is you're going to create an object of this class R1, a new R1, and make use of all the methods inside it, object.move and object.stop, etc. Now we have a very serious problem here. Can you guess what it is? Let's assume that you realized that the code provided by company S2 is more relevant for your purpose, and you thought the code provided by company S2 is more efficient and is performing the task faster than the source code provided by company S1. So you just wanted to switch to this source code. So what you're going to do is, instead of R1, you're going to say R2, which is a class file from this company. But how do we make changes in here? For example, instead of the method move, you're going to have to use the method walk. Instead of the method stop, you're going to have to use the method halt. So for this purpose, you need to go look at the documentation and try to understand what they're doing. You need to try to understand what their source code is doing to be able to make changes to your code. And we're just talking about a single class file, but in reality it would be an entire project. It's pretty time consuming and a messy process to make changes everywhere. Now in future, let's say you wanted to move to some other vendor, maybe S3 company, then you will end up doing the same. It's a pretty painstaking process. How do we get rid of this problem? The solution is interfaces. You can think of an interface as an abstract class, except the difference is interfaces will not have methods with behavior. Of course, with the introduction of default methods in Java 1.8, you can have some behavior written. We'll talk about it at a later point of time, but for now assume that an interface can only have abstract methods and constants. So the syntax of defining an interface would be something like this. We're going to take a look at the example in our next video, but just for the sake of this example, let's see the syntax. For abstract class, you're going to have to say class abstract class name, and you will have the signatures of the method. But coming to interface, instead of class, you're going to say interface, and you get rid of this word abstract because it is implicitly assumed that it is abstract. Let's call this I1. I stands for interface, and all you're going to have is signatures of these methods, and you don't have to explicitly mark these as abstract because the Java compiler does that implicitly. Whatever the methods you have in here will be marked as abstract methods, and whatever the variable that you have in here, say int x equals 10 or whatever, by default compiler will assume them to be of final static. You can't have a variable that is not of final static. Essentially you're just going to have only the constants in an interface. But coming back to our example, how does an interface solve the problem? All these companies, S1, S2, S3, they're going to have a small meeting and they're going to discuss about their problems. They found out that customers are finding it difficult to move to a different vendor. The guy from S1 says, there's a customer who is interested in taking our code, but he's not taking our code because there's a lot of tasks involved in making changes. Same is the problem with other companies as well. So all these three companies will come to an agreement that whatever the class files that we write will have the same signature for their methods. And the way of standardizing that process is through an interface. So all these three companies will discuss and figure out an interface for a typical robot. It will have all the method signatures like maybe walk, run, navigate, whatever. Whatever are the typical behavior of a robot, they will decide and put it inside this interface. And all these class files in here are going to implement this interface. So instead of saying extends, let's call this interface I1. So instead of saying extends I1, we're going to use the keyword called implements. Again, we're going to take a look at this example in our next video. Implement I1, and everybody is going to do the same. Implement I1, and by doing so, all these class files are forced. They're forced
to give some behavior for all the methods inside that interface. Now, how is this solving the problem of the customer? Let me explain you. The customer, I mean you in this example, instead of saying R2, he's going to create a reference type of this interface, I1. So instead of R2, he's going to say I1. And this reference type of interface will point to, say, this class object R2. Now, by doing so, he can only access the methods that are defined inside this interface. He can't access the method move anymore. He's going to access the method walk, whatever is there in the interface. Now, in future, if you decide to move to a different vendor, all you have to do is to change the object to which this reference type is pointing to, say R3, something like this. Now, you don't have to make changes anywhere else in the code. The reason is, since everybody inherited or implemented this interface and you use that interface as the reference type, the methods are going to remain same for all the vendors. Isn't that amazing? So from your perspective, by using an interface, you have the flexibility to switch to different vendor as and when required. At the same time, there is improvement in the maintainability of the code and the time it takes to make changes to your code. Also, if you're switching to a different vendor, you don't need to know the internals of their code, and you don't need to understand what their code is doing. For example, without the interfaces, instead of stop method, you'll have to figure out what your new vendor is using and make changes here. But with the interfaces, no matter which vendor you use, you're going to have the same method. So essentially, all these vendors will expose this interface and make it public to everyone. And people like you will look at this interface. They don't look at source code. So this is kind of like an abstraction mechanism, which is also one of the major features of object-oriented programming language. And also these vendors will keep this source code proprietary. They don't want to expose it and make it public. So, but still they can just expose only the limited details like the method signatures by exposing the interface. On the other hand, the benefits that the companies like S1, S2, S3 will have is again the flexibility that they're offering to their customers to switch to a different vendor. In a way, all these companies are forced to implement this interface. The reason is, only if the company implements this interface will the customers like you prefer their code. And also another benefit is, let's say there is no interface, and if they make changes to this method definition, then whoever or their clients, they all end up getting compilation errors because now the signature changed. But with interfaces, there is no scope for change. It's going to remain the same thing forever. In fact, if you try to make changes to the signature of this method move, let's say, then you're going to have a compilation error. So there is no room for mistakes as well. So that's all what an interface is. We're going to take a look at some of the interesting examples going forward. Stay tuned. Let's take a quick example of interface. For that, we're going to create a new project, which is obviously a Java project. Let's name this project as Interface Project. As a good naming convention, we always start our project name with a capital letter, and every subsequent words will also start with a capital letter. Let's click Finish. Inside the project, we have a default package. It's not encouraged that we use the default package, so we're going to create a new package, which is Interface Package, whatever the name that you want to give. But make sure you follow a naming convention of camel case, wherein the first letter starts with a lowercase and all subsequent words will start with an uppercase. Click Finish. Right click on this package and we're going to be creating an interface. Let's call this interface Animal and click Finish. There you have it.
we have an interface. The next thing that we're going to do is right click on the project and create a new class. This class, I'm going to call it land animals. Basically the animals that live on land. Let's click finish. So we got land animals, and inside this animal interface I'm going to define a method which is going to be a breathe, something of that sort. Let's do Ctrl Shift F to give the proper indentation to the code. Now what we're going to do is we're going to use the keyword implements animal. Now by doing so, we are forced to give the implementation for all the methods inside this interface, and that's why we have this error in here. The type land animals must implement the inherited abstract method animal breathe. You can just resolve the error by clicking this. The Eclipse IDE will help us in doing so, and whatever that you want to do, you can do it over here. System.out.println. You're gonna say something, maybe breathing, whatever. And besides this, you can also have your own other methods. This is fairly a very simple example of using an interface. Let's take a look at another example. Let's consider something that falls in the subcategory of land animals. Let's say a frog. I'm going to copy this class. I select this class, I'll do Ctrl C, select the project, and I'll do Ctrl V. This will copy the class. Of course we need to give a different name, and that's why we got this prompt. I'm going to name this frog. And inside this class, I'm not going to implement animal. What I'm going to do is I'm going to change a little code in here. I'm going to make this class an interface. And of course, interface does not have an implementation, so we're gonna have to get rid of this, and we're gonna provide some kind of an abstract method. What is that one thing that every land animal does? Let's say jump. Just for the sake of example, I don't know if an elephant can jump, but just for the sake of example, let's assume so. Let's save the file. Can you guess why we have an error here? That's because when we use the keyword implements, we should provide the implementation for all the abstract methods. But in this case, this is an interface. An interface cannot provide implementation for its parent interface. So instead of using the keyword implements, you're going to have to use extends keyword. Just as class extends a class, an interface extends an interface. But every class can implement an interface. The reason is only if it is a class can it provide the implementation for all the abstract methods of an interface. So the keyword makes sense. Now if you observe, a frog is kind of a land animal, and at the same time a land animal is a kind of an animal. Our hierarchy is in right shape. Now what I'm going to do is I'm going to do implements land animal, and by doing so, not only should we provide the implementation for the jump method, but also for all the abstract methods inside the grandparent interface, which is in this case is animal. Hover your mouse over this error and click on this. There you have it. Breathing and jumping. This brings me to talk about one of the problems with the multiple inheritance or hybrid inheritance. Let's go to whiteboard and I'll try to explain it. So what is a multiple inheritance? Take a look at this example. We have an animal class, we have a land animal and a water animal, which will both inherit the properties of an animal. Now let's assume we have an animal which is neither completely water animal nor a land animal, which are called amphibians. A good example of an amphibian would be a frog. Now this will have the properties of both land animal and water animal. Now if you think there's one thing in common, one thing is common between a land animal and a water animal, which would be breathing. A water animal breathes in the water and a land animal will breathe in the air. But the frog is both. If we were to write a Java program, then we would have this method inside both these classes. And let's assume that Java supports multiple inheritance, just for the sake of example. By the way, what is multiple inheritance here? This part of this is multiple inheritance, wherein a class will try to extend more than one class. So in here, the frog class extends land animal and water animal. If you do it programmatically, we get a compile time error here. The reason is Java doesn't support multiple inheritance, and we'll see why. Let's say we're supporting multiple inheritance, and if I create an object of this class frog, so frog object equals new frog, and if I do object dot breathe, is it going to call the breathe method of a land animal or water animal? There's a confusion, right? This is the ambiguity. JVM cannot figure out which method to call at the runtime. So to avoid the confusion, Java designers decided to eliminate the multiple inheritance altogether. So in your program, you would get an error in this statement. You can't extend more than one class. This is also sometimes referred as the diamond problem, looking at this pattern which looks like a diamond. Hope that makes sense. Now people say that interfaces solve this problem of multiple inheritance, which is wrong. With interfaces, we eliminated the problem itself. We didn't solve the problem. So let's assume we have animal interface, a land animal interface, and a water animal interface. And let's say we have a frog class. A frog class can implement both land animal and water animal interface. And multiple inheritance with interfaces is possible in Java. Also, by the way, these two will implement the animal class. Now if we create an object of frog and do object.breathe, you will not get a conflict. That's very obvious because there is no implementation or behavior written in these classes. The behavior is defined or written inside the frog class. There are no two behaviors. It's just one behavior provided by the frog class itself. So there is no scope for ambiguity. Let's take a look at this example in our workbench. Let's go back. So let's create another class which could be a water animal. I'll just do Control C and Control V, and instead of land animal I'm going to be doing water animals. Say breathe. Let's have the same method declared inside the land animals as well. And in here, since we no longer have this method, we get an error. Let's save the file. You can implement both water animal and land animals interface by using comma, like so. Water. I'll do Control space to complete my statement. Let's save the file. And let's create a new class in here, which would be our main method. Just to be able to execute this method, let's right click, click new, and class interface example. I'm going to be needing this public static void main method. Let's click finish. what I'm going to do, as you would pretty much can expect, frog object, new frog object dot breathe. This is going to call the breathe method inside the frog, which is pretty obvious. You can also have the reference type as one of these two categories, land animals or water animals. Let's do it. Land animals object 2 equals new frog. Let's go to the end of the statement and copy this statement and paste it over here, and you see no difference in the output. Let's run the program. There you go. These are the bare minimum examples of interfaces. We haven't yet walked into the mainstream yet. When we talk about collection framework, we're going to be exclusively talking about some of the major features introduced in Java 1.8. They're going to be very interesting topics, and we'll get there pretty soon. But for now, let's just keep focused and stay tuned. See you in my next video.
In this video, we're going to be talking about default methods. Going back to our robot example, let's say we have this interface with all these abstract methods: walk, navigate, talk, etc. The problem with interfaces is it doesn't move along with the trend. For example, let's say there is a new technology out there, say a fingerprint sensor, and I want every of my client to provide implementation to use that technology. When I say client, I'm talking about the people who implemented this interface, my interface. But there is a problem. Let's say I have introduced a new method, new abstract method in here, which would be, say, sense, fingerprint, something of that sort. Now everybody who is implementing my interface are forced to provide implementation. This is not a good thing for my reputation. Nobody would like to be forced. At the same time, if I let go this technology, then somebody else is going to define a new interface, and he's going to define such standards which will use the latest technology. And slowly over time, people will start migrating to a different implementation. And that's not good either. So thinking about all this, Java 8 introduces default methods. The actual reason of using default methods can be understood when we cover the concept of collections. It makes more sense there. But for now, this example should suffice. But let's move on. So what is the solution in here? The solution is obviously default methods. So now what is a default method? So far we haven't been able to provide implementation, or we haven't been able to provide behavior inside an interface. I mean, all these methods are abstract. We cannot have a curly brace and provide all the instructions. But from Java 8, it is possible that you can provide the implementation. But you need to make sure you will mark that method using a keyword called default. For example, in this case, we have introduced this new method, which is sense fingerprint. So I'll just simply get rid of this semicolon in here, and I would put a curly brace and provide some instructions to do something with the fingerprint sensor technology. Let's assume so. Now all the people who are implementing my interface, they don't have to provide implementation for this method, because I have already given the default behavior. I'm using the technology. But in case if these guys decide to provide implementation, they can always override the behavior of this method. So when we create an object of one of these classes, let's call this class C1, and when we create an object of it, C1 object equals new C1 whatnot. So object dot sense fingerprint is going to call the method which is overridden. In case if you don't provide any implementation,
this is going to result in calling the default implementation. So that way there is backward compatibility. You can introduce new methods. At the same time, you don't have to worry about people who already implemented your interface. But this has introduced a new problem. Actually, it has brought back the old problem we had with multiple inheritance. Remember the diamond problem with the multiple inheritance? We have eliminated that problem using interfaces, but now we introduce that problem back again by introducing default methods. Let's say we have interface A and B, and we have C, which is implementing A and B. Now let's assume that both A and B interfaces is having a method, say XYZ, and both these interfaces are providing default behavior in here. Now when we have an object of C, and if we do object.xyz, which method is it going to call? Confusion, right? So Java 8 has provided some solution for this as well. Let's go to our workbench and try to understand. First, let's quickly take a look at an example of default method. In here, we already implemented these two interfaces, land animals and water animals. What I'm going to do is I'm going to introduce a new method in here. Say void, maybe make noise, something of that sort. Now, did you see the problem that I was talking about? We are now forced to make changes to provide implementation for this method. But with Java 8, you can just convert that semicolon into curly braces and do whatever you want to do here. There's a shortcut to quickly type system.out.println. It's just type in sysout and then control space. It's just sysout and then control space. It's to control space. It should work. Maybe it's because of this error it is not working. Let's get rid of this. And as we know, we need to mark this as default method by using the keyword default. Now this should work. Sysout and then control space. It's a shortcut. Keep a note of it. And making noise, something of that sort. Maybe we'll get rid of the capital letter in here. Alright, now we no longer are forced to provide the implementation. And in here, I get rid of this. I do object dot, instead of breathe, I'm going to say make noise and run the program. There you have it. Now let's try to override that method. So all I'm going to do is copy this and paste this in here. You can always use this annotation, override, and make sure you make this public. Let's run the program. By the way, let's make some changes in here. Make noise from frog, something like that. Let's run the program. There you have it. The method is overridden. Now let's talk about the diamond problem, or the problem we had with the multiple inheritance. Let's get rid of this. Let's introduce the same method here as well. And we're going to get rid of this keyword. Make this default. Make noise from water. Let's save the file. Okay. See, now we have an error here. What does that say? Duplicate default methods named
make noise with the parameters blah blah blah. So it's just basically suggesting us that there is a conflict. So the way we deal with the conflict is by overriding. We'll override, and in here, instead of giving your own instructions, you will tell Java which default method to call. And the syntax for that is you're going to use the name of the interface. For example, I'm going to be using this name dot super dot make noise. Now if you run this method, it's going to call the make noise method inside the land animals. Right, and let's say you gave the water animals interface in here, then it's going to call the water animal default method. So that's how we deal with the conflict. That's it on the default methods. But again, the real reason of introducing default methods can be understood in better fashion when we talk about collections. See you in my next video. In our previous video, we talked about default methods, or also known as defender methods. What I should have also mentioned is that interfaces support static methods starting from Java 1.8. Actually, Java designers should have introduced static methods much before, but they thought that it would violate the rule of interface where an interface cannot have implementation. But in Java 8, with the introduction of default methods, anyway they have violated the rule of interface a little bit by allowing us to provide the default implementation. And since we did so, there's nothing wrong in allowing static methods as well. So the way you define a static method inside an interface is same as a static method inside a class. For example, you're going to do static void something of that sort, and you can have anything that you want to have in here. And in order to access this method, you can always use the interface name. So in our example, let's comment this out. I did Control-Shift/, I guess it's a / to comment out the selected part. And in here, I'm just going to call that method. Let's save the file and run the program. Well and good. Another thing to note is you cannot override the static method, even if you have the same signature. For example, I'm just going to copy the same method in here. Now this looks as though this method got overridden, but in reality it's not. For example, if I use this annotation override in here, it's going to throw a compile time error saying the method static method of type frog must override or implement a super type method. Basically what this means is the compiler did not find this method in the interface that is of not static. So we get rid of this, can't be overridden. Now looking at this interface, this looks as though this is an abstract class, right? An abstract class can have abstract method and also can have static methods. So what is the real difference? There seems to be no big difference between an interface and an abstract class. But there is a difference. Unlike an abstract class, since it's a class, it has some kind of a state. You can always have variables defined on top. Whereas in an interface, you cannot have a state. You can only have constant in an interface, which are public, static, and final. And since there is no state, there is no purpose of having a constructor. So interfaces cannot have a constructor. There's no meaning of it. And obviously, since there is no constructor, you cannot create an object of an interface. You can only have it as a reference type, but you can never create an object, or you can never create an instance of an interface. Hope that makes sense. In this video, we're going to talk about exceptions in Java. For this purpose, do import this project exception into your workspace and open up these files. We talked about compile time errors. For example, if I type in some random text, it's going to show us a compile time error. Similarly, if you're trying to assign a float value to an integer, it's going to throw us a compile time error. Compiler will not compile the program unless we fix all these errors. That being said, the ultimate job of compiler is to translate your code into a language that a JVM can understand. That means the bytecode. Compiler does not take full responsibility on fixing your errors. It will only try its best. What I mean by that is that there could be a scenario where an error could come when you run the program. That means compiler compiles the program successfully, but an error could come when we run the program. These kind of errors that come during the runtime are called exceptions. Well, the actual definition of an exception is not an error that comes in during the runtime. In fact, we're going to form our own definition of an exception after we take a look at this example. In here, I have just created an object of this class, exceptionTemp, in which I have a method that will just simply return this string. We have few instructions in here, and we know what those are. I'm calling this method and passing this object as an argument. Inside this method, I'm calling another method, method2, and I'm passing in the same object. And we're using that object to call this example method. Pretty well and good. Let's see the output first. Pretty well and good. Now, let's say I'm passing in here null. Maybe accidentally. Now let's run the program and see what's going to happen. It has executed these 2 lines of code, and something went wrong in here, due to which these instructions didn't get executed. So what has actually happened? Let's take a look. We're passing null here. Eventually it will end up in here. So it's going to be like this, null.example, which doesn't make sense. It has to be an object. The reason why this is called a null pointer exception is called the reference type is actually pointing to null. What do I mean by that? For example, we have a reference type object obj, and this reference type is pointing to null, and that's why this is called a null pointer exception. And this exception will only come in when we run the program. It's okay to have exceptions here and there, but it shouldn't cause the entire program to crash. In this example, these 2 instructions are innocent. Still, they didn't get executed. This is a big concern, especially for bigger applications. We can't expect the entire software to crash just because of one single exception behind the scenes. And there is a good reason why JVM don't execute all the subsequent instructions. That's because JVM thinks that if it executes all the subsequent instructions, there could be side effects due to the failure in this line. It makes sense from JVM perspective, but from programmer perspective, he wants all the rest of the instructions to be executed regardless of there is an exception somewhere in the middle of the code. How do we handle this? Is by using exception handling. Before we take a look at the exception handling, let us talk about something called a call stack. Whenever JVM comes across with an exception, the JVM is going to create an object of that particular exception. In this case, it's null pointer exception. And the JVM is going to throw that exception. When JVM throws that exception, there has to be something that will catch it. In this program, we don't have anything to catch it. So JVM tries to find some block of code that will catch that exception. If it doesn't find, JVM will throw that exception to the calling method, which in this case this method. And even in here, we don't have any block that will catch that exception. The JVM keeps throwing that exception, and it will eventually end up in the main method. And even in here, we don't have a catch block or a handler code, and hence JVM will just stop executing rest of the instructions, and it will just abruptly stop the program. So somehow, as a programmer, we need to convey the JVM that it's okay if you find exception. I still want to continue with the rest of my instructions. So how do we convey the same? By just looking at this program, you could make a guess that there is a possibility of getting a null pointer exception in this line. So what you're going to do is you're going to wrap this code. You could have more than one line, so obviously. You can wrap this code into a block called try block. As simple as that. By doing this, you're telling the JVM that try this block of code, and within this block, if you come across with any kind of exceptions, throw that exception and I'll catch it. And the way you catch it is by using the keyword catch. And what is that exception that you're trying to catch? Is null pointer exception. And you have the handler code in here. By doing so, you're letting the JVM know that you're aware of the potential exception that's going to come in here. Now from JVM perspective, since it's sure that you're aware of what you're doing, it won't mind executing the rest of the instructions. Now if you run the program, everything runs smoothly despite having an exception in here. Alternatively, you can just use the IDE's facility to wrap this code inside try and catch is by going to source, surround with try catch block. Let's run the program. Pretty well and good. And you see the call stack in here. Well, that's what is an exception in general and how we basically handle it. Let's continue in our next video. Alright, let's continue. In this video, we're going to take a look at the types of exceptions. Basically, there are two categories of exceptions. We have checked exceptions and unchecked exceptions. And within the unchecked exceptions, we have a couple of more categories. There are errors and runtime exceptions. The example which we have just taken a look at, the null pointer exception, is an example of runtime exceptions. All these runtime exceptions are due to the programming error or due to bad handling of exceptions. But when it comes to errors, these are actually not within the hands of a programmer. These errors are dependent on the hardware on which you run the program. I'm not talking about the compile time errors, the syntax errors, or if I assign a value of a float to int, that's all compile time errors. These kind of errors are still exceptions. I mean, they come during the runtime. A good example of these errors could be the stack overflow error, which we looked at in our previous example. I'm going to demonstrate the same in a while. Maybe I'm just going to demonstrate and then we'll talk about the checked exceptions. So in here, I'm just going to create another method, static void new method recursion. New method recursion. We're just going to call the exact same method. And from here, we're going to call this method. Let's comment out all these lines. If you run this program, this method is going to call itself forever until the stack gets full. Now, what is a stack? We've talked about it a million times. A stack is a memory location where a dedicated section will be allocated for each method call. Let's run this program. Here we have it. If you go up a little bit, we got stack overflow error. this method has called itself to an extent where the memory is full. Now this is dependent on the hardware on which you run. If you set the JVM parameters to utilize more memory, then this would delay the error, right? So these are called errors. Now let's talk about checked exceptions. What is a checked exception? As I've mentioned, the major job of compiler is not to fix errors in your code. Its job is to translate your code. But however, it's going to try its best to make you write a clean code. That's where the checked exceptions will come into picture. When the compiler scans your code, it's going to make a guess. Just as you have predicted that there is a possibility of null pointer exception in here, the compiler is also going to try its level best to make a guess on such exceptions. One such example of an exception is file not found exception. I'm just going to paste a line of code. Essentially, let's import that class. Essentially what this instruction is doing is we're just kind of getting a file reader so that we can read the content inside this file in the subsequent instructions. But what we're more interested in is it has thrown an error. Let's see what it says. Unhandled exception type file not found exception. So in here the compiler made a guess that there is a possibility that we get file not found exception. What that means is I have specified a path to a file. What if this file is not existed? We're going to get a file not found exception when we run the program. So compiler is kind of telling us to handle this exception because there is a possibility of file not being present in the specified location. So the programmer is forced to provide the handler for this. Only then will the compiler compile the program. Even though this file is actually present, compiler is still going to ask the programmer to handle that exception. These kind of exceptions are called checked exceptions. That's because these exceptions are checked by the compiler, not by the programmer. Hope that makes sense. So we talked about all the types of exceptions. One is the error, like Stack Overflow error. That's why it's called an error. And we've talked about runtime exception, like for example null pointer exception. And we've taken a look at the checked exceptions which are checked by the compiler, for example file not found exception, etc. We're going to take a look at whole list of exceptions. Of course we're not going to go deep and write code for each and everything. It's not worth the time. You can experiment it on your own, but we'll definitely be covering all the popular exceptions that you would typically come across when you write Java programs. See you in my next video. Okay, let's continue. In here I'm just calling a method inside another class, and inside that method I have a line of code that can potentially generate a file not found exception. And since it's a checked exception, I'm forced to provide the handler, and that's exactly what I did. I have wrapped the line with try catch block. Now let's say we need to do something with this argument. Say object dot example. I'm just calling this method. Now there is a potential that this line can generate a null pointer exception. So we need to wrap this code with try catch block, and we handle the null pointer exception. Why this has to be exception by default, we'll talk about it in a minute. Let's call this null pointer exception. I'll do control space to autocomplete the statement. Now this is very tedious job because for each and every line of code I write, I need to take care of providing the exception handling. Luckily in Java we have a shortcut. You can have multiple lines of code inside a single try block. What that also means is we can have a single catch block that will handle multiple exceptions. So I'll do Control X and paste it in here. We need to separate both these exceptions with the pipe character, and also we can now get rid of this variable in here because this variable will represent either of these exceptions. And this approach will be apt only when you're providing the same handling for both these type of exceptions. Now we can get rid of this code. Or better yet, you can just have
simple exception. What did I just do? All the exceptions that we're talking about, null pointer exceptions, file not found exceptions, or exception in general, are essentially class files that were created by somebody somewhere. Let me just take you to the hierarchy of all these exceptions. First of all, let me just quickly credit this website, programcreek.com. I'm able to find this diagram, which I thought will help you understand what I'm trying to say. All the blocks in blue are all unchecked exceptions, and all the boxes in red that are below this exception class are all checked exceptions. An example of which is file not found exception, which we have talked about. And an example of the runtime exception would be the null pointer exception, which is an unchecked exception. And we've talked about both of them. We've also talked about error, for example, stack overflow error. So whenever JVM comes across with stack overflow error, it's essentially creating an object of the class stack overflow error, which is the subclass of this error class. You don't see stack overflow error class in this diagram, but do take note of it. And both these classes, error and exception, are child classes of throwable class. We'll talk about this throwable class in a minute or two. So the point that I want to make here is all these exceptions that we've talked about are child classes of exception class. Now let's go back to our code. So in here, since exception is the parent class of both file not found exception and null pointer exception, it's okay to have the parent class type in here. Sometimes it's better that we let the caller method handle the exception. For example, let's say we're calling this method from here. For the sake of explanation, let's assume that this Java file is not present here. All we have is the .class file version of this Java file. We have imported that class file, and then we're trying to call the method inside it. If there is some kind of an exception in this method, we are not providing the handling. Somebody else is providing the handling. We want to deal with the exception our own way. So what is the solution that Java provides is the throws keyword. Let's go back here. If you get rid of the try catch block in here, we're going to get a compile time error. Compiler is yelling at you saying that please provide the handling. The way you convince the compiler that I'm not going to provide the handling, but I'll make sure that whoever is calling my method, I'm going to force them to provide the handler. So the way you convey it is by using the keyword throws, and then you will pass in the type of exceptions that are expected out of this method. One is file not found exception, and the other is null pointer exception. By doing this, even Java Virtual Machine will get convinced of the fact that whoever is calling this method must and should provide the handling for all the checked exceptions. So in here you should get an error. There we have it. Now you have two options. Either you deal with the exception by providing the handler with the try catch, or you can just use the same keyword throws to throw it to its calling method, which in this case is the main method. But this is a bad practice. You need to deal with exceptions as soon as possible. So let's handle it with the try catch block. Did you observe something? We got a couple of catch blocks. We'll talk about it at a later point of time. Now, had it been the case that we didn't have this line of code, we can easily get rid of file not found exceptions. Then, since this is not a checked exception, there is no need that the calling method needs to provide any handler at all. So what is the intent of the throws keyword? The throws keyword will not be typically be used with unchecked exceptions. They are used with either checked exceptions or user-defined exceptions. In our next video, we're going to talk about user-defined exceptions.
Stay tuned. In this video, let's try to understand custom exceptions. Let's say there is a requirement wherein if the age of the user is less than 18, then you're going to have to throw an exception with some message. Let's see how it's done. You just need to simply create a class. Let's call this custom exception, whatever the name that you want to give. And in here, if you want to make this exception a checked exception, then you want to extend exception. If you want to make your class an unchecked exception, then you want to use the keyword extends runtime exception. Remember the runtime exception in the hierarchy? Let's go back. So here it is. You're creating a new class in here, somewhere in here, and this will be an unchecked exception. Now all you have to do is create a constructor of this class with string as an argument, since you wanted to show a message along with the exception. And this is a very important instruction. You're going to use the keyword super to call the super class constructor, which in this case is runtime exception, and you're going to send the same parameter. Of course, this has to be small s. Now guess what? You have just created a custom exception. Let's try to use it. So if the age of user is less than 18, then you want to create a new object of your custom exception with some message. You are under age. You're not allowed to what? Allowed to apply for driving license. Let's save the file. Let's do Ctrl+Shift+F to give the proper indentation. And since in here age is 100, we're going to be safe. Let's make this 15. Let's run the program. Now can you guess where we went wrong? I'll give you 30 seconds. Why didn't we have an exception in here? That's because we didn't throw the exception. When we had a null pointer exception or any other exception, the JVM took care of throwing the exception. But in this case, since we created the exception, it's our responsibility to throw the exception. So we're going to use the keyword called throw. Now let's run the program. And I would expect these two instructions should not be executed. Here it is. And we also see the message, you're underage, blah blah blah. And we also see the call stack. And in case if you want this exception to be a checked exception, then you want this class to extend the exception class. Now if you don't provide any kind of handler, you're forced to provide some kind of handling. Let's do try catch and run the program. All the subsequent instructions should work now. Pretty well and good. Now you might get confused between the keywords throws and throw. If you open up our example, our previous example, maybe not this. In here, I'm telling the JVM that somebody else is going to handle the exception. I'm not going to do that. But whereas in here, throw is completely different. You're throwing the exception. I think it's pretty understandable. If you're interested, you can also throw the already existing exceptions. For example, you can just throw null pointer exception on your own. In this case, JVM won't take care of it. Hope that makes sense. Let's do Ctrl+Z. One last thing which I wanted to point out is in our hierarchy we have something called throwable class. Only if an exception is subclass of a throwable class will you ever be able to throw that exception and use the keyword throws. It's as simple as that. If there is an exception that can be thrown using a throw keyword, then it has to be a child class of throwable. Hope that makes sense. See you in my next video. Earlier we had talked about the custom exceptions, but there seemed to be no real advantage with it. For example, instead of saying custom exception, I can always say exception and have it in here as well. If I run the program, you would still get the exception, but the exception in here, the name of the exception is not very descriptive. But whereas if we have our own name and when we get an exception, the name is somewhat descriptive for the user. In here, instead of saying custom exception, I could say illegal age exception in here as well, and we put this in here as well. Let's save the file. And run the program. Illegal age exception. Now this makes sense. However, it is always advisable, and actually it makes more sense, to have your own methods written in here. That will be useful for the programmer. For example, instead of letting the programmer give his own age, maybe we want to define the age somewhere in here. So public static age limit, the return type is going to be int, turn 18. Now instead of letting the user enter the age, we can tell him what is the legal age, and you can use the same class name since this is static, something of that sort. Now this is not the best example I could give, but I'm just trying to give you an idea of how you can make the most out of custom exceptions. Let's save the file and run the program. The output is as expected. Okay, moving on. Earlier we had talked about having multiple exceptions under the same catch block. This is good only when you're trying to perform a certain set of actions, no matter what exception we get. By the way, we haven't talked about error index out of bound exception. It just means that I'm trying to access an element that is not present. In here, let's say we have 6 elements in here, and I'm trying to access the 10th element. This is going to result in error index out of bound exception. Now going back, instead of having these under one catch block, you can always have them in a couple of catch blocks, each dealing with individual exception. Like so. Now that being said, at a time only one catch block will get executed. For example, if we get a null pointer exception, the controller is going to get inside this block. Similarly, if we have error index out of bound exception, the controller will get inside this block. But what if there is an exception that is neither of these? Then it's always better to have a more generalized exception. Like for example, we could have simply exception. Always do remember that the order has to be more specific exception to a more general exception. If you put this catch block on top of everything, there's a problem with this. Unreachable catch block for null pointer exception. It is already handled by the catch block for exception. That means even if you get null pointer or error index out of bound exception, the controller will get inside this block because exception is more general, and these two exceptions are actually the child classes of the exception class. So we need to have a proper order. You can also have a try catch block inside another try block. It's called nested exception. Let me just show you what I mean. For example, let's say we get rid of the handling of null pointer exception from here, and we would like to handle right where the actual statement is. We're gonna say try catch, and then we can have the statement in here, and this is perfectly fine. We got a try catch inside another try catch block. Also, so far in our examples we've talked about the null pointer exception, but remember, prevention is always better than cure. It's always better to prevent the null pointer exception than trying to handle it once it comes. What I mean by that is, every time you anticipate a null pointer exception, it's always better to have an if condition and check to see if that object is null or not. Only if this object is not null will you want to execute this statement. Now this makes sense. See you in my next video. In this video we're going to talk about finally block. Sometimes you might want to execute set of instructions regardless of if there is an exception or not. For example, think of this scenario. Let's say you have a program, a Java program, and all we're trying to do in here is to do something with one of the local system files in your hard drive, maybe a txt file. It's not possible for the Java virtual machine to directly access these files. It needs to take help from the underlying operating system, and in order to take help from the operating system, JVM is going to use native interface and native libraries. If you remember, we've talked about native interface and native libraries when we talked about the Java virtual machine architecture. So this is where these two will come into picture. So first, JVM needs to place a request to operating system asking that it wants to do something with the local system files. Now the operating system will either reject or grant that program. The reason for this request and approval is to address one of the problems with this. For example, let's say there is another program which is trying to access the same exact file, let's say. Then we can't let two programs edit the same file. It's going to create ambiguity. Actually, it's not ideal to call two programs accessing the same file. Maybe I should call this as two processes trying to edit the same file. Think of it this way. Let's say we have two different photo editing softwares, say Photoshop and something else, and both are trying to edit the same exact file. Wouldn't that create ambiguity? So to address this problem, operating system will grant the acquisition of the system resource like file only to one process at a time. Once that process do whatever it wants to do with the file, then the operating system will grant other processes. So it's the responsibility of the Java programmer to tell the operating system that it has performed all the operations that it wants to do on that file, and now it's free for other process to take. So in here you have instructions that will edit the file, and finally you have instructions that will tell the operating system that you're done using that file. But what if there is some kind of an exception in here? Then that's going to cause a serious problem. These set of instructions will never get executed, which also means that this process acquired this resource, but it didn't free it. Now operating system will wait forever, waiting for the resource to be freed by this process, which will never happen. And so in this case we can't use the hard drive in other processes. This is where the finally block come into picture. If we could wrap this code in finally block, then no matter if there is an exception or not in the preceding code, the instructions in the finally block will get executed anyhow. So that way we'll be able to free the resources for other processes. This is not only in case of acquiring the system resource, this is also applicable when you're trying to acquire a database connection. Now let's go back to our workbench and see how we can make use of the finally block. This is a very simple program that would generate a null pointer exception. Let's run it. Pretty well and good. Now how do we write a finally block? You just have to use the keyword finally, and within the curly braces you will have all the cleanup code that I was talking about. Maybe you would want to disconnect from database, release the system resource, etc. We're going to talk about database connections and acquiring the system resource at later point of time, but for the sake of this example, let's just simply use sysout statement. And finally block. Now even if we have an exception in here, this line of code will get executed. There it is. And even if we don't, that will get executed. Now you may ask me, if we have this statement right after the try-catch block, like so, even in that case, this instruction will get executed regardless of if there is an exception or not. For example, it's executed, and even if we have an exception, it will be executed. But there could be a case where the instructions after the catch block will never get executed. For example, let's undo those changes. Let's assume that you have all this code inside a method and you're returning out of that method by using return keyword. Then in that case, all the subsequent instructions after the try-catch block will never get executed. But the instructions in finally block will get executed. Another such case is, let's say you have an exception that is not handled. In this case, we just have null pointer exception. But what if there is arrow index out of bound exception and is not caught in here? In that case, all the subsequent instructions will never get executed, but the instructions inside the finally block will get executed. Another scenario which I could think of is, let's say you have an exception inside the catch block. The same thing will happen. Now that being said, there could be a scenario where the code inside the finally block will never get executed. For example, if you explicitly exit out of the program by using system.exit, then it's going to cause the program to stop abruptly. You may want to explore this method exit on your own. A quick Google should help. Or in case if there is an error, I mean something like a stack overflow error or something, then even in that case, the code inside the finally block will never get executed. Because anyways, the entire program is going to crash under such scenarios. So there is no real purpose of releasing the resource. Okay, pretty well and good. Now you may have confusion between the finally block and the finalize method we've talked about earlier. They both are distinct. Although the purpose of these two are almost similar, they were used in two different contexts. The finalize method will get called when the corresponding object is going to get destroyed. But whereas finally is different, it has something to do with exceptions. Hope that distinction is pretty clear. Now this will summarize the chapter on exception handling. That being said, we're going to get back and talk about all the popular exceptions that are out there in the software industry. It's just that at this point of time, we haven't yet acquired enough knowledge to be able to comfortably understand all those exceptions. So we're going to come back and go through all the list of exceptions at a later point of time. And definitely I'm not going to show an example of each and every exception. I'll just make sure that you're pretty well aware of all sorts of popular exceptions out there. Hope that makes sense. See you in my next video. In this chapter, we're going to talk about Java IO, or input and output. Consider the following example. Let's say you have a water purifying plant, and all you need to do is to take in the water from the river, purify it, and send it to an overhead tank. So we have a river, which would be the source, and we'll have an overhead tank, which will be a destination. Now, in order to take in the water from the river, you need to create a pipeline. And once we install the pipeline, a stream of water will start flowing. This stream is called an input stream. The reason is this stream has become an input source of water to this water purifying plant. Similarly, we need to have another stream between the water purifying plant and the overhead tank, and we need to let the purified water flow in that stream. Now this is called an output stream, because the output that comes out of this plant is going to get transported to the overhead tank. Now do take a note that once we take in all the water inside the river, there's nothing left in river. Similarly, once we transport all the water from the purifying plant, there is nothing left in purifying plant to process. Now keeping this in mind, let's try to map the same example with IO in Java. We can replace this water purifying plant with a Java program, and we can replace this source or the river with a file. There can be any number of sources, but for the sake of this example, let's consider it to be a file. And this file will have some kind of text in it. Similarly, we're going to have a destination, and in this example, we're going to consider another file as the destination. Our job is to copy all the text in here to the destination file. And in between, we may want to do some processing. But in this example, I just want to demonstrate to you how to copy this text from the source to the destination. And for this purpose, we need to create the pipeline or the streams. We're going to need to create an input stream, and to put the data from the program to the destination, we need to create an output stream. That's exactly what I'm going to demonstrate you now. In this case, the stream that's going to flow is bytes of information. Although it's the text which we see on the file, internally it's all zeros and ones. So this stream would constitute bytes of information. Now let's go to Eclipse and see how this can be done. Import this project Java IO, and in that open up this file, Java IO file example. And here the first thing that I'm going to do is to create input stream. Since we're dealing with file, we're going to create the file input stream. And the argument that you're going to pass in is the path to the source file. Let's create a source file. I have already done that. I've created this file todos.txt, and in that I just have a text which is essentially my to-dos. Let's get the path of this file. Let's copy this and paste it over here. And remember, we need to use the escape character, which means another slash, and you're going to provide the name of the file, todos.txt. Let's expand this. Now we have an error here. Can you guess what it is? It's a checked exception. There could be possibility that this file is not existed at all. So we need to either provide try-catch block or just use throws. Now we have created the input stream. Now let's create the output stream. Let's copy this statement and paste it over here. Let's call this out. Of course, this has to be file output stream. Let me copy this and paste it over here. And the argument that this is going to take in is the destination file. Let's have a new file name in here, something like that. Now the next thing that we're going to do is to read each and every byte of information from the source file. And for that purpose, we're going to use the method called read inside this class file input stream. While we're also going to be needing an int variable. We'll see why in just a while. I equals in dot read -1. Now what we're trying to do here is the input stream in here is going to have stream of information, and in this case is just bytes of information. The text is essentially represented in bytes in our hard drive, and that's exactly what is going to come inside the stream. The file input stream is going to have the bytes of information of the text inside that file, the source file. And this read method in here is going to read 1 byte at a time. And once it reads 1 byte, it's going to read the next byte the next time we come back to this loop. So we keep looping in this while loop for each and every byte of information. And in here, we want to do something with that byte of information. Also, there has to be a condition to break this loop. The condition in here is when the read method returns -1, that means it has reached the end of file. Going back to our previous example, that means the river has no water to consume. So we'll quit out of this loop. By the way, we seem to have an error here. Again, we're going to provide the throws declaration. We're going to come back and talk about try-catch block, how we can make use of it. In fact, this is the perfect place where you will understand the try-catch block and even the finally block in better fashion. So we'll get there pretty soon. So for each byte of information, what we want to do, we want to print that we want to send that information to destination. So we can certainly make use of this output stream. So we're going to say out.write. It's going to take in the integer parameter, and I'm just going to pass in the I. So what does this variable I hold? It's just going to hold the integer form of the byte information. So this read method will read the data as byte and is going to convert that byte information into integer. When we pass that integer to this write method of the output stream, the write method is going to convert. In fact, it's going to typecast this integer into character. And how is this done? Going back to our typecasting examples in the beginning of this tutorial, we've talked about how we can typecast an integer to a character. Let's say the value in here is 65. Then if we typecast it to a character, it's going to be capital A. Let's take a look at the ASCII table. You can find this table in ascii.cl, and you can see if the integer that we're going to get is say 90, then that's going to be the letter Z. Similarly for 65, it's going to be capital A or uppercase A. Likewise, we have total of 127 characters. And if you take a look at the extended ASCII table, there will be total of 256 characters. The reason why there are 256 characters is because in each byte there are 8 bits. So within the 8 bits, how many combinations of zeros and ones we can have? is 256. Let's go back. When you're going to read each and every byte, and when we convert that each and every byte to int and eventually to a character, it's not going to go beyond the 256 characters, because ultimately we're reading one byte at a time. Hope that's clear. And this is pretty much it. This should copy all the contents in the todos.txt to the todos new.txt. Let's save the file and run the program. You probably won't see any console output because we don't have any system.out.println instructions. Let's go to our desktop and see. Here it is. We have exact same information. This is definitely a good start for this chapter. See you in my next video. In this video, we're going to talk about character stream. The example that we talked about in our previous video used the byte stream, meaning the data that we're reading from the text file, we're not reading it in the form of character or text. We're reading it as bytes, just as it gets stored in the computer memory. And internally, we're trying to convert those bytes, etc. But ultimately, this stream, the file input stream, is going to hold the byte information of the text present in the file. And we're looping through each and every byte, and we're trying to do something with it. We can also use the character stream. Instead of the byte stream, we can have character stream so that we can loop through each and every individual character from the text file instead of looping through each and every byte of information. Now you may ask me, how does that make a difference? Consider the following example. Let's say I'm creating a new file in here. Let's call this temp. This file is going to remain here temporarily. And in here, I'm typing in some random text. If I save the file, it saves comfortably. No problems whatsoever. But what if I enter some kind of text that looks something like this? Now if I try to save the file, then we get a prompt saying the file contains characters in Unicode format, which will be lost if you save the file as an ANSI encoded text file. Now what is an ANSI encoded text file? To know more about it, I would recommend you to go to Wikipedia. Here it is. An ANSI character set has no official meaning and has been used to refer the following among other things. So the ASCII character set that we've talked about in our previous video is one of these. So what I'm trying to say here is all these characters in here are not part of the ASCII character set. And the kind of encoding, the default encoding which we're trying to use here does not support these characters. And that's a warning that we're getting. To keep the Unicode information, click cancel below and select one of the Unicode options from the encoding drop-down list. So let's click cancel. Let's save the file. Do you want to replace it? Yes. Okay, and let's close the file. And if you try to open the file now, we're seeing just a bunch of question marks. The reason is the ANSI encoded text does not support the characters that we have put in here. So it just doesn't know what to put in here, so it just shown us a bunch of question marks. Now let's do something different. Let's have the same special characters and save the file. We get the same warning. Click cancel, but this time we're going to use a different encoding, UTF-8. Let's save the file. So I want to replace it. Now if I close the file and reopen the file, it's going to retain those characters. That's the magic of the encoding. So what has actually happened here? If you understand, for each and every byte, there are only 256 combinations of zeros and ones. And all the characters inside the ASCII character set would occupy all those 256 characters. It's not possible to represent any of these characters in just one byte of data. So if we use the UTF-8 character encoding, each one of these characters is going to be represented in more than one byte. It's going to be between 1 to 4 bytes. Now let's close this file. Let's go back to our example. In here, let's try to read from the text file, the temp file with all the special characters. For the sake of this example, let's get rid of the output stream. Instead, we're just going to use the sysout statement, and we're going to print. And all I want to print here is the integer value that we're going to get, and I'm going to append it with character representation of that integer. Now let's try to run the program. What has just happened? Can you guess? Although we have only 4 characters in that text file, why are we getting so many characters? The reason is, as I mentioned, each one of the characters in the text file is no longer 1 byte. It could be 1 to 4 bytes. And we're just looping through all the byte information in here. So to represent all those 4 characters, there are a total of 11 bytes. Now this is clearly a problem. The characters which we have in the text file were not getting printed in here. That's because we're converting each and every individual byte information to character, and we're trying to print. The solution to this problem is read the content inside this text file as individual characters, not as individual bytes. So how do we do that? We're going to use the input stream reader, and let's call it INR, input stream reader, and new input stream reader, and the argument that we're going to give is the file input stream object. Essentially, this is going to act like a wrapper for this class, meaning this is going to convert all those bytes of information into characters. But still we have one problem. By default, this is going to use the default encoding. What is the default encoding? If you right click on this file, go to properties, and in here you see the default encoding. The text file encoding is of CP1252. Let's click cancel. So what we're going to need to do is we're going to have to tell the kind of encoding it needs to use while converting the bytes of information into characters. And you can pass in another argument to the constructor of input stream reader, and you're going to say UTF-8 format. Now let's try to run the program. This is still going to cause a problem. Obviously, we need to use the input stream reader object in here, not the file input stream. And this is going to result in going through each and individual character, not bytes. Pretty well and good. Ignore this first character. This is called BOM, or byte order mark. This is used for holding the information about the bytes that are getting stored, etc. It's a little tricky there, but we're not interested in this. All we're interested in here is the rest of the characters, which are 4 characters. But still we didn't see the characters in here. That's because this console in here is not using the UTF-8 encoding. So we need to change that as well. We go to properties and choose other, and in here you can choose UTF-8, click OK, and then let's run the program. You would see all those characters. Pretty well and good. Similarly, for file output stream, we can have the output stream reader, output stream writer, and you can specify the kind of encoding. Let's try to do the same. I'm going to uncomment it. Let's copy this line and let's call this OSW, output stream writer. It's just plain opposite of input stream reader, output stream writer. And obviously we need to send the output stream object to this, and we're going to use the same to print all those characters using the write method. And we send the integer as an argument, which in this case is I. Let's save the file, but this time let's use a different file name, temp underscore new. But before running this program, we need to use another method inside the output stream writer, which is flush. So what this method will do is it will flush all the characters that are in the stream, output stream writer, to be written into the destination file. We'll see and we'll talk about this pretty soon. Let's run the file. There it is. Pretty well and good. Now instead of creating all this mess, let's comment this out. You can simply use file reader and file writer objects like so. File reader, you're going to have exact same constructor. Obviously this has to be changed to file reader. Similarly, we can have file writer, and you can use file reader to read the information and file writer to write the information. Now, how is file reader and file writer is different from file input stream and file output stream? The file reader is going to use the character stream, not the byte stream, by default. But whereas in here, we need to use a wrapper class, which is input stream reader, to be able to read bytes of information as characters. But there is one problem here. The file reader and file writer is going to use the default encoding of your operating system, and most of the operating system may not support the UTF-8 as the default encoding. So it's not recommended really that you use file reader and file writer. Instead, use this mechanism. Now obviously this program is going to result in inappropriate results because it's going to use the operating system's default encoding. So let's undo everything. So that's it for this video. Thanks for watching. See you in my next video. In this video, we're going to talk about buffer reader. Buffer reader is used for the sake of efficiency. Let me give you a real-time example. Let's say you have a river with some water, and let's say there is some kind of a pipeline connected to that river. In one end of the pipeline, there is a tap that will control the flow of water. If you turn off this tap, the flow will stop. If you turn it on, the water will start flowing. And let's say your house is located in some remote location where there is no supply of water. Let's also assume that you only have one container which is of capacity 1 liter. Let's say the distance between these two is say 10 kilometers. Now every time you need water, you need to walk for 10 kilometers, collect the water of 1 liter and come back. This is a very tedious job. So instead of doing it in this manner, you would rather purchase a container of say 50 liters. You would take that container to the location where the water is available, fill that container and get it back and pour it on your overhead tank. Now this way you're getting a lot of water in one go. So you don't have to go 50 times to get 50 liters of water. Now this is exactly what we can achieve with buffer reader. So far, when you read the data using input stream reader or file input stream using the read method, you're fetching data all the way from the hard disk. In comparison with this example, with our Java example, we can replace this river with our file inside the hard disk, and the tap can be
replaced with the input stream that we create, and the house can be replaced with our Java program. So if you use the read method of either input stream reader or the file input stream, every call of this method is going to fetch data from the hard disk. So each and every character, if this is a character stream, then for every character we need to go all the way to the hard disk and get that character to our program. This is very expensive process. Also, if you remember, in one of our previous videos, I've explained that we will make use of the native interfaces, and we actually take help from the operating system to get access to the files inside the hard disk. And that's a very expensive process. So instead, if we use the buffered reader, instead of getting one character at a time, it's going to get one chunk of characters in one go and is going to store in the RAM memory. In this example, it's the overhead tank. Once we have a chunk of data, not all the data by the way, just a chunk of data in the RAM memory, with our program it's very easy to access the data and it's very faster. And when we are accessing this method, the buffering mechanism is going to refill this buffer with next stream of data. We can also set the size of this buffer. Now let's go back to our program and see how we can make use of the buffered reader. Alright, here we are. All we're going to need to do is to create an object of the buffered reader. I'll do control space to autocomplete. Let's call it BR, stands for buffered reader, and equals new, again control space, buffer reader. And the kind of argument that the constructor of the buffer reader would expect is an object of the character stream. In here, this is the file input stream, and we have wrapped this input stream with input stream reader that will make this stream the character stream. So this is exactly what we're going to pass as an argument to the buffer reader. Let's get rid of all this code in here, or maybe just I would comment this out for your future reference. And in here I'm going to create a variable of string. We'll see why in a minute. And I'll call this line. I'm also going to have a while loop, and inside the while loop I'm going to do line equals, I'm going to use the buffer reader object dot, now see the magic. We got a method called readLine. The readLine method will help us read data from a file line by line. And once this method returns null, that means there is nothing left to be read from the buffer. Let's just do sysout, and we're going to simply print that line. Let's run the program. By the way, let's change this back to to-dos. And in here, we don't have to have the UTF-8 encoding anymore, because all the characters inside this to-dos.txt will belong to ASCII character set. Let's run the program. Pretty good. We also have buffered input stream. And this class will help us use the buffering feature for the byte stream. So in here, it cannot take the character stream, it will take the byte stream. You're going to have to use a different method in here, br.read, and is going to return an integer. So I, and similarly -1. We will print that integer and we convert that back to char. Let's run this program. Now obviously, since we used the println method, it's going to print a character along with the new line character. Let's get rid of this and use the print method. Pretty well and good.
Just remember one thing is that it's always better to use the character stream when you're dealing with the textual data. Since todo.txt is holding the textual information, let's undo the changes and use buffer reader. Now you may wonder, when do we ever use file input stream? I mean the byte stream. If you're dealing with an image file or a music file or a video file, it's better that you use, or in fact, you have to use the byte stream, not the character stream. It's only when you have to deal with the characters you should use the character stream. And no matter which stream you use, always make use of the buffering mechanism, and that will improve the performance dramatically. Alright, that's it for this video. Oh, wait a minute. I guess I have one more thing to say. Just as we used buffer reader for input character stream, we can have buffer writer for character output stream. Let's do that and have a complete example. So we're going to have the file output stream out equals new file output stream. Let's copy this argument. To-dos, let's call this buffered output, and we're going to have to convert this byte stream into the character stream. Output stream writer new output stream writer, and we're going to pass in the byte stream object. And finally, we're going to have buffered writer new buffer writer, and we pass output stream writer object, which is a character stream, character output stream. And now we can just simply use this buffer writer to write the data into the file. Let's save the file and run the program. Let's go to desktop, and here it is. Well, that's funny. I guess we have to flush the data. Let's do that. Buffer writer dot flush. This is what will actually dump all the data into the file. Let's save it and run the program. Here it is. You may ask me why we have everything under one line. It's not actually having everything under one line. Basically, the readline method will actually omit the new line character. If you take a look at the Java docs and see the description of what the new line method would return, this is what it says. A string containing the contents of the line, not including the line termination character, or null if the end of the stream has been reached. And that's why we got everything under single line. Now going back to our example, we can always increase the size of the buffer. You just have to provide another argument. The default size of the buffer used by the buffer reader is 8192 characters. However, we can configure the size of the buffer to any size we want. So all you have to do to increase the buffer size is to send in another argument to the constructor. Basically the amount of bytes of buffer you would need. And always keep in mind, as a good practice, instead of typing in some number, try to type in the multiples of 1024, because it makes 1024 bytes to make 1 KB of memory. And if you give multiples of 8, that means we're going to have the buffer of size 8 KB. The program will run just as before. Let's close the file and reopen it. Pretty well and good. Alright, that's it for this video. Thanks for watching. In this video, we're going to talk about closing the streams. Once you're done using the streams, it's always important that you close the stream.
To explain you in better fashion, I'm going to make use of the functionality provided by the Eclipse, which is debugging. Debugging will allow you to pause the program while the program is running, and it will let you analyze the code then and there. So to make use of the debugger, we need to have some breakpoints. For example, if I have a breakpoint in here, and when we run the program using the debugger, the program execution is going to pause in here for us to do something. Let me just show you. So instead of running the program, I'm going to click this bug icon to start the debug process, and the controller will stop right there. It won't process further until we say it to go. So in here, you can just analyze this line. So the line currently is holding this text. If you press F6, it's going to move on to next instruction. By the way, I have moved out the code of buffer reader and buffer writer under another file, which is bufferreaderwriter.java, and I've also have a new line introduced right after each and every line. So the output will now have a new line character. Each line will be printed in a new line. Now moving on, so you can analyze the code like so, and if you click resume, the controller will stop at the next breakpoint. If there is no breakpoint on its way, it's just going to complete the execution of the program. So let's click this, and since we are in while loop, it's going to stop here again, but this time the line is different. I hope you got the purpose of the debugger. Anyway, why am I explaining this? To tell you the significance of closing the streams. We have this output stream open. That means we didn't use any statement like close or something to close the stream. Now let's see what can happen if you don't close the stream. If I go here and if I try to delete this file, I'm going to get a message saying the action can't be completed because the file is open in Java platform SG binary, which means some Java process is using this file, and so we cannot delete it. This is a very simple program, and we may not see any damage being done, but think of very large applications where there could be thousands of Java files, and when you run that application, and let's say you have opened a stream and you forgot to close it, then throughout the execution of that entire application, you cannot do anything with that file. And that's why I've used the debugger in here to stop the program, making sure that the stream is still open, and as we've looked at, we cannot delete the file. So what we need to do is we need to use the method inside the buffer writer called close. Let's stop the program to close the stream. Buffer writer dot close. Now there are a couple of things that's going to happen with this. One is you no longer need to use the flush keyword, because when you close the stream, it's going to automatically flush the data onto the destination. In this case, it's another text file. Number two, if you close the buffered writer stream, it's also going to close all the corresponding streams, which are output stream writer, file output stream as well. And it's also important that we close the input stream just like so, using the close method. Now this way we're ensuring that we didn't keep the file stream open throughout the execution of the entire application. Let's run the program, and everything works just as before. Now another reason why you want to close the streams is from operating system perspective. When you create an output stream or an input stream, you're essentially opening a file to do something with it. And even in your operating system, you cannot just open unlimited number of files. There is a certain limit. If you keep opening files, hundreds and thousands, over time you will reach to a point where you won't be able to open any more files. Same with this. If you keep creating the streams and not closing them, ultimately in larger applications, it's going to result in reaching the limit
of the files, and the rest of the program may not be able to create streams or deal with files. Now that's a big problem. So always remember to close the streams the moment you're done with it. If you don't close the stream manually, the Java is going to take care of it, but there will be a very big delay, because when the garbage collector comes in and destroys this object, that's when the stream will get closed. And we're not sure when the garbage collector will come, and definitely we don't want to rely on it. We still have one more problem in here. Can you guess? Well, I'll give you a clue. Is there any possibility that these instructions will not get executed? Sure. If you have an exception in these lines, then this is not going to get executed. What is the solution? Use try catch finally block. So let's get rid of throws in here, and instead let's wrap the entire code inside the try catch block, surround with try catch block. Eclipse has automatically did the job for me. We have an error here. We'll get there what it is, but we're leaving the scope for these instructions to not get executed. For example, if we have a return statement in here, this won't get executed. So what is the solution? We're going to have the finally block, and we're going to have these two instructions in here. Now let's see what the error says. There is one checked exception, so for that we need to provide another try catch inside the finally block. And even for this, the code is really getting bigger due to introducing the exception handling, but it's really worth it, believe me. We have one more error. Let's see what it is. It just says the variable is not initialized. This has to be initialized to some value. In this case, let's make this a null. Because the initialization happened inside the try block. By the way, what if this BR is a null? Then this is going to throw a null pointer exception, and since the exception is not handled in here, this statement will not get executed. Serious problem, right? So as a good practice, it's always better that you check to see if this object is null. If it is not null, then go ahead and close the stream. So it's going to be if not equals null, then you'll do this. Same in here. PW, and let's save the file. In fact, now you can have these two handled under one try catch block. No problem whatsoever. Let's save the file. Let's do Ctrl+Shift+F to give proper indentation. And there it is. This is a proper way of dealing with streams. And the reason why I said you need to have this variable initialized is because you can't just use a simple reference type without that reference type pointing to certain object. We cannot call the method close without pointing it to some object, and that's why when you get rid of this in here, it's going to show us, the compiler is going to tell us to initialize the variable. Alright, that's it for now. See you in my next video. In this video, we're going to talk about how we can make use of Java IO package to copy an image file. By the way, all these classes we've talked about were all part of the package called java.io. We're going to talk about all the classes, and in fact we're going to go through the hierarchy of classes inside this package pretty soon. In this example, since we're dealing with an image file, we don't need to use input stream reader. Input stream reader is specially meant for textual stream. So we can simply get rid of this. Let's save the file. Now all I'm doing here is I gave the path of the picture, which in this case is mypic.jpg. Let's go there and take a look at that picture. So this is mypic.jpg. Well, the name is mypic, but this is not me inside the picture.
just that the picture is mine, but I'm not the one who is inside it. Anyway, we're going to copy this image using the output stream. Again, this is file output stream, and we have the exact code as to that of the one we have seen in our first example. Let's run the program, and we should see a copy of this image with the name mypicCopy.jpg. Here it is. Here is a wonderful picture from India. Let's close the file. Alright, now what I want you to take away from this example is that using the file input stream and file output stream, you not only deal with textual data, you also deal with pictures, music, video files, etc. Now what this also explains is that if you were to develop a software or an application like Photoshop or Audacity to edit the audio files, etc., this is what you're going to do. You will make use of the byte stream and you will do something with it. Hope that makes sense. See you in my next video. So far in our examples, we've used files as source and destination, and for that purpose we've created file input streams and file output streams. But there are multiple types of source and destinations. In this example, we're going to use array as a source and array as destination, and for that purpose we're going to have to create a stream that has something to do with array. In this case, we have a byte array, and you need to enter some values within the range of byte, which is -127 to 128. If you enter something greater than that, for example 129, it's going to show us an error saying the mismatch cannot convert from int to byte. Let's undo. And we've created byte array input stream, and we pass this array to the constructor of this class. So essentially what this means is this stream in here is going to read bytes of information from this source, which in this case is an array. And all I'm doing here is just looping through each and every byte, trying to convert each and every byte of information to character, and I'm just printing it. If you run this program, you would see character representation of all these bytes in this array. And just as we've used file output stream to create an output stream for file as a destination, we can have an array as a destination, and we can use byte array output stream to create the stream between the program and the destination. In this case, it's another byte array, and instead of writing it to the console, I'm just going to write it to this array. And all I'm doing in rest of the code is I'm actually converting that output stream to an array, and I'm kind of assigning it to this byte array, and I'm looping through each and every element of it, of this array, and I'm printing it in the form of character. Let's run this program. There it is. Alternatively, you can use a string and you can convert that into array of bytes by using the method getBytes of the string class. Let's save the file and run the program. Pretty well and good. On the contrary, if you're dealing with the character array, then you can use the char array reader to create a character stream between the program and the character array, and you can do something with it. And obviously you can have char array writer to write the data into an array. Just remember, when we have the stream at the end of these class names, then that means we're dealing with the bytes. If we have a reader or a writer, then that means we're dealing with the character stream. Okay, pretty well and good. Let's run this program. There it is. See you in my next video. It is possible that we store an object along with its state into a file, and then again from another program we can get that object back again along with its state from that file. Well, this might sound confusing, but it is possible. And for that purpose, we're going to have to use a mechanism called serialization. What is serialization? A serialization is a mechanism where an object can be converted into a byte stream.
And in order to be able to convert an object into a byte stream or to be serializable, the class has to implement this serializable interface. Only then the objects of this class will qualify to be serializable. In this class, this is a very simple class where we have one constructor and we are setting the state of one of these variables in here by sending an argument to this constructor. In this case it's color, and we're going to use this method to get what we have set in here. We also have a method, and that just simply going to show this message barking. What I did in this file is I have created an object of that class and I had set the state to brown. The color of that dog is going to be brown. And the next thing that I'm going to do is going to create a file output stream. We're going to use file output stream to put all the binary data of the object into a text file. And in order to convert the object into the binary data, we're going to have to use this class object output stream, and its constructor will take in this object, the object of file output stream. And using this object, we're going to call this method write object, and we're going to send the object that we want to serialize as an argument to this method. Doing so, the object along with its state will be converted into a binary form and will be stored inside this text file. And finally, we're going to close the stream. By the way, in our examples, we're not using the try-catch block. The example that I've demonstrated you is definitely not a good practice. You're going to have to use the try-catch block. It's just that the number of lines of code will increase if I introduce try-catch blocks. Let me show you how the class looks with try-catch blocks. Here it is. This has increased the lines of code almost doubled. Anyway, let's run this program and we should have this file created. So here it is. Let's see what's inside it. You would not understand anything. Well, basically, the text editor, Windows text editor, tried to convert all those binary data into characters, and this is how it ended up. But what you're seeing is essentially the dog object in a textual format. Isn't that wonderful? Now let's go back. I have another program which is object input stream, and as you would guess, we're going to create an object input stream to read the object binary data back into the program, and then we can use that object along with its state. So in here, that's exactly what I did. Using file input stream, I'm reading the data from the file, and then I'm sending this as a parameter to the constructor of object input stream. And using this object, I'm going to just call the method inside it, which is read object. And I need to typecast it back to the desired object. This is dog object. So here is the class name. And now we can call the method inside it, as well as we can also get the state that we had set when we serialized the object. So what we have done here is we have deserialized that object, and we're able to play with that object. Let me run this program. Awesome. Isn't that wonderful? The concept of serialization and deserialization will come into picture when we talk about Java 2 Enterprise Edition, where you would deal with web applications, etc. But it's a long way ahead. I'm just trying to tell you the significance of using the streams for dealing with objects. Hope that makes sense. See you in my next video. We've been using streams throughout our examples even before this chapter, and those streams are something that we didn't create. Those were created by the Java virtual machine. I'm talking about system.in, system.out, and system.error. Let's talk about system.in. System.in is a stream that is connected to one source. The default source of system.in would be your keyboard. So whenever you have this defined system.in, then you're actually doing something with your keyboard. This will let you enter something from your keyboard while your program is running. Now I said system.in is an input stream, but is also a source. It is a source to this object. the scanner. We could use input stream reader, but the problem with that is we would only be able to enter one character at a time. But whereas if you use scanner, you can enter a bunch of characters, string. So hence I use this scanner, and using this scanner I'm going to invoke the method inside it, which is next line. This will let me enter the value when the program is running. Similarly, we're taking another input, which is the last name. Let's talk about system.out. It's an output stream, and the default destination for this stream is going to be your console. And that's why whenever you use this statement system.out.println and you provide something inside it, you would say something on your console. The system.error is no different from system.out, except there is some formatting done that will make the text look like an error. Whenever we get an exception, we see red colored text on our console. Internally, it had used system.error to display that text. Even when you're creating a custom exception, it's always advisable that you use system.error instead of system.out. Now let's run the program. I'm going to enter the first name and last name, and we have the output. Now do take a note that when we had used system.error, the text is actually highlighted in red. Alright, see you in my next video. In this video, I'm going to talk about the file class. The file class will allow you to access the underlying file system. In this particular example, all I'm trying to do is I'm trying to see if this file is existed. If not, I'm creating one and displaying some details about it. For that, I have an object of the file class, and I'm going to pass in the path of that directory as an argument. Do take a note that this path can either be the path of the directory or the path of any specific file. Let's make sure in our desktop there is no directory with this name. Now let's run the program. So file is created. In this case, it's a directory with the name subdirectory, because that's what we gave in here, and we've displayed the absolute path of the directory. Let's go to desktop. Here it is. So this method makeDirs not only created the directory but also the subdirectory. In our previous examples, whenever we had used input streams, we're passing an argument. Although this looks like we're passing a string, internally this string will be converted into this file object. So this line in here is internally like this, the new file object and then the path. I've just demonstrated a very simple example, but you can explore more such methods inside the file class. For example, if you do new dir dot, you got a lot of methods to explore. We have isDirectory method to check to see if the path given is of a directory or a file. You can actually go through the description in here. Similarly, we have the delete method. This will allow us to delete the file or the directory. There are many such methods, and I would encourage you to go and explore and play with it. Alright, see you in my next video. Alright, let's look at the class hierarchy of the Java IO package. It's quite a large package with lots of classes, but we've covered all the major classes that are in here. Also, more than anything, the point I want you to take away from this chapter is, depending on the source and destination, you need to choose the stream. For example, we've used file input stream when we're dealing with files. We've used byte array input stream to read the data from the array. And we've used object input stream to deal with objects. It's impossible to talk about each and every class in the Java IO package, but we've talked majority of them, and I'm sure by now you are capable of understanding the purpose of rest of the classes in here. All you have to do is to click one of these classes and see the description. And some of these are also having examples associated. If you look at this hierarchy, the ultimate parent of all these classes is the object class. Console is something that will let you enter values from the console. This is somewhat similar to the scanner example we've seen in our example. We've talked about file, and we've talked about some of these classes in the input stream. We've talked about the object streams, and we've talked about output stream classes, for example, byte array output stream, file output stream, etc. And coming to permissions, basically using these classes you can deal with the permissions that you give to the file or the folder. It's pretty self-explanatory if you read the description. The random access file is something that will allow you to read the data somewhere in the middle of the file. And we've talked about readers. We've talked about the writer. Basically, readers and writers will deal with the character stream, whereas when you have input stream or output stream, all these classes that end with stream will actually deal with the byte stream. And we are aware of some of these exceptions, and they're all child classes of throwable, and that's very obvious. I guess we've covered majority of these classes, but we might be missing some classes here and there, which is fine. And in fact, some of these classes will be covered at later chapter. For example, talking about the piped input stream is something that you'll understand when we talk about the multi-threading concept, which will be our next chapter. Also, I'll try to put examples of some of these classes in the project files along with the description, just for the completeness. So I guess that's it. This will summarize this chapter, and we'll definitely be using streams throughout our course. And in fact, when we get into Java to Enterprise Edition, we definitely have to use streams in order to get our job done. So until then, stay tuned. In this chapter, we're going to talk about multi-threading. Before we understand what is multi-threading, let us try to understand what is multitasking. Take a look at this example. Let's say there is a person and he is watching TV. While he is watching TV, he is also able to eat popcorn. And when he is doing both, he is also able to attend a call. As per this person, he thinks that he is performing all these tasks simultaneously. But actually, his brain is allocating few seconds of time on each one of these tasks and is switching between the tasks so quickly that the person feels that he is doing all these tasks simultaneously. For example, his brain is allocating 2 seconds of time in watching TV, say 3 seconds of time eating popcorn, and a few seconds of time in attending the call. And it switches between all these tasks so quickly that the person thinks that he is performing all these tasks simultaneously. Same is the case with computers. If you have a computer with single processor, and the reason why you're able to run so many applications at the same time, like Photoshop, Microsoft Word, or any game, is because this processor is allocating some nanoseconds of time on each one of these applications, or let's call it processes, and it switches between all these different applications or processes so fast that as a user you feel that you're able to run all these applications simultaneously. So in both these cases there is no actual simultaneous behavior. So when does computer perform tasks simultaneously? Is when you have more than 2 processors. Although you have one single physical processor, it can have more than 2 cores. A core is just a logical division of a processor, and each core would act just as another processor. When you have a processor, a physical processor with 2 cores, that means your system can perform 2 processes or 2 applications simultaneously. So now you can run Photoshop and Microsoft Word simultaneously, where each processor is dedicated to run one application or a process. It's as good as having 2 brains, and each brain is allocated to one task. Now, since we're able to perform 2 processes simultaneously, this is called process-based multitasking. Another type of multitasking is called thread-based multitasking. Let's see what it is. Let us try to understand what is a thread. You can think of thread as a sub-process. For example, let us consider Microsoft Word. In Microsoft Word, there's a process that takes in the input from the keyboard, from the user, and that's why you're able to see the text. And there could be another process running behind that will check the spelling of whatever you type. So each one of these sub-processes can be termed as a thread. Whereas from programming perspective, it's an individual piece of execution of a program. Let me just explain you what I mean. Let's say you have a Java program, and say you have instructions on downloading a file, and you have instructions that will do some math. Now both these sections of code are completely independent of each other. We don't want this section of code to wait for the file to get downloaded, because this section of code has nothing to do with file download. So what we can do is we can separate both these sections and run them as 2 different processes or sub-processes. In our example, if you were to write the source code for Microsoft Word, then you'd have 2 sections of code that will do both these tasks simultaneously. So you can think of thread as a sub-process when you run the program, whereas from programming perspective, it's an individual piece of execution of a program. So what is the actual purpose of multi-threading? Let's say you have a processor with 2 cores, and let's assume that you didn't program with multi-threading in mind. Now, if you run this program, this entire program will be run only on a single logical processor, while we keep the second processor idle. But whereas, if you code with multi-threading in mind, you would identify sections of code that are independent of each other, and you would run them separately. Your program will utilize both these processors, and each thread would run on each one of these logical processors. So that way, if it takes 10 seconds to run the program, with multi-threading, you would run it in only maybe 6 seconds. So the basic purpose of multi-threading is to make the most out of existing processors, and that's how we improve the performance. We're going to take a look at an example where I demonstrate you the utilization of the processor with multi-threading and without multi-threading. Now, since we're able to run multiple threads simultaneously with each thread on each one of this processor, this is called thread-based multitasking or multi-threading. Hope that makes sense. See you in my next video. In this video, we're going to take a look at how we can create a thread on our own. For this purpose, please import the project multi-threading into your workspace and open up this file, main thread example. All I'm doing here is I'm just throwing a simple exception, which is null pointer exception, and the reason why I'm doing so is because to demonstrate you that so far, although we haven't explicitly created threads on our own, JVM has done that for us. By default, JVM will create a thread called main, and that's the reason whenever you have an exception, you would see a message that starts with an exception in thread main. Let me just show you what I mean. Exception in thread main. That's because JVM has created a thread which is main thread. Now let's see how we can create threads on our own, a separate piece of execution of a program. In this example, I'm doing something in here, and I'm also taking the time when the program starts and the time when the program ends, and ultimately I'm calculating the difference between both the time just to see how much time it takes to run this program. In here I have a couple of for loops which are very similar, and what I'm doing here is I'm trying to do some math that would ultimately utilize the CPU. So doing this math is quite CPU demanding operation, and that's exactly what I wanted. Let me run this program, and it's going to take quite a lot of time. Maybe I'll just pause the video and come back again. So it took a total of 76,000 milliseconds, which is, when converted, it's 76 seconds. Now let's see if we can improve the execution time by using multi-threading. Now just by looking at this code, I could identify two sections of code which are completely independent of each other, and I think we can run simultaneously. Can you identify those two sections? It's simple. These two sections are exactly identical, so that means we can perform these two sections simultaneously or concurrently. Let's see how we can achieve that. There are two ways to achieve that. One, by implementing a runnable interface. This is just a plain class file, and all I'm going to do here is I'm going to implements runnable. Now by doing so, I'll be forced to add all the unimplemented methods. The runnable interface has only one method defined, which is with the name run. This is the method where all the magic happens. All you want to do here is you want to insert the code that you want to be part of as a separate process, or whatever I'm saying as the individual piece of execution of program, you want it to be here. In this case, it's going to be this. Let's do Control C and Control V. Pretty well and good. Let's also track the time. I'm going to take the start time and the end time, and ultimately I'll find the difference between the two. But before the start time and end time, I need to do something. Somehow I need to create a new thread and run this set of instructions twice. And for that, I have to create two threads that run simultaneously, and both the threads will ultimately run the same piece of code. The reason why I'm running the same piece of code is because that's exactly what we're doing here. We have same piece of code running twice. In this case, this code will have to wait until this finishes. But in this example, I'm going to do them concurrently or simultaneously, and that can improve the overall time of execution. Let's see if that's the case. So I'm going to create an object of a thread class. I'm going to call it t1 equals new thread. Pretty well and good. I need to create another thread. Let's call it t2. Save the file. In order to start the execution, we're going to say t1.start and t2.start. In our next video, we'll understand what this start method exactly does. But for now, you can think of this as this will actually initiate the execution of the thread, basically execution of whatever the code that you have inside this run method. But here we are lacking something. This thread is not aware of this code in the run method. The way we convey that is we need to create an object of the class where the run method is implemented, new runnable example, and we're going to pass this object to the constructor of the thread class. That's all there is to it. Now what we have exactly done here is we sort of created a couple of threads and we have initiated them, and these two threads will now run simultaneously. But we have a problem with the timer here, because as I said, the main itself is treated as another thread. So although we have explicitly created two threads in here, we've actually have three threads in here, because one is the main thread. So if you run this program, while these two threads are going on, our main thread finishes and it prints the time. We don't want that. What we want to make sure is that only when these two threads are not actively running do we want to go ahead with the rest of the instructions. So for that, we're going to use the method called isAlive. I'm going to use while loop t1.isAlive or t2.isAlive. So in our main thread, we always continuously check to see if either of these two threads are alive. If they're alive, then just keep looping. And once these two threads come to a dead state, which we'll talk about in our next video, that means we're done with execution of these threads, then the isAlive state will return false. When both of these are false, then we'll exit out of this loop and would ultimately calculate the end time and would print the total time. Now let's see if there is any improvement in the time. Let's run the program. Again, I'm going to pause the video and we'll get back. Here it is. While it took 75 seconds or so without multi-threading, with multi-threading it just took over 38 seconds. It's almost half the time, and that's exactly the beauty of using multi-threading. Let us take a look at another approach where you can create multiple threads. You can create threads either by using runnable interface or directly extending the class thread, which I have done here. In fact, you're going to have exact same code in here. Let's do Control-C and Control-V. Going to have exact same code in here, and instead of implements runnable, you're going to say extends thread class. Let's change the name of the class name to thread class example. Now this time you don't have to pass in the object. In fact, you don't even have to create a new thread object. Let's delete it. Instead, you can use object of the same class to call the start method. The reason is we have already inherited all the properties and behavior of the thread class. Of course, this name needs to be changed to thread class example. And if you want to create another thread, then you can just create another object. Let's call this object 1 and object 2. I'm going to start the thread of object 1 and I'm going to start the thread of object 2. Same thing goes in here. Let's run the program and you would pretty much get the same output what we have got in our runnable example. Let me pause the video. There it is. It just took 38 seconds. So which approach should you follow? Should you implement the runnable interface or extend the thread class? I would recommend you to always go ahead with implementing runnable interface. One good reason for that is if you use an interface, you still have the possibility of extending another class. In this case, since you have already extended a class, which is the thread class, you cannot extend any other class because Java does not support multiple inheritance. Also, in terms of good design practices, it's always recommended that you use runnable interface. We'll see why in our examples pretty soon. Now, talking about the CPU utilization, I said when we use multi-threading, we would improve the utilization of the CPU. Let's see if we are right. And for this purpose, I have opened the task manager for Windows. I'm not sure what it is for Mac users. So this is the current graph of the CPU utilization. Let me run the program without using the multi-threading and see how the CPU spike looks. The utilization is around 39%, 38%, and it's going to remain same for 75 seconds or so. Let me pause the video. So this is how it looks. The CPU utilization is fluctuating between 31 to 39 and is kind of stable in that range. Now let's see the CPU utilization when we use the multi-threading. Let's run this program and go to Task Manager. Take a look at that. The utilization has increased to 67%, 68%. It's fluctuating somewhere around there. Let me just pause the video and get back. That's it. We're done. So we got maximum utilization of CPU when we've used multi-threading. That's because each one of these threads would run on individual processor cores. Alright, let's continue in our next video. Alright, let's continue. Now this is not the best example I could demonstrate. In this example I have exact similar code in two places, but most often this could be two different operations but are still independent. Let's say I want to get rid of one of the 0 in here. Ultimately, the point I want to make here is these two are two different operations but are still independent. Maybe you would want to do download of a file here and you're doing something completely independent, which is, say, you're reading some text from a stream or whatever. For this example, I just excluded another 0 just to make sure these two are two different operations, or maybe I just play around with these numbers, maybe say 4, 4, 5, 5, whatever. Now let me just copy this file and create another file. Let's call this with the same name, appended with number 2, and for your reference I'm undoing all the changes. Let's close this file. Let me open this file. Now I have identified two sections that are independent. How do I multi-thread them? I'm going to use the same class, but this time I'm going to create two of them. In one, I'm going to copy this section of code and paste it in the run method, and in another I'll have the other independent code just like so. And all I want to have here in these two classes is just the code that I want to multi-thread. I'm going to get rid of all this public static void main and stuff like that. In fact, I'm going to do Control X. Let's create a new class file. Let's call this some name, whatever the name that you want to give, and I'll paste in the code in here. I'm going to create one object of this class and another object of this class. Let's call this object 1, and object 2 is supposed to go in here. There it is. Let's try to run the program. Let me pause the video and get back. Here it is. From design perspective, if you use the thread class, extends thread, then you're sort of encouraging the developers to extend the behavior of this class and play with it, which is definitely bad practice. But whereas if you implement runnable interface, then it would sort of signify the developers that they're not supposed to do anything other than what you want to multi-thread. Which means in this class we only want that independent piece of code that we want to execute as a separate thread. So always it's better that you use implements runnable than extends thread, and you can have as many classes as you want that implements runnable, and each one of those classes perform a separate independent task. Hope that makes sense. Now let's talk about call stack. We know what call stack is, and every time we get an exception, we get the call stack from the method where the exception originated to the main method. The reason is that call stack is specific to main thread. Similarly, when we create our own threads, a separate call stack would be created. So now whenever we have an exception in one of these threads, let me just explicitly throw an exception in here. Throw new null pointer exception, and if you run the program, okay, looks like we need to have it at the end. Let's run the program. This time, again, a lot of wait time. It says exception in thread 0. That's the name thread scheduler named the thread. We'll talk about thread scheduler in our next video. But that's it. That's all I wanted to talk about in this video. See you in my next video where we'll talk about thread lifecycle. In this video, we're going to take a look at the thread lifecycle. If you run the multi-threading example we've seen in our previous video, this is exactly what's going to happen. When the interpreter comes across with the line new thread, we're creating a new object. So that will essentially create a new thread. And when we call the start method, the thread will go into a state called runnable. What this means is a component called thread scheduler can now schedule a task to run this thread by calling the run method of that object. Talking about the thread scheduler, a thread scheduler is a component that is not completely part of either operating system or the Java virtual machine. It's a combination of both. Ultimately, the job of thread scheduler is to manage all the threads in the thread pool. So once the thread comes into runnable state, the thread scheduler can now ask the processor to process instructions inside the run method of that thread. Once it does so, the thread will come into a state called running. And there are three possible state changes when the thread is in running state. One is dead, meaning all the instructions inside the run method were successfully executed, and now the state of the thread is dead. That means it's no longer there. Or there could be possibility that a running thread can get into a state called blocked or waiting. A thread can change its state from running to blocked when it is waiting for a resource, for example, a file. And that's the reason why it is important that you close the file stream once you're done with it, because there could be n number of threads which might be needing the same resource. So until the resource gets freed, the thread will be in blocked state. A thread can also get into a waiting state when it is waiting for other priority threads to finish executing. We'll talk about thread priorities at a later point of time. And a thread which is in running state can go back to runnable state depending on time slices of the processor. And a thread which is either blocked or in waiting state can go back to runnable state once the resource for which it is waiting for is freed, or after all the priority threads came to the dead state. So that's how the life cycle of thread works. It's as simple as that. See you in my next video. In this video, we're going to talk about anonymous inner classes and see how we can improve our multi-threading code using them. Take a look at this example. I've just created an object of class dog, which is having a method called bark, and that just prints the message barking. And in here, we're just calling that method. If you run this program, you would obviously see this message. But let's say I wanted to override the method, override the behavior of this dog right here, only for this time. So as you can guess, for that I need to create a new class. Let's call it dog extended, and I'm going to use the keyword extends dog, and I'm going to give a different behavior. Now if I run this program, you would still see the same message, but if we have the parent class reference type and make it point to the child class object, now the behavior is going to change because of the polymorphism. Now if you take a note, this is the only time I wanted the behavior to be overridden. And even though if it is just one time I wanted to override the behavior, I still have to create another class and override the method. This is quite a tedious job. Fortunately in Java, we can override the method then and there itself wherever we wanted to attain a different behavior. And we can do so by using anonymous classes. An anonymous class is just as a local class that is local to a method, except it does not have any name to it. So what that means is we can use this entire block without copying the name of the class and have it in here. Let's comment these two lines. This has created an anonymous class, but we have a problem. We also need to tell the compiler for which class are we overriding the behavior. So we need to tell the compiler the parent class of this. And the way we convey the compiler the same is by using this statement like so, and we need to end with a semicolon. Although this statement looks like we have created an object of the dog class, actually it's not the case. We have actually created an instance of the anonymous class that does not have any name, and that anonymous class is actually the child class of the dog class. And we're assigning that object to the reference type of the parent object, which is the dog class. If it sounds confusing, go back and listen to my statement again. But whereas if you get rid of these curly braces, this is a different story. This is like you have a reference type of dog and you're pointing to the dog object. But if you have curly braces and you have overridden method like this, then what this means is you have actually created an anonymous class that does not have any name, and you have overridden the method of the dog class, which in this case is bark. Now you can use this object to call the bark method, and we get the result of the overridden method. Let's run the program. There it is. So now we can easily get rid of this class dog extended altogether. So that's the beauty of anonymous classes. In fact, since this is the only time you're calling the bark method, you can actually get rid of the reference type in here and just call the method bark directly, like so, and it will still print the same. Now, why am I explaining this? Let's see how we can improve our multi-threading code. Now see, I have created a new class which is runnable int example 4.java, and I have the exact code as to that of what we had in our other runnable examples. And in our anonymous class example, I've created an object of this class, and I'm passing that object to constructor of thread, thereby we are creating a thread. Now, this is the only place where I want the method of that interface runnable to be overridden. Why should I create a new class for that purpose? So what can I do? I can certainly make use of anonymous classes. I'll copy this code from here and let me get rid of this. And paste it over here. This will create an anonymous class, but compiler will expect us to tell for which class we have overridden this method. In this case, it's runnable. Runnable, new, runnable. Let's end with a semicolon. And now we can pass this object to the thread, and everything works perfect. And we can now certainly get rid of this class in here. Let's run it. There you have it. Now let's try to make this code a lot cleaner. I'm going to move this entire functionality to a method. We'll call it public static sum method, and I'm going to paste the code in here. Of course, we're going to have the return type, and I'll call that method from here. Now if you take a note, the constructor of the thread class is going to take the object of the class that implements runnable. So instead of passing the object, I'll straight away create the object right there. There is no problem or whatsoever. Let's get rid of this semicolon. Now there are two things that are very obvious to the compiler. Compiler is aware the kind of object that we are passing to this thread constructor. The compiler is also aware that the only method that we can possibly override is the run method. With Java 1.8, with the introduction of lambda expressions, we can now get rid of all these unnecessary details that the compiler is aware of. So we can get rid of this object declaration here and the ending curly brace. We can also get rid of this method definition, including the keyword override. Now this is pretty well and good. We can get rid of the semicolon from here. The only thing that the compiler wants us to specify is number of parameters that we are passing to the method sumMath. In this case, there are none. So we need to tell the compiler by using the Java 8 lambda expression, like so. We have dedicated an entire chapter talking about Java 1.8 features. Until that point, you don't have to invest too much time in understanding Java 1.8 features. Just try to understand what I'm doing here. Now there is one more improvement we can do. We can get rid of this reference type in here and directly call that method start. This will do everything. Isn't that wonderful? We have significantly reduced the lines of code, and we haven't created another class implementing the runnable interface. That's the beauty of lambda expressions. Now again, we'll talk about lambda expressions and all the Java 1.8 features at later chapter. Now in future, let's say you wanted to create another thread. All you have to do is Ctrl C and Ctrl V. Give this a different name, some new, and we're going to provide the behavior. For the sake of example, I'm just copying the same code, but make sure you do some task in here, you do some other task in here, and both these two tasks should be independent of each other. So now by using anonymous classes and lambda expressions, we have significantly improved the readability and the maintainability of the code. Of course, at a first glance, the lambda expression might look confusing, but once you're used to it, you will learn the comfort of using it. Alright, one last thing that I wanted to tell you is this lambda expression is only applicable when you have an interface that has exactly one method. Talking about the runnable interface, it just has one method, which is with the name run. And that's why we're able to make use of the lambda expressions. And these kind of interfaces with just one method are called functional interfaces, which were introduced in Java 1.8 specifically for usage with the lambda expressions. Let me just show you a quick example of a functional interface. Let me create a new interface. And let's have one method defined, void some name. In order to make this interface a functional interface, you can use the annotation functional interface. And that way, if you try to create another method, if you try to define another method, that's going to show us an error saying invalid functional interface annotation. This example is not a functional interface. So the developer cannot add another method accidentally, because we might be using this interface in our lambda expressions throughout our project. Hope that makes sense. See you in my next video.